welcome to the fundamental course on Python. This course is aimed at anyone who wants to get a good foot into the basics of Python. So let's get started with what the course has to offer, covering sections such as loops, conditional statements, data structures, operators, file handling, modules, packages and libraries, functions, object-oriented programming, and so on. And it also extends into some key areas outside of just pure coding, such as setting up an IDE to write your code in, setting up virtual environments, also looking at Python's best practices, and Python's role in AI, that's artificial intelligence. So Python is a very popular programming language used across industries, and it's used in areas such as for web development, data science, again artificial intelligence, and automation, to name a few of the main ones. And you can see the full end-to-end content of the course is on the right hand side. I forgot to mention Git as well, Git for version control, and GitHub for that matter. Git is used for version control, and version control in programming is absolutely essential. It's very important that you have backups of different versions of your code so that you can revert back to in case you have any issues. And GitHub is used for collaboration. It's a public hosting repository for code, so a team of developers can work together on the same project from anywhere in the world. They can access the same content with just having an internet connection, enabling them to collaborate together. And Python is a favorite programming language due to its simplicity and readability, because Python's syntax is beginner friendly and easy to understand, making it an ideal programming language. It has a vast ecosystem, so a huge array of libraries and frameworks tailored for many of the fields, and it has a large community support. So there's an active Python community that provides tutorial, resources and solutions to almost any problem, so you will not feel isolated. There's plenty of help out there for Python. It has cross-platform compatibility, so Python works seamlessly on Windows, macOS and Linux operating systems. And finally, the course will set you up to advance in Python and directly covers all of the requirements for a popular exam known as PCEP, that's Certified Entry-Level Python Programmer, offered by Python Institute. And everything you need to cover off for the PCEP certification is covered in the contents of this Python course. So PCEP is an excellent match for this Python course, but it's not the only one. This course will give you a good grounding for many other certifications, such as PCAP, Certified Associate in Python Programming. This is another certification by Python Institute and is more advanced than PCEP, and it covers object-oriented programming, file handling, exceptions and modular programming, which are some of the content for that certification this course covers. And another course the content will help you prepare for is Google IT Automation with Python Professional Certificate. So that's enough of me as per the introduction on Python. Let's dive straight into the course by installing Python and Python's default code editor, idle. Welcome back. In this video we will have a look at how to download and install Python on a Windows workstation. And to verify if you have Python installed on your Windows machine, you can go to the command prompt, and if we type Python --version, usually it would come back and tell us the version of Python installed, but it's not recognizing it because Python is not installed on this Windows machine. We can also type Python, and again it's not recognizing that Python is installed on this Windows operating system. And there's a couple of ways you can install Python. The first one is by going to the website, so it's at www.python.org. You can download the latest version from here and install it, or you can install it from your Microsoft Store. If we open up the Microsoft Store, and we can do a search for it, and the latest version at the minute is Python.3.11. So let's click on 3.11. Alternatively, if we go to the Python website, and it tells us the latest version here, Python.3.11.3. We can also go to downloads to have a look at what's available in downloads, and we can see it's available for Windows, macOS and other platforms as well. And we can download specific releases from here. Let's do this one here, download Python 3.11.3, and we can see it downloading on the right hand side of the browser. Now it's completed. Let's click on it and attempt to install it. By the way, the macOS and the Linux operating systems come with Python installed, but if you're running it on Windows like me, you would need to install it. And we get the installation wizard. We've got custom installation as well, we will have a look at. But when installing Python, it's good to check this tick box here, add python.exe to path, which lets you access Python shell from the command prompt as well. So it's good to tick this box. Let's have a look at the custom installation. And if we click on custom installation, we can see what it will install for us. So the top one is the documentation. Next one is pip, and pip is used to download and install other Python packages. Next is idle. Idle is a code editor, and you need a code editor, which is a tool that is used to write and edit your code. Idle is the default one that comes with Python. And idle within itself is coded using Python, and it uses the tkinter GUI toolkit. Then we have the Python test suite, which installs the standard library test suite, and it comes with the PyLauncher. The PyLauncher for Windows is a utility which helps in locating and executing different Python versions. And we will install all of these, so let's click on next. And we've got some advanced options here. For example, Python files end in a .py, so it's saying associate the files with Python, and a few other options down here, but the only one from here I'm going to make a change on is this install Python 3.11 for all users. And we can see the custom install location. You can change this if required. Let's click on install and install Python for Windows. Python has been installed, and we can see it says you can read some online tutorial and documentation, and it tells you how to start Python as well, and you can see what's new in this release. But this time round, if we open up the command prompt again and let's type Python -- version, and this time we get the Python version, Python 3.11.3. we can also type Python. And when typing Python in the command prompt, we see the 3 greater than signs, and this indicates we are in Python, or also known as the interactive interpreter or interactive mode, or the interactive shell or the shell. But we are going to open up the idle to have a look at this bit in there as well. So the way we exit this is we type exit, open and close bracket, enter. So the idle is the default program that comes with Python. Hopefully if we type it in here, we should be able to see it. Of course, you can go to programs and features and see it in there as well to verify it's installed. And this is the default program, but you don't have to use this. You can instead use another application like PyCharm or Visual Studio Code, which are very popular code editors. And I will be going through a high-level overview of PyCharm and Visual Studio Code in the next videos. And this is the idle shell, and we can expand this. So idle stands for Integrated Development and Learning Environment, and it's an application bundled with the default implementation of the Python language. And idle has 2 main window types. This one, which is the shell window, and there's also the editor window, which we will also have a look at. It's not the most feature-rich program, but it gives you simplicity and ease of use. And right now we can see the 3 greater than sign. So this is like the command prompt, and again it's called the interactive shell. So in here we can see the results as we type. Another way to use the shell is the command prompt. So for example, if I type print, open bracket, and type my name, close it, enter, and we will see the result under it, which has printed my name. Let's do 2 times 3. And it's printed out the result, which is 6. Or we can type something like x equals 2, and then do x plus 5. Enter. And because x equals 2, x plus 5 is 7. And notice white spaces don't matter, so I can do x times 5 with spaces, and it tells us the result is 10. But as you can see in the first one, I did not put any white spaces, and the second one I did, so they don't matter. And we can also play around with Boolean expressions and many other things as well. So let's do 3 greater than 2, enter, and it tells us that is true because 3 is greater than 2. We can do 2 equals 3, and 2 does not equal 3, so it should come back as false, which it has done. And we would use the shell to start interacting with Python immediately and testing it out with some code. But you wouldn't typically use the shell when you are writing Python files, multi-line codes. And unlike the shell, you cannot run these commands when working with Python files. When using the actual Python files where you build your code and then you save the files, you would instead have to declare your values with variables, such as x equals 3, and then print the value of 3. And we would have to run it and then see the results. So the standard way of writing code, we would create a new file. So let's go to new file, and we would have to save it as well. So file, save as. And you would always save your files with a .py extension. And we will call it first file.py and then save it. So here we can start to write our code again, and we can see suggestions. It gives us guidance to complete our code. So let's type hi all. And at the top we have some options. So we've got the file, save as, etc. We've got some options for modules here. You've got edit, you've got some things in edit, such as finding and replacing things in your code. Then we've got format, so we can format the paragraph or indent the region. So for example, if I select this code and then go to format, we can indent it. You can see it's indented it to the right hand side, or we can dedent region, bring it back. And there's other formatting options down here. Then we've got run, which will run our code. Let's do this. Run module. Source must be saved. Your file must be saved, so let's click OK to save it. And we can see at the bottom here it's printed out our code. Hi all. Going back to the Python file, we have options where we can configure various things. Configure idle. So we can configure our font size from here, our highlights, change the color of things where it highlights things. We can configure our key shortcuts. So we've got lots of shortcuts here. We can configure those. Then we've got the Windows shell and extensions as well. And finally, on the right hand side here, we've got Windows. So we can see the windows we have open. For example, the idle shell and our first Python file. And then finally, we've got the usual help where you can read more about idle, and you can go to idle documentation and learn more about the idle application itself. And that's it. That's a high level overview of idle. In the next videos, we will have a look at PyCharm and Visual Studio Code. In this video, we will have a look at PyCharm, which is a very popular code editor, or more commonly known as an IDE, Integrated Development Environment. PyCharm is a very popular and cross-platform IDE which supports Windows, macOS and Linux operating systems. There are 2 versions of PyCharm. One is the open source version called Community, and another one which has more features called Professional. The Professional one is a paid version, and it's a fully featured IDE with support for web development features. And actually, if we go to the second tab here, compare PyCharm Community Edition versus PyCharm Pro, we can see the features both editions support. So we can see the languages, and we can see here PyCharm Pro supports SQL. Both of them support HTML. But down here there's a few more, such as JavaScript, CSS, etc. So you get more languages with PyCharm Pro. And then there's more in terms of framework support. So PyCharm Community only gives you the PyQt, where PyCharm Pro supports lots more in terms of frameworks. And these are the rest of the features both versions support. The community version is free and open source, and it's a good lightweight editor, and it's more than enough for pure play Python use, and in particular for network engineers, so that's what I will be downloading and installing. Now, because we already have Python installed from our earlier video, PyCharm will automatically detect Python has been installed when we attempt to install PyCharm. let's go to the main page of jetbrains.com website where we download and install PyCharm, and let's click on download. And it does the same thing, it brings us to the different editions and you can choose which operating system you want to install it on, Windows, Mac OS or Linux. Professional version is here and we will download the community version. And once we have downloaded it, we can go ahead and install PyCharm. So let's click yes here. Welcome to PyCharm community. Let's click next. And we will stick to the default destination folder. So let's click next again. And here we have some options, and to allow Python to run from a Windows terminal, we will tick this box here, add bin folder to the path. And this enables PyCharm to run from the console without having to specify the path to it. Let's create a desktop shortcut. And we can also associate .py files with PyCharm, especially if this is your Python editor of choice. And that's pretty much it from here and the options. Let's click next and we will install PyCharm. PyCharm has now been installed. Let's reboot it and then we will have a look at the application. Windows has rebooted and we can see a shortcut to PyCharm community. So let's open this and take a look. The first thing we want to do is confirm that we accept the terms of this user agreement and click continue. And then you get your data sharing, so do whatever you want to do from here. I will click on don't send. Right, so this is PyCharm. Let's maximize it and we can see on the left we've got projects, customize plugins, learn. We can do a quick tour from here, or we can click on create a new project, open a project, or get from VCS, which is version control. We don't have anything to open, so let's click on create a new project. And if you have been following the videos, you can see we installed Python 3.11 earlier. So it's automatically detected Python 3.11 has been installed on this Windows machine, as we can see here in the base interpreter. But you are free to change this if you have more than one Python version installed from here. I only have the one version, so it's only giving me the single option here. And then above we can specify the location and the name of the project. So let's leave it at default. Python project will do for me. And because we have this ticked at the bottom here, create a main.py welcome script. It will create a main.py welcome script where we are able to run and test it's all working. So this looks all good. And from here we can click on create down here on the bottom right. And it goes away and starts to create our virtual project. And it's created our Python project here on the left hand side. We can see Python project. If you click on the arrow, we can see our virtual environment. And here we can see our main.py script has been created as well. And you may have seen some recommendations on the bottom right hand side here. So they are always good to follow as well. Let's maximize the screen and we can see this is a sample Python script. And we can run this to test it, but let's also change it around. Let's call it test my script. And at the bottom left, we can see some other options: Python console, Python packages, services, terminal. So if we click on terminal, it will open up the terminal for us, which in our case is the Windows PowerShell. And here we can type Python. You have to type Python and then main.py, which is our file. Enter. And we can see here it shows us hi, test my script. So it's run the file. But of course, the better way of doing that is you have the green play button on the top right here, run main. So if we click on this instead, it will run the file for us. And we can see it's done the same thing on the bottom left here. Another way of doing this, you can also right click in an empty area on the code in the file and you can run main from here as well. And this is all providing it's got a configuration file from here. So this is where it's all reading it from. Run debug configuration. We can go into here. We can have a look at this. Click on edit configuration and we can see it in here. So this is what we had created at the beginning. You can remove it as well by clicking on the minus sign here. Remove configuration. Clicking apply. Click OK. And you can add it again from here. Edit configuration. And click on the plus sign. Python configuration, let's call it main. And you have some options here. So again, it's specified the interpreter, which is 3.11. Let's click on apply. Let's have a look at the other settings so you can see the other settings down here. We will stick with the defaults. Let's click on apply and OK. And And it's got our configuration again here. So that's how we would run our test script, or any script for that matter. But on the left hand side here, again, we've got our folder, our Python project. And you can right click the project folder to do a number of things, like creating a new file. So let's create a new file. And it doesn't just have to be Python files, it can just be a standard file, like a text file. If you're creating a Python file, you can just go to create a new Python file. Maybe if you're creating another file, like a text file, you can create a text file from here, notes.txt. Hit enter on that. And we can see it here appear in our Python project, the note.txt file. And now we can see the tabs, both files appear here. We can also drag these around as well. So you can drag the notes below the main. Well, let's put it across. I'm pretty sure you can also drag it below as well, like that. And then I might want to add some notes to finish off my code from line 17. That sort of thing. And of course, when you right click, you've got many other options as well in here. Like maybe you want to open it up in Explorer. You may want to physically see the file. And if we do that, we can see our Python project in Windows Explorer from here. Or maybe you want to have a look at the local history, show history. And within Python project, it shows us all of the history that has occurred. And it shows it in the last 12 hours over here. Let's cross this off. And the Python project folder is our folder structure. So this is how our Python files are organized. You can make subfolders and put your Python projects into subfolders. Maybe for different Python projects, you can break it all down like this. So all your Python files are organized into different folders. And if we create another file, let's right click here. Let's create a new Python file. Let's call it first py file and click enter. And now we can see our file is created here. And we can write some code. Age equals 25. Print age. And you can see PyCharm gives us suggestions to finish off the code. Let's press enter here. And if you notice on the left, it's got line numbers as well, 1, 2, and 3. And if we right click, we can run it from here. First py file, select that one. And at the bottom, we can see it's ran the file. Now we have seen where we open up the terminal from down here. But there's also the Python console, which is good for experimenting with. And with the Python console, you can test your commands from here and debug things. And this is similar to the interactive shell with idle. Idle is the default application when you install Python. And this is in one of my previous videos if you wanted to go back to it and watch it. Let's get rid of this Windows Firewall notification. Allow access. And then here we can see, just like the interactive shell of idle, the other application, the other code editor, the default one that comes with Python. And we can see the 3 greater than signs here. So we can do things from here like 5 times 5 and it would give us the result straight away, or some kind of Boolean result. 2 is greater than 3 and it will tell us it's false. Print something and it would print it out for us. So this is really good for when you are debugging or you just need to do some quick experiments, and you would use this. You can basically test some of your commands from here to make sure they work. And as we have seen with writing code, it helps you finish off code. So if we type PR, it's determining what we would finish this off as. Python helps you with the autofill feature and it determines what you want to type. So with PR, it guesses we want to type the print function here. And it's color coded as well, as we can see in the top script. For example, strings are in green. It's even given us a suggestion to say it's a typo. Replace with TypeScript. So it's giving us suggestions all over the place, and then we can see comments are in grey. There is a lot of good features with PyCharm, but one of them is the to-do list, and you can remind yourself of anything you need to finish off. So for example, I can come over here, and the way we write comments is using a hash, and then you would type to do. And let's put in our note to remind ourselves to finish something off. Let's go with import request module, press enter. Now as soon as we have done that, we've got a to-do list here. On the bottom left, We're in the Python console at the minute, but we can click on the to-do list and it's found one already. So we break this down. We can see in Python project, in the first pyfile.py, on line number 3 and indented 10 across. So line number 3 indented 10 across, basically 10 spaces across. There's a reminder to do import request module. We can do another one. Hash again to do. Let's go with install netmiko and paramiko for network automation tasks. Enter. And again, we can see down here, it's found it on line number 3, indented 3 across. So this is really good to remind ourselves of things we need to finish off within our code. And if you cannot find this option here, you go to the top here, the 3 dots here, you click on these, and here is where you would find more tools. Let's have a look at the plugins. You can install various plugins. If we go to these 4 lines here, which will show us the menu, and these are plugins for things like your themes or anything else. Let's go to settings here. Actually, while we are on this page, you can change your theme from here. So the theme is dark at the minute. We can change it from here. We can also download other themes as well. Here is our zoom in. We are zoomed in 100%, but you can zoom in further. And down here you've got key maps. So these are your keyboard shortcuts. And the key map it's chosen for us by default is Windows, because it knows it's a Windows operating system. But if you needed to change that, you've got a couple of other options here. And you can duplicate, let's say, a Windows key map and then change it to your preference. That way you can use your own customized key map of all your shortcuts. But going to plugins down here, we've got all our plugins. So the ones that are installed are on the right hand side here. These are the plugins that have already been installed. And then we have the marketplace, and this is where you can install some further plugins. For example, the presentation plugin. And this plugin helps us with shortcuts. So it says here, this plugin shows the name and shortcuts of any actions you invoke. So it's good to learn your shortcuts using this plugin. And actually, while we are on shortcuts, if I cancel here, I can do things over here. For example, Control A would select everything, Control X would cut it, Control Z undo, or maybe Control D, so I've selected that line, Control D to duplicate the line. And you get the idea. So a lot of these shortcuts are Windows shortcuts, like Control X for cutting things and Control Z for undoing your last action. And again, going over some of these options in here. So we've got File. In File we can create new files. We can open things and save everything as well. In Edit we can cut, copy and paste. Delete we can find. And of course there's many other options. In View we can put it into presentation mode. Enter presentation mode, for example. So it'll hide everything like this. Let's come out of this. View. Go back to appearances. Exit presentation mode. Or View for viewing recent files or recent locations and changes. You can increase and decrease the font sizes from here, but that's in settings as well. We've got Refactor. For example, renaming something so that it renames it everywhere across all your code, and that way your code still works. And you can move files or copy files without affecting any of your other code or any of your other files. We have Navigate if you want to navigate around, navigate in File, navigate across highlighted errors, search for classes, file symbols. Then we've got Code, inspect our code from here, analyze code, and lots of other options inside code. We've also got Run to run our file or debug our file. We've got Tools over here. So these are more tools that come with PyCharm. VCS for version control, where we can share the project on GitHub or Space. Window to see the multiple windows we've got open, and Help as well. And this find action is quite good. So if we type in Git, share the project on GitHub here, we can just search for it in there when we don't know where the option is. And it doesn't have to be everything. It can be for specific classes. You can narrow it down to classes, files, symbols, and actions. Let's type something else. Python. Python console, Python packages. Maybe font size. increase font size, decrease font size, reset the font size. So you could imagine how useful this would be when you are looking for something and you don't know where the option is. But this is not the only way to find things. You might be searching for something within your code, so you can do that with the Control and F, and then you can search for anything within your code. So let's go for age, and then just like any Windows Word or Notepad program, it will show us all references to our age, and we can do Control R, and you would probably guess what this does. Replaces everything. So you can see the top line is for find and the bottom line is for replace, and you've got the options here: replace, replace all, or exclude. So this is when you are looking in a specific file for something. And we have version control down here, so we can track changes to our codes. And PyCharm supports version control at two levels. One is at the IDE level. VCS integration is provided through a set of bundled plugins enabled by default. And then the other one is at the project level, where VCS integration is enabled by associating project folders with one or several version control systems. And last but not least, at the top right here, we've got our notifications. It's giving us some suggestions up here, and then down here it's giving us a timeline of what's occurred. And over here is where you can invite someone, invite others to your IDE, or join another IDE to work together on a project. Here is that search function that we used in help menu. So you've got a shortcut of it here. So if I click it, it's the same thing. So it's just a quicker way of accessing the search function. And then we've got IDE and project settings here as well. So rather than going into file settings, appearances and plugins, you've got the shortcut here, because plugins is probably one of the main features we access using PyCharm. Themes and keyboard shortcuts as well. In this video, we will take a look at variables and data types. Variables are an absolute fundamental part of programming and an easy concept to understand. So let's get straight into it. What is a variable? A variable is a way of storing a value, and you can see it as a container which holds that information. And then we can use these variables that hold values in our Python scripts. And technically speaking, it's a reserved memory location for that value. And the way we write a variable is, by the way, in this demo, I'm using idle, which is Python's default application for writing Python scripts. I'm going to put hash here to state that the first line is a comment, but a variable equals a value, such as, well, let's go with age, and let's go with age equals 25. Now to print this, we type print, which is a function which I'll get to later on in the videos, and then open bracket age, which is our variable, close bracket. To print it, I would save this file and then go to run module. And the result has popped up on my other screen, which I can drag across. And now we can see it's printed out the value of 25. And the print is actually a function which we will take a look at later, but its job is to print something to the screen. And what we want to print is inside the open and the closed brackets here, age. The name of the variable is like a label, and then we will assign the label to a value. And wherever we use the label, Python will assign the value of the label. Now this value of 25 is a number, a numeric value, and to be precise, it's an integer value. But there's more data types, and that's what we will cover off now. And here are a few of the different types of data types we're able to use with our variables. And the first one is a string called myString. String variables are used to store sequences of characters such as words or phrases, text data such as names, addresses, or any other type of text. A string is one or more characters, and you put a string inside of quotes, as we have done here. So we've got the double quotes to open the string and double quotes at the end to close the string. And a string can have letters, numbers, or special characters inside of these quotes. And by the way, quotes can be double or single quotes. And an example of why you would use double quotes is if you're using single quotes within the string itself, as we have done right here. For example, I wanted to use an apostrophe or quote to form a possessive noun, so when it belongs to someone. such as this is Jaffa string 12345 exclamation mark. And we can see I've used the apostrophe as part of my name over here. So often programmers use single quotes, but in this case you can use double quotes instead to open and close the string. There are more rules about quotes, but that's the basics of it. The next two are numeric values. My integer equals 25 and my underscore float equals 1.5. So you may know these as numbers or numeric types. And with numbers, you don't need quotes. You can assign numeric values to variables without the quotes. Because if you put them inside quotes, then that would be classed as a string and you would not be able to perform maths on a string. Well, actually, you can perform maths on strings, but you would get a different type of output than the one you was hoping for, which I will demo shortly. So if we actually need Python to read the actual numbers, the numeric values, and use it to calculate something as a numeric value, then we would need the numeric value to be identified as a numeric value, a number, and not a string. So no quotes needed here. And we can break numeric values into multiple types. We've got two types over here, which is the integer, which is a whole number, and then we have a float. And this is a decimal value, such as 1.5. Next, we have Boolean. And Boolean values are either true or false and can be assigned to a variable as well. And notice the true statement with Boolean as well as a false statement has to be capitalized, or else it would produce an error. And Boolean is usually used if a certain condition is either true or false. Let's have a quick demonstration of Boolean values from the interactive Python shell. We have the interactive idle shell in front of us. If we do 5 is greater than 4, we can see the result is true. 5 equals 4, and we can see the result again is false. 5 equals 5, and we can see the Boolean result again is true. And later on in the video series I have an if then else statement video which explains Boolean values in a bit more depth. Next we have collections. There are 4 data types or collection types that are used to store collections of data, which are these over here, which means the storing of multiple items, and these are list, tuple, set and dictionary. And lists are created by using square brackets, and they are ordered, changeable and allow duplicate values. By ordered it means that the items have a defined order and that order will not change. So the order of these items inside this list will not change. And if we add new items to this list, the new items will be placed at the end of the list. By changeable it means we are able to change, add and remove items in a list after it has been created. So we can do that with lists. And by allowing duplicate values, it allows the duplicate values. And this is because lists are indexed. And here we can see the value London has been created twice, just to prove it allows for duplicate values. And we will test all this in our Python application very shortly. Tuples are written with round brackets, and tuples are ordered, unchangeable, so we cannot change, add or remove items after the tuple has been created. And tuples also allow duplicate values. And we can see, like lists, tuples can be of any data type, such as an integer, a float, and some string values here as well. Sets are written with these curly brackets, and they are unordered, unchangeable, and unindexed, and they do not allow duplicate values, so they are the most restrictive. With unchangeable, it means although you cannot change items, you can however add and remove new items. And the last one is dictionary, and dictionary is also created using the curly brackets as well, like the set, and they consist of key value pairs. So we can see the key, city, and the value of London. We can see these right across the dictionary. And dictionaries are ordered with a caveat. Prior to Python 3.7, they were not ordered, but since 3.7 and later versions, they are now ordered. And dictionaries are changeable, but do not allow duplicates. So they cannot have 2 items with the same key. And the values in a dictionary item can be of any data type as well, such as integers, strings, booleans, and even a list itself. So you can see a list here defined within the dictionary. So you can have a list inside a dictionary, as we can see over here. And just to summarize these collection types again, with list variables, they're used to store sequences of values such as a list of names or numbers. They can be modified by adding or removing items. Tuple variables are similar to list variables, but they are immutable, meaning they cannot be modified once they are created. Set variables are used to store unique collections of items. They are similar to lists, but do not allow duplicates. And dictionaries. Dictionary variables are used to store key value pairs. They are often used to represent data with a unique identifier or key, such as a person's name or an ID number. And it would be good to print all of this out. So what we can do is copy all of this code and print it out into our idle Python script to see the results. Now what we have here is our code. So it's the same code we just had a look at on the PowerPoint. But I've also added all of the print statements to print our code to the idle shell on the right hand side here. I've got a few extra as well. So I've got print hello. So this will literally print out the string hello. So it's not referring to a variable. And down here I have another 3 print functions. This print function has a function called length. It will specifically tell me the length of my tuple. And the next one down will tell me the type. Tell me the type of variable I'm using. So in this example, I'm asking what type of variable is my set variable. It should be set. And the third one down is querying what the type is for my float variable, which should be float. The print function here is specifically printing out the value of city. So this is the key, and I'm requesting it to print out the value of city, which should be London, in my dictionary key value pair. We can see city over here, and London is the value. And finally, the last 2 are arithmetic operations. We are performing on 2 different data types. The first is on an integer, my integer times 3. So this should be 25 times 3, which is 75. And the second one is on a string, just to prove that you can do arithmetic operations on strings as well. And we should see the results for both of these as well. Let's run the file. Run module, and on the right hand side we can see the results over here. So I've printed the hello string as indicated here. That's the first one, and then I've printed my string variable. This is Jaffa string 1 2 3 4 5 exclamation mark. I've printed out the integer and then the float, next the boolean value of true, and then these are my collection variables. We can see the first one, which is my list. Following on from that is my tuple. Then there is my set, and here is my dictionary. Next, I was asking for the length of my tuple, which is a function, which is the function length. And we can see it says 6 here. So if we count my tuple, we can see it's got six values. 1, 2, 3, 4, 5, 6. And the next 2, I was asking for the types. The data types used. One was of type set, and the next one is of type float. So we can confirm how Python has interpreted these data types. To make sure Python has interpreted them correctly, then it's pulling out the key, city, and the value for it, which is London. We can see over here, London. And the next 2 are arithmetic operations. So my integer times 3, which is 25, times 3 is 75, and then my string times 2, so it's printed out my string twice as well over here. And that's it for this video. That's a high level overview of Python variables and some of the different data types we can use with variables. Welcome back to another video on variables and strings. Some key points to take away on variables. The first one is variable names are case sensitive. So the words age and age with a capital A are 2 different variables. The next one down, the first letter of Boolean, true and false, need to be capitalized, as in the T and the F need to be uppercase, or else Python produces an error. Some words are reserved and cannot be used, and we will see these in the next slide. Variables cannot have special characters in them, just letters and numbers, and underscore can be used as well. So that's the exception. The underscore can be used as a special character, but no other special characters. And the last one is variables cannot start with a numeric value. They can have numeric values in them, but they cannot start with them. And there are some best practices with variables, and I follow these three in particular below. These are: with variables, use clear and meaningful names so you know what the variable is, i.e. not a equals 25, use age equals 25. So make sure it's meaningful, so when someone else is reading the Python program, they know exactly what that variable is. And you should use an underscore to separate multiple words to make the variable more readable, i.e. don't use my age all in one word, write my underscore age, which is a lot easier to read. And finally, be consistent with using capitalization, so either making the first word a capital or leaving them all small. I usually leave mine all small. So when I create my variables and I use them elsewhere, I know consistently I have them as all small and it's less prone to making errors. And here is a list of Python reserved keywords which cannot be used as variable names, or for that matter, they cannot be used for function names either, or anything that identifies something. Also notice that these are case sensitive if you happen to use any of these reserved words. Like we have just covered, true and false need to be capitalized, as we can see here, and the word none is capitalized as well, but everything else is in lowercase. Now covering off some additional things. Multiple line strings. With strings that span across multiple lines, we use 3 quotes, and they can be single or double quotes. For example, if you need to add a comment or a string over multiple lines, then we would type message equals. Then I can use my 3 quotes. I will go with 3 single quotes. And because this time I'm using PyCharm, it knows that I need another 3 quotes to end my multiple line string. So it's automatically put them in for me. Enter. You are logged in to a secure box. Only authorized users are permitted. Regards, admin team, and let's print the message. Print message. And there's a typo in my word authorized. So in UK, we spell it with an S, not a Z. I'm missing an R in there. And then we can run this. So we can go to run first PyFile, or on the right hand side here, I can just click on here, rerun first PyFile, or over here, run first PyFile. And now we can see our message over here. Now there's a couple of things with special characters. First, with strings, you can use single or double quotes to start and finish the string, and within the string itself, but also there's a special character, which is a backslash, which we can use to ignore the quotes within the string itself. Let's have a look at that. Now if we print a string, print, and I like to use single quotes, Jaffa's Python training. Now it's already got confused because I've used one here as well in my string itself. So I've got a quote here, and to complete my quote I need one at the end of the string. But because I've already used 2, one to start the string off and one within my string, I've confused it because it thinks this is the start of my string and this is the end of my string. And this is all meaningless. So if I put my quotes in here, it gives me 2 quotes to write another string. So what I can do instead is use a backslash to ignore this quote here. Backslash, and then remove this one. So what I'm saying here is this is the start of the string with this quote, and then I've got one to complete the string, because this backslash is telling Python to ignore whatever character comes after it. So if we run this, let's remove the previous stuff. So if we run this using the print, we need the open parenthesis as well and the closed parenthesis. And let's run the program. And we can now see my word with my quote inside there perfectly fine. Jaffa's Python training. But what if we wanted to use a backslash itself inside my string? In that case, we'll need to escape it with another backslash. Of course, this is if you're using a backslash in conjunction with a quote or a special character within a string, because a backslash is there to ignore quotes and double quotes or to use them with special characters like the small r. So let's say in this example we was typing in backslash and the small r, which usually means a carriage return. It's a special character. But let's say we was typing something like resources. Of course we would usually write it with a capital R, and that would bypass it altogether. But let's say we had to use a small r in this case, because the backslash is here, it's thinking of a carriage return. So what we'll do in this case, if we run the file, we can see it's giving us a strange output and it's excluded the R in resources. So what we'll do in this case is add another backslash, and that would ignore it. So this time it will treat the backslash as a standard backslash as part of the string itself. So let's run that again. And now we can see it's printed out my string perfectly fine. And just for completeness, there are common reasons why you would use a backslash within a string. You can use it to ignore the quotes and double quotes. You can use a double backslash if you want to use an actual backslash within a string, which we just saw. And a backslash can be used with a T for a tab, or a backslash R for carriage return, a backslash N for new line, or a backslash B for backspace. So these are the special characters a backslash can be used with. And like most things in Python, there are multiple ways of printing variables and strings to form sentences. Let's have a look at these. And if I wanted to print my name and say something, let's type name equals my name, age equals 40, and now we can print name, which is one variable, separated by a comma, which is a separate argument itself, is, again we want to separate it with a comma. Let's use our second variable, which is age, comma, years old. So this is my sentence I want to print. Let's run this, and we can see it's printed out my sentence. But there's also another way to do this. Let's type print again, name plus, this time we are using the plus operator to concatenate the variable name and the string is. We can do this in this instance because they are actually both strings. One's a variable referencing a string, and the is a string itself, comma, age, comma, and another string, years old. Now if we run this one, we can see there's a slight issue where it's printed out the sentence. However, when running this, it does not add a space between the variable name and the string is. So what we can do is add a space before the string is, like this, and run it again. And that has fixed the issue. And the reason for that is because each of these are separate arguments separated by a comma, which means it adds a space by default. And because name plus is joined together within the argument itself, separated by comma, it's using the separation between is and age and the separation between age and years old, but there's no separation here. So this is why we have had to add one manually. And now if for some reason you wanted to use multiple print statements to print the same sentences, like this, print my age is, and then again print age, print and I am based in the UK. So if we run this, let's remove the old statements, we would see this printed fine, but with a separate line for each of our statements. And now this is because if we go back to the print statements and if we click on them, there's a couple of arguments as part of the print statement. So one is set, which is string inserted between values, default a space, and set means put in a blank space. And this is the default after each argument, as we have just had a look at. And then there's end, string appended after the last value, default is new line, which means put in a new line after the print function, and this is also the default. So this explains why we did not have to put in a new line after each of these statements, because it does this for us by default. So the way we change this around, let's have a look at these statements first. The way they are written is sep with a colon and end equals backslash quote end quote. So this is how it looks by default. This means put in a new line. So if we copy this, and now if I paste this at the end of my statement, so if we paste it at the end of here, but let's take the n out for new line. So this time what we are saying, do not follow the defaults, end it without a new line. So there's no n in here, and let's do it again over here and remove the n again. Now if we run this, and of course we've got an error because I forgot to take the backslash out, and that's why it's red as well. So let's take the backslash out and run this again. This time, as we can see, it's printed out the statement in a single line. So that's how you would do that. And just to add the spaces after is and before and, we can do that manually. Again, let's put a space in here. And before and, let's put in another space and run it again. So that's how you would fix that as well. I'm going back to the original statements. This is why we did not need to put in a separator, as they have a separate argument separated by the comma. So it knows to use the separator, which is really a blank space after the comma. And again, it could not do it on this line here because they are joined together as part of one argument and the comma is here. But of course, that's another thing. You can put in the sep and the colons to say, okay, I want to add a separator over here. And that's another way of doing it as well. You can use a sep argument to add a blank space wherever required in your print statements. Now, another way to write this is to use something known as formatted strings. Well, they're called formatted string literal or f-string, which is the recommended way to format strings, and it works with Python 3.6 and above, so it's fairly new and is prefixed with a small f or a capital F, and we use curly braces. So let's have a look at that. So what we will do here is we'll use the small f for formatted string, and then a quote, put these in curly braces, the name. Let's put it in again and remove this one. Is, and then put my other variable, the age, in curly braces as well. Age, let's remove this. Let's remove all of this. And after age, let's put in years old and close it off with a quote. Let's run this. And it's printed out my statement. Jaffa is 40 years old. But the difference is it's done all the formatting for us. So we didn't have to add the quotes and the commas for all of these. It's done it all for us. We can also do something like, so let's create a new variable, my underscore value equals 250. I think a million is 6 zeros. Now let's print out my value of 250 million. And usually with 250 million, we should see commas after, starting from the end, after each 3 digits. So we should see one here, and we should also see one here as well. So let's ask my print statement to do that using f-string. So that would be print f for formatted string and a quote. Now open it up with curly braces, my underscore value, and after this we want to specify a colon and the comma symbol, and let's run this. So we can see it's put in the commas for us, so it's done that for us as well. So formatted strings is a very useful feature to get familiar with. As we have seen, it helps with formatting the strings. There are collection types that are used to store collections of data, which is the storing of multiple items like lists, tuples, sets, and dictionaries. In this video, we will have a look at lists. And lists are created by using square brackets. They are ordered, changeable, and allow duplicate values. And here is an example of a list, and we can see the square brackets. And inside the square brackets, we have what are called items, or sometimes they are called elements as well, and we can see strings, integers, floats, and you can add other data types in there as well. and we will run this in PyCharm very shortly. So lists are ordered, and with ordered it means that the items have a defined order and that order will not change. If we add new items to a list, the new items will be placed at the end of the list. Then there's changeable. With changeable it means that we are able to change, add and remove items in a list after it has been created. And then there's duplicates. With lists, because they are indexed, they can allow duplicate values. And we can see in my underscore list, the third value and the final value is a duplicate. We have London in there twice. And use cases for lists. So examples of why lists are used. So when data changes, your lists get bigger or smaller over time, you can use a list. As lists are mutable, which means data can be changed. However, they are not as quick as tuples. So that's the main use case. If your data changes, you would use a list. And Python has a number of predefined built-in methods that can be used on lists. They're also called arrays, by the way. So lists, arrays, which are all of these in red below. So we can see append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. And we can see these when we have created the list, which we will do very shortly. So let's jump into PyCharm and create the list. I've copied the list from PowerPoint, so we just need to paste it in, and let's run the file to make sure it runs as well, which it does. So the next thing we will do is, if we type my underscore list and then the dot operator, we can see all the methods in here, and we can see append, for example. Let's just scroll down this list to see all of the methods. So we can use these methods on our list to do things. So these are like operations to do things. So if I click on the method, double click the method, and then if I add Paris inside the brackets and run the file. So Mr. Quotes, let's add the quotes in there and run the file again. Of course, let's move it before the print as well. We want the operation to kick in before we print the list. And now we have printed the list. We can see Paris has been added to the end of the list. We can also do other things. We can print individual items, or sometimes known as elements again, from the list using their index position. So we can do print my underscore list as we have done here, and then we specify the index in square brackets. And as it starts from 0, if we specify 1, it will print the float 5.5. So let's do that. Print the index of 1, which is 0, and then there's 1, 5.5. So let's run the file, and we can see here it's printed out 5.5 there. We can also do a -1 to print out the last item in the list. Let's run the file again, and it's printed out Paris. Even though it's not in this current list, we've added it in the second line here. So it's printed out Paris. -1 is the last item, and -2 will be the second to last item. -3 would be the third to last item. So let's print out Marrakesh and run the file again. Sorry, Bangalore, because Paris is in there as well. Or we can start at an index value instead. So let's start at maybe 3 and print to the end of the list. So 0, 1, 2, 3. So it should print Marrakesh, Bangalore, London, and Paris. Let's run the file again, and we can see Marrakesh, Bangalore, London, and Paris in there now. Or we can do it the opposite way. So let's finish at 3. So it will not print the third index itself. It's up until 3, so it's 0, 1, and 2 instead. So let's run the file. We can see here 1, 5.5 in London, 0, 1, 2. So it doesn't actually print 3 itself. And to do a range, we can put in 1 here. So that's index 1 up until 3. So that will be 1 and 2. Let's run the file again. We can see 5.5 and London, 1 and 2. Just to finish off, going back to the PowerPoint slide. And we've used the append method in the list to add a new item to the list. It adds it to the end of the list. But there's also these items here. So there's clear, which removes all items from the list. Copy returns a copy of that list. Then there is count, which specifies the number of values in the list. And instead of append, if we want to insert an item inside the list, we would use insert instead. So insert is similar to append, where you can add an item at a specified position. Because append adds it to the end of the list, but insert will add it to the position you want to add it inside the list. You can use remove to remove any values from the list, reverse, which reverses the order of the list, sort, which sorts the list out, and the one I've missed is index, and this returns the index of the first item of the value we specify. Let's run another method. Let's run count instead. London as the value. Let's add this as a variable, and let's print X here and run the file. And it's telling us the number of times London appears in the list is twice. It says it twice. If we go for Bangalore instead, it should return the value of 1. And let's run the file again, and this time we see 1. We had a look at append just a bit ago, but if we wanted to insert something other than the end, let's say we wanted to insert an item somewhere in the middle or at the beginning, we would use insert instead of append. And this takes two values inside the parenthesis, and the first one is the index of where we want the item to be placed, and the index starts at 0. Let's type 3. Then we type the object of what we want to add to the list. Let's go with Antalya, and let's run the file, and we can see Antalya has been added to the list. We can also remove Antalya by using the remove method, and we leave Antalya in there. Let's remove Antalya and run the file again. So we cannot remove Antalya because Antalya is not in the list in the first place. So let's go with London instead, and let's run the file. This time we should see only one occurrence of London. So it should remove the first occurrence, leaving the last occurrence in place. Let's run the file, and we can see London is still there as the last occurrence. The other one, the duplicate one, or should I say the first occurrence of London, has been removed from the list. We can also copy the list as well. Let's do my underscore list underscore 2. So let's create my underscore list underscore 2, and we will copy my underscore list to create my underscore list underscore 2. So it's a copy of my underscore list. Let's print out both lists and run the file. So we now have two lists with the same items. It's almost like a backup of the original list if something goes wrong. We can also do a clear to clear the list as well. So we can do my underscore list dot clear, and if we run the file, now there are no items in the list, so we have cleared the list. There is also sort as well, so we can sort the items in the list. Let's create some more items in this list, and let's use the sort method. So we can see here it sorts it in reverse as well. We will have a look at that as well, but let's use the sort method for now, and let's run the file. So it's complaining about mixing strings and integers together. So if we remove the strings, let's run the file again. And when we run the file, we can see it's sorted them in ascending order. So we've got 1, 2, 3, 4, 5, 5.5. The original file had them all over the place in random order. So we can sort them out in ascending order. With string values, it should sort them out in alphabetical order. Let's try that. Let me paste back in those string items, and let's run the file. And we can see it sorted them out in alphabetical order. So Bangalore starts with a B, then it's L, and then it's M for Marrakesh. But we can also reverse it as well. So if we do a my underscore list dot reverse and run the file again, it should do it the opposite way this time. So we've got Marrakesh, London, London, Bangalore, and it should do the same for the numeric values as well. So if we do 5, 3, 1, let's run the file. Sorry, actually 1, 3, 5. So if we do 1, 3, 5 and run the file, so it reverses them opposite way, starting with the highest value to the lowest, so descending order this time. There are 4 collection types that are used to store collections of data, which is the storing of multiple items, lists, tuples, sets and dictionaries. In this video we will have a look at tuples. A tuple is immutable, which means it cannot be changed, and a tuple is written with round brackets. We can add any data type within a tuple, such as integers, floats, strings, boolean values, etc. And we can see in the example tuple, my underscore tuple, it has random data inside it. but a tuple is typically used to group related data. For example, it might be a record of a list of people or person's ID or information on them for, let's say, insurance purposes. For example, their name, age, marital status, job, address, criminal record, driving history, and so on. So this is just an example of the type of information you could see inside a tuple. And like I said, a tuple is ordered. Items have a defined order and that order will not change. But unlike a set, a tuple is unchangeable, so we cannot change, add or remove items after the tuple has been created. And like I said, a tuple allows duplicate values. This is because they are indexed. And you can use tuple items with any data type. In terms of use case for tuples, a tuple is faster than a list, and the main reason is it protects you from accidental modification since a tuple cannot be modified. Python has two predefined built-in methods that can be used on tuples, and these are count and index. There's not many, there's only two, and this is because you cannot change anything on a tuple. You can only gather information about a tuple. So a count will count the items or elements or values. Sometimes they're called items, sometimes they're called elements, sometimes they're called values, and return the number that the item exists within the tuple. So for example, the item blue could exist 3 times within the tuple. So this will tell you that it exists 3 times. We will have a look at it shortly. And then there's index, and index returns the index of the first occurrence of an item in a tuple. So it tells you where it is inside a tuple, its index position. And we are back on PyCharm. I've copied my tuple, so I'm going to paste it in, and let's print the tuple to make sure it prints. My underscore tuple. And we can see on the right hand side the tuple prints to the screen. And if I type my underscore tuple dot, we can see the methods that the tuple supports. So there's only count and index as methods. We can see if we go further down, we don't have the other methods like we have with the list, which are append, insert, clear, etc., as we cannot update a tuple or change it in any way. Typically what we would do if we wanted to modify a tuple, we would convert it to a list and then modify it and then reconvert it back to a tuple, or we would create a brand new tuple instead. And these other ones that look like methods, they all have a double underscore before and after. These are known as magic methods, or also known as dunder methods. They perform things like logical operations, mathematical operations, object comparisons and sequence operations, and they are beyond the basics of learning Python. So we are not going to cover them here. And the first method we will take a look at is count. In the last video on lists, I created a variable x equals and then printed x to show how the count method works. In this video with tuples, we will directly print using the method without having to declare it first. So let's look for the item London and let's print it directly to the screen and run the file. So we can see it says there's 2 occurrences here of London. We can see one here and one over here. If we type something else like 5.5, we can see it over here. We should only see 1 occurrence. And we only see 1 occurrence of 5.5. Now if we wanted to see the index position of 5.5, let's type in index and double click it here. So the index position is 0 and then it's 1. So 1 is the index position. Let's run the file and it shows us 1. And if we wanted to see the index position of London, there's 2 occurrences of London. Let's type in London. As it shows you the index position of the first occurrence of London, it should show 0, 1 and 2. So the index position should be 2. Let's run the file and we can see it's 2. And we could do many other things with tuples. We can use loops to look for items in tuples as well. Let's say, for example, if. So we are saying if London is included in my tuple, in is the keyword for include, then print yes. Let's run the file. And we can go on. So we can do an else statement to say otherwise, print no. A set is another collection to store multiple items. The other 3 are list, tuple and dictionary. A set is written with curly brackets and is mutable. And where the big differentiator is with a set is it's similar to a list, but it does not allow duplicate values. A set is unordered, and because a set is unordered, items cannot be accessed using indexes like a list. This means items in a set can be in a different order each time you use them. Actually, let's have a quick look at this in PyCharm. So we are on PyCharm, and I am going to paste in my set. So we can see my underscore set, and it equals curly brackets, and we've got some items inside my set, and then we are printing my set to the console. So let's run the file, and we can see the order. So the order has changed. You can see true, the boolean value of true is the first one, but we can see in my underscore set it's the last one. If I rerun the file again, we can see again true is at the beginning. If I rerun the file again, we can see it's changed to Sydney as the second one. So true, Sydney, Marrakesh. Let's run the file again. We can see it's changed true, 34, London. So the order does not stay the same. Finally, true has moved. So it's moved into the middle now. A set is unchangeable. You cannot change its items, but you can still add new items and you can remove items. It's unindexed, as we have just had a look at, so there's no index with sets. And we've already seen, because they are unordered list of items, items cannot be accessed using an index like lists can. And because it's unindexed, it does not allow duplicate values. So if we go back to PyCharm, and if I add another list, another item, let's copy Marrakesh and paste that in, and let's run the file. So we can see Marrakesh has been added in once, even though in my set I have included it in twice. So looking at use cases, unlike a tuple and a list, a set cannot have multiple occurrences of the same item, and it stores unordered values. If it's important to store unique items, use a set. A set is also faster than a list when searching for items. Let's look at the methods supported by set. So set has quite a few methods, as shown in red below, and some are quite obvious and others are not. So add an item to the set. Clear will remove all of the items from the set. Copy prints a copy of the set or returns a copy of the set. Difference update is quite a good one, because it removes items in a set that those items also exist in another set. So it removes duplicate items. So it removes the items that are the same from one set that are also inside another set. Discard removes an item. Intersection, this checks if both sets have the same items. And intersection update removes the items in the set that are not present in the other set. IS disjoint returns whether two sets have an intersection or not. IS subset returns whether another set contains this set or not. IS superset returns whether the set contains another set or not. Pop is like the remove method, which removes an item from the set, but this is a random item. So the pop method randomly removes an item from the set. Then you've got remove itself. The remove method removes the specified item from the set, so the one we specify. Symmetric difference, this would return a set with the symmetric differences of two sets. Symmetric difference update, this would apply the symmetric differences from the set and another set. And the second to last one, the union returns a set containing the union of the sets. And the last one, update method, this would update the current set by adding items from another set. Let's have a look at some of these in action in PyCharm. So we are in PyCharm again. If I type my underscore set and then a dot, we can see our methods supported by the set. So you can scroll down, we can see there's quite a few methods here. And let's start off with add. So if I double click add and then add something inside here, let's go with Paris and let's run the file. And now we can see Paris is inside my underscore set. We have got two Marrakesh items inside the set or elements. Let's remove one of these. Let's copy it and let's paste it in here. And let's use the remove method and run the file. Actually, what we see is it removes Marrakesh altogether from the set. So that's something even I've just learnt. It's removed both of them. Let's run the pop method. The pop method removes something randomly. So it removes an item randomly. Let's see if that works. And we can see 34 is still in there, London, Sydney, Marrakesh. So it's removed true. Let's run it again. So you can see it's fairly consistent in terms of what it wants to remove. So it's randomly removed true from my set. So far what we have used is my set.pop. We used the add function. And we used the remove method. I should call them methods, not functions. And we can hash these out so they don't run, but we've got them there for reference. And for this one, let's create a new set. So we'll call it my_set2. Let's paste that in. Got some random values inside here as well. Now what we can do is use the update method. So my_set.update, and then in brackets my_set2. So what we are doing here is we are passing my_set2, and if we print this, so I've got an error because I'm missing the equal sign here. Let's add that in and let's run it again. Now we can see it adds all of my_set2 items to my_set list. We can see they are all combined now. So we can see my_set contains the items of my_set as well as the items of my_set2 as well. Or what we can do instead is create my_set3 equals my_set dot union my_set2. So to join the sets together and give the set a new name, we can use the union method. Let's run the file, and we need to print my_set3. So let's run the file again. Now we can see I have added my_set2 and my_set and created a new set called my_set3. To clear them, we can use my_set2 dot clear. And now if I run my_set2, there's nothing inside the set. So if I run my_set instead, because I've not cleared my_set, we can still see the elements inside here. So that's what the clear method does. And we can also check if both sets have the same items as well. This will be done with intersection method. So we do something like, let's do it directly inside the print. Let's run the file, and we can see it saying London is a duplicate value. So if I scroll back up a little bit, we can see London is inside my_set and my_set2 as well. So that's what the intersection does. It tells you if there are duplicate values in both sets, which there is. There's London. And you can do the opposite as well. You can see the differences between the two sets as well. So what we can do instead is use the difference method, and let's run the file. Now we can see the differences between the two sets. So Sydney, 34, Marrakesh and true are part of my_set, which are not part of my_set2. And we can flip this around as well, just to see it the opposite way as well. Let's run it again. We can see now my_set2 has California, 50, Antalya and 100. And these items do not exist in my_set. So these are the differences. I can do something like remove an item as well. My_set2 dot remove. Let's go with 50. Let's run the file. And now we can see 50 has been removed from my_set2. And that's it for sets. So in this video, we've had a look at another data structure type. This is a collection type of sets. And we've had a look at some of the different methods supported by a set. A dictionary is another collection to store multiple items. The other three are list, tuple and set. Dictionaries are written with curly brackets like sets, and they consist of key value pairs. The key and the value is separated by a comma. For example, we can see the key city and the value London in my example in the red are the key age and the value 25, the key year and the value 2023, and so on. Dictionaries are ordered. Prior to Python 3.7 they were not ordered, but since 3.7 and later versions they are now ordered, which means items have a defined order and that order will not change. And new items will be placed at the end of the dictionary, and dictionaries are changeable, so you are able to change, add and remove items to an existing dictionary, but duplicates are not allowed, so they cannot have two items with the same key, for example. And as a side note, the values in a dictionary item can be of any type, and you can even include a list itself. So if we look at the example in red, we can see favorite cars, that's a list, and the list called favorite_cars consists of 3 items or elements, which are BMW, Audi and Mercedes. And moving on to the methods, so what methods are supported by a dictionary? And these are the ones listed in red. So clear will remove all the items from the dictionary. Copy will return a copy of the dictionary. From keys returns the specified keys and values. Get returns the value of a specified key, which is good to use as it does not return an error if the value key does not exist. So your program can continue to run. We'll have a look at this in PyCharm. Items returns all of the items. That is all of the key value pairs. Keys return the keys within the dictionary. Pop removes the specified item from the dictionary. Pop item removes the last key value pair. Set default returns the value of the specified key. Then the second to last one is update. With update you can add specified key value pair to the dictionary. So you add a key value pair to the existing dictionary. And then the last one, values. Values returns all of the values in the dictionary. Let's have a look at some of these in PyCharm. We are back on PyCharm and I'm going to paste in my dictionary, the one that we had on PowerPoint. So it's called my_dictionary and we want to print this out to the console. So let's do a print my dictionary, and let's run the file to make sure it runs. So we see all the items, the elements of my dictionary. We see the key value pair, city, London, age, 25, etc. And what we can also do is use the items method. So if we print the items method, print my_dictionary.items, and the items method returns a tuple of each key value pair. So let's run the file, and we can see the print function above with the print function and passing the items method. The one below it, they are in key value pairs again, separated by these brackets. So we've got another one here for age and then for year here and so on. Or we can print a particular item. So if I hash these, so the way we print a particular item is to print my_dictionary as usual, and then in square brackets we can specify, let's say, the key age. Because I've hashed these ones will not run, and we should receive the key value pair for age instead. Let's run the file. So I've missed my commas. Let's run the file again. So this time if I run the file, because I'm passing age, I should get the value of 25. Or we can print all of the keys. Let's do another one. Print my_dictionary.keys. Let's run the file. And we can see the key of my dictionary here. So we have printed the keys, city, age, year and favorite cars. And we can do that for value as well. So if I copy this line and paste it in again, change the keys to the values method, and let's run the file. So now the third line down we see all of the values. Let's have a look at another method. Let's hash these out. So usually if I wanted to print something that does not exist, so age does exist, but let's say I type this in wrong, I used a small a or a completely different key altogether, and if we run the file, this breaks the program, so the program stops. And this is a bad thing because the program stops running, so it doesn't continue with the rest of the program. And this is where the get method comes into play. So let's use the get method here, .get. By the way, we can see all of the methods here. So if I scroll down, you can see what's available with the dictionary. So you can see all of the methods at the top. Let's use the get method here. And now let's type in age again and run the file. I have forgot another bracket. Let's put in another bracket there and run the file again. And of course, my commas. And let's run the file one more time. So this time it gives us some feedback of none, but the file continues running. So it doesn't stop the program. The program continues to run. And that's the important bit here. Let's type in age with a capital A, just for completeness, just so we see the value of 25. And for the last method, let's create a copy of my underscore dictionary. So I'd do that by typing in my underscore dictionary 2 as the new name for the new one. So you can call the copy whatever you like, give it a name, and then equals my underscore dictionary, and then let's use the method .copy, the top one here. Let's double click that, and now let's print my underscore dictionary 2. We can see it's giving us some suggestions of both dictionaries here, so I want the top one. I've double clicked that, and now let's run the file. Actually, let's finish off by using the update method. So we can use the update method to update my underscore dictionary. Let's remove this part and then change the copy to update method. Now inside, using curly brackets, we specify our key value pair. Let's go with gender, and then our colon, space. Now we would specify our key, which we will call male. Now let's change this to my underscore dictionary, not dictionary 2, and let's run the file. Now we can see at the end it's updated that, so we now have our new key value pair of gender male. And that's it for this video. So that's the last one on data structures. So we just had a look at dictionaries, the collection type dictionaries, and we had a look at the different methods supported by the dictionary as well. We have already covered off lists, which are collections of items, and in this video we will have a look at two-dimensional lists, also known as, for short, 2D lists. A 2D list is essentially lists within a list, or you can call them multiple lists, or also known as multi-dimensional lists. And it represents a table-like structure with rows and columns. The outside or the outer list represents rows, and the inside list or the inner list represents a row of items or elements. And what we are going to do is create 3 lists of different places in different countries, and we are going to turn this into a 2-dimensional list. So let's log into PyCharm and we will do that now. We are now logged into PyCharm, and I'm going to paste my 3 lists, Turkey, UK and Canada. And we can see lists are created using square brackets, and we can see 3 items for each country. These are the 3 places associated to each of the countries. Now let's create another list. Let's call it FAV for favourite underscore places. So favourite places equals. Again, lists are created using square brackets. And in this list, we will place our 3 countries. Consist of the 3 lists we have created. So that's Turkey, UK and Canada. So this is our 2-dimensional list. Our 2-dimensional list is called favourite places. And this is a list made up of multiple lists, Turkey, UK and Canada. Next, we will print it to the console to make sure it prints. So let's print favourite underscore places to the console and run the file. I've accidentally added an X at the end of my list. Let's run the file again. And now I can see my 3 individual lists printed to the console. So this prints all of the items in all of the lists. And the 3 items are grouped together, separated by the square brackets identifying each list. Now, if we wanted to print a particular list, we would use indexes. And to do this, we would use square brackets. And we would specify the position of the index starting with 0. So Turkey, the first list, would be represented with a 0 and so on. So it'd be 0, 1 and 2. So let's go with Canada, which is 2, and let's run the file. Now we can see it's just printed out Canada. But what if we wanted to print out a particular item in Canada? Let's go with Vancouver. This would be again another index. This would again start with 0. So Toronto would be 0, Vancouver 1 and Calgary 2. So we need 1. We will do this by adding a second set of square brackets. And in here we would specify the index of 2. Now let's run the file. And as we can see, it's printed out Calgary to the console. Vancouver would be 1, so let's print out Vancouver. And of course, if we wanted to print out something within the UK, that's 0, 1, we'll change the index in the first set of brackets, which controls the list, to a 1. And let's print out London. So that would be 0, 1, 2. So London is 2. And let's run the file. So you've got the point. The first index represents the lists and the second index represents the items within the lists. We can also modify an item. Let's change Leeds to Newcastle, and that would be favourite underscore places, set of square brackets. We are now looking at list number 1, and then another set of square brackets, and Leeds is the first item, so that's a 0, equals Newcastle. So let's run the file. Actually, let's change this to 1 and 0 as well. Let's run the file. And we can see it's printed out Newcastle, so it's modified Leeds to Newcastle. Now, if you don't want to separately name each individual list, you can also do this. So now my variable favourite underscore places consists of these 3 lists. And if I run the file to make sure it runs, we can see it's picked out Leeds due to the indexes of 1 and 0. Now we can also iterate through our lists using a nested for loop as well. So to iterate through the lists, we would type for my underscore list in favourite places. So with this line, we are iterating through each of the lists in favourite underscore places, which will be these 3 lists here. Now to iterate through each item within the list, we would use a nested loop within the loop. And this would iterate through the individual items within the list. So it would be for item in my underscore list, and then it would be print item. Let's run the file. Of course, I'm missing a colon. So let's put the colons in place and run the file again. Now we can see it's listed out all of the items in all of the lists. So it's iterated through each of the lists using the first for loop, and then it's iterated through each of the items as well using the second for loop. And that's an overview on 2-dimensional lists. Welcome back to another video. In this video we are going to have a look at data type casting. Type casting, or another name for it, is type conversion, which means converting something from one data type to another data type. And typecasting can be done in 2 ways. One is implicit and the other one is explicit. The implicit way is performed automatically by Python without any user intervention, where the explicit way can be done manually by the user using casting functions. And some common use cases for typecasting include ensuring consistent data types for mathematical operations, converting user input from strings to integers or floats, and handling data from APIs or files that require conversions. So these are some common use cases. Now here's an example of an implicit typecasting where Python automatically promotes smaller data types to larger data types when needed. For example, adding an integer to a float will automatically convert the integer to a float. So we have int underscore number equals 5, and then we have float underscore number equals 3.2. And then we store everything in a variable called result. Result equals int underscore number plus float underscore number. Here we are adding an integer to a float. So the integer 5 is implicitly casted to a float. So data type casting is implicitly applied to the integer number 5, and then we can see the result. The output is 8.2. And to now prove this is a float, we can use the type function. So this will tell us the data type, and the output of the type function is a class float. So this is an implicit example. Now looking at an example of explicit typecasting. In explicit typecasting, you can manually use the following functions, which are int converts a value to an integer, float converts a value to a float, string str, which converts a value to a string, bool converts a value to a boolean, and then there's list, tuple, and set, which converts a value to a list, tuple, or a set respectively. Now I have some examples. So the first example, we have x equals 1, y equals underscore 2.5. And to convert x to a floating point type, because currently it's an integer, we can store it in a variable called x underscore float. And then we can use our float function, the second one in the list. So float, and then we will specify x in the parenthesis. And now when we print x underscore float, this will convert x into a float. And then we can use the type function to prove it's been converted into a float. So this example we will have a look at in PyCharm amongst the other two examples. The next example, we convert the float y to an integer. So we're using the int function here. And the third example, we are converting the integer x and the float y to type strings. So we're using the function str to convert them. Let's have a look at these three examples in PyCharm and how we confirm they have in fact changed to the correct data types. So if I do x equals 1 and y equals 2.5, and then we can print x and y. However, if we use the type function to confirm the data types, and now if we run the file, it will confirm x is a type of int for integer and y is a float. Now to convert x and y to a string type, we can store them in the variables x underscore string and y underscore string equals str. So we are using the data type casting function str followed by x and str again followed by y to convert them into strings. And now we can print x underscore string and y underscore string to the screen. And let's follow this up using the functions to identify the data types again. So in the previous time they were identified as integers and floats. But if we run the file again, at this time we can see it's still printed 1 and 2.5 as per the first two print statements, and the second two print statements identify the new types, so they have changed from int to float to string and string. And it's a similar process for the other examples as well. So if we wanted to convert x to a floating point type, we will store it in x underscore float equals, and then we will use the casting type of float. Now we can print type and inside parenthesis again x underscore float. So if we run the file, we can see x has been converted to a float, but in the original instance x was an integer type int. So it's now been converted into a float. And with y we can already see it's a float because it's 2.5. So to convert y to an integer type, we can do the same. So we can see originally y was a float. Now we have converted it to a type int, which now we can see over here it's been converted to a type int. I have a couple of example use cases. Example 1 is converting user age from string to integer. So when gathering age input from a user, it's often entered as a string. And here is how to convert it to an integer for further calculations. So I've got user underscore age equals input, and then we ask the user for their age. And then on the second line, we will store it in age in 5 years. And then we will use the typecasting function int, specify user age in there plus 5, which will convert it to an integer. And then when we print it, in 5 years, you'll be age in 5 years, years old. And of course, on the second line, we can see age in 5 years equals the user age, which has been converted to an integer plus 5. And I guess if we go back to PyCharm and paste the code in just to see the output, we can see it's asking us for our age. And over here, we can see it confirms in 5 years, you'll be 30 years old. So it has indeed converted it to an integer type and added the int type values together. Example 2 is counting items in a list as a string. So imagine counting items in a list, then converting the count to a string to display it with a message. So items equal apple, banana and orange. And then the second line we will store it in a variable called item underscore count. This time we'll use the length function to count the items, which effectively gets the number of items. And then we will print you have plus, and this is where we're using the str function to convert it back to a string. And this of course was stored in item underscore count. And then we are using the plus to concatenate another string, items in your basket. And finally the output should be you have 3 items in your basket. And again we can run this in PyCharm just to confirm it runs. So it's converted the item count to a string and then concatenated it with another string. And that's the end of this video. That's a high level overview of data type casting. In this video, we will have a look at input and output. So input and output is about the Python program ability to take input, and based on the input it receives, it produces an output. There are two main functions we want to have a look at based on input and output, and these are input and print. We've been using print all along through the video series, and we're going to be using the print function, and we can pass parameters to the print function, which are values separated by commas, as functions can take parameters. But we can also accept input from the user using the input function, which is input, open parenthesis, and then followed by a closed parenthesis. This is how functions are written. Once the user inputs information, the function stores the information inside a variable and is able to print it out using the print function. And the output of an input function is of a string data type, but we can change the data type to an integer, float, or a boolean value. Let's take a look at some input examples. So here we use the input function, open parenthesis, and then we are going to type what is your name, followed by a closed parenthesis. Also another input, and we have created a second input so the user can specify their age. And we want to store these in a variable, so I will create a variable called name equal, and then input followed by the question. And we will do the same for age as well. We'll store it in a variable called age. And finally, we'll want to print out the output to the console. And then on the third line, we will print out the name and the age. Let's run the file. What is your name? So specify my name here. And then my age. And it's giving us my age and my name as well. And another thing about input is the input function by default returns a string value, which is not what you want if you're working with numeric values. For example, if we wanted to add two numbers together, let's say we have two online businesses. Let's clear the screen here and let's start off with a clean slate over here. So for online business profit 1, we are asking the user how much money did they make today. And then for profit 2, we are again asking the user how much money did they make today. And then we are doing some basic calculation here, profit 1 plus profit 2, which is stored in the variable of total underscore profit. And then we are printing total underscore profit to the console to see the result. So if we run the file, let's go with £60 or $60, and let's go with 40 for our online business too. And we can see because it's treated it as a string, it's printed out 60, 40. So it's actually concatenated the numbers together rather than doing any arithmetic operations on them. So it's not calculated them using numeric values. We should have received the result of 100. So the way we fix this, we can specify int for integer before profit 1 and before profit 2 as well. But we would have to put the variables in parentheses as well. Now if we run the file again, how much money did you make today? 60, and again 40. And this time, because it's treated them as actual numeric integer values, now it's able to do proper arithmetic operations on them and add the numbers together. And as a tip, this is nothing to do with input and output, but to save on the lines of code we're writing, we can also write all of this in another way where you can use the integer by nesting them on the first two lines. So what we can do instead is remove the integer from here and paste it here. Put this into parentheses. And we can do the same over here as well. And then with profit 1 and profit 2, we can remove them from here and use them as arguments in our print function instead. Change that to profit 2. And now we can remove the third line here. We don't need it anymore. And we can run the file again just to make sure it runs. 60, 40, and we get the result of 100. Now it's good to do this where it makes sense, so we are not using total profit in our program ever again. So rather than declaring a variable called total profit, which we are never going to use again, and then doing an equals profit 1 plus profit 2, we can just remove the line altogether if we are never going to use it again, and then directly print it all out into the print function instead. And that's it for this video. That's a couple of examples of how you would use the input function to gather input from the user to produce an output. Next, we will have a look at the if-else statements. With if-else statements, they are used to create conditional statements, and a block of code is executed depending on whether the condition is true or false. If it's true, it will be executed, and if it's false, Python will move on to the next condition or expression and evaluate it. So the way you read this is, if this condition is true, then execute the associated block of code. But if it's false, move to the else statement and execute the block of code that belongs to the else statement. And some refer to this as if then else statements because they read this as if condition is true, then execute this block of code. So that's why it can be referred to as if then else statements. And there is also another statement as well, which is the else if statement. And this statement is used if you have more conditions. And every time a condition is false, it will move on to the next condition and evaluate if that's true. If it's true, it will execute the block of code. Otherwise, it will hit the very last condition, which is the else. And it will hit this one if all the other conditions are false. And if we notice, the blocks of codes here are indented. And this is to represent that it belongs to the if or the else condition above it, or the else if we are using else if, which is a good thing for multiple reasons, including it makes the code much easier to look at, read and understand. And it's the way Python groups codes into blocks of code. Whereas with other languages, typically they use parentheses or curly braces to do the same thing. But with Python, using indentation, it makes the code a lot more pleasant to look at, and that's why people love Python. It's a lot more pleasant to look at, easier to understand and work with. And for our conditions, we use Boolean operators, which are these over here. For example, if the condition equals something, and it needs to be a double equal over here when using it within an if statement, as a single equal is used when assigning a variable to a value. We can also use the not equal to, or the greater than, or the greater than or equal to, less than, or less than or equal to. We will write some code next, but here's a few rules. So the block of code is indented, and then we have the elif condition. Also, we write it as elif, and we will have a look at this in the code, but it's used if you need more conditions in your if statements. Finally, the if statements are a top-down approach, and once it hits a condition expression that is true, it will stop and execute the block of code associated to that condition. Otherwise, it will hit the else condition, which is the very last expression when everything else is false. Let's have a look at some code next. First, we will create a variable profit equals 700, and next we will create our if statements. If profit is greater than 500, we need to add a colon at the end. And notice when I press enter, Visual Studio has indented it for me. And if profit is greater than 500, we will print we made profit and exceeded our target. Next, we need to add an else statement. And this is not indented, so we go back to the very first line. Else, colon. And when we hit enter, notice it's indented it for us again. Let's print. We did not make any profit. Let's print another statement as well. Let's print one more statement. Try and sell more items tomorrow. Let's save this and let's run the program. And the result we see is we made profit and exceeded our target, and that's because the variable equals 700, which is greater than 500. Let's change the variable to 200. So we would expect it to hit the else statement this time, and let's run our program again. And this time we did not make any profit. Try and sell more items tomorrow. So here we are saying if the value is more than 500, we have made profit and exceeded our target. But if it's not greater than 500, which means it will be 500 or less, then we did not make any profit. But let's say we actually do make profit above 300. So we need to add something in between. And for this, we can add a further condition to check if we still made profit. And this is known as else if statements, using the elif keyword. So here we would type, let's cross this off, and let's add an else if statement in the middle here, starting from the very first line. So let's type elif profit. Let's go with is greater than or equal to 300. And we can add a comment here so we know exactly what this means. And to do that, we create comments using hash. So Python will ignore this as code and it knows it's a comment. And if I hit enter here, if you notice, it's started it at the very first line. And this is because I've missed a colon here. So let's add our colon and let's press enter again. And now it's indented it. So we know this time the statement is correct. And let's print we made profit, but there is room for improvement. And again, let's save this and let's run our code. And we will start off with it being 200. So that's not greater than 500 and it's not greater than or equal to 300. So it will hit the else statement at the bottom here as a result. So let's have a look. And we can see we did not make any profit. Try and sell more items tomorrow. Let's change this to 400 and try it again. And we can see we made profit, but there is room for improvement. And finally, again, if we change this to 600 and run it again, we made profit and exceeded our target. And to complete this, let's add another statement, but nothing to do with our if statements. Let's add something like life is great. Try and be positive every day. So now what we are saying, regardless of any of these statements, this line will run every time. At the minute, the profit is 600, so the top line should run. We made profit and exceeded our target, and we should see the very bottom line here because this is not part of our if clauses. This should run regardless. So let's run this to verify the results. And we can see here we have made profit and exceeded our target. Life is great. Try and be positive every day. And if we change this to 200, run it once again. This time it's hit the else statement at the bottom here. We did not make any profit. Try and sell more items tomorrow. Life is great. Try and be positive every day. Welcome back to another video. This video is on using loops in Python. So quick overview on loops. So loops allow you to execute a block of code multiple times without having to write the same code repeatedly. And this is useful for tasks that involve repetitive actions, such as iterating over a list, processing items in a collection, or performing operations until a certain condition is met. So by using loops, you can make your code more concise and easier to manage. And when you need to make changes to the repeated actions, you only have to modify the code inside the loop rather than altering multiple instances of the same code. And this reduces the risk of errors and makes the code base easier to maintain and debug. So loops are used for iterating over sequences or executing a block of code repeatedly. But there are two main types of loops you're able to use. One is the for loop and the other one is the while loop. So let's have a look at some use cases of the for loops and while loops. Some of the common examples of when you would use a for loop is when you want to iterate over a sequence, such as a string, a list, or a tuple, or when you are iterating over a dictionary. And for loops are often used for when you need a range-based iteration, which is when you want to repeat something a certain number of times. Or another use case for for loops is when you want to iterate over multiple sequences simultaneously. For example, iterating over a couple of tuples, such as people's names and their ages. And of course, there will be other use cases for for loops, but these are the most common ones. Next, moving on to while loops. So this is another loop, and some of the reasons to using a while loop are, you would use a while loop when the number of iterations is not known and is dependent on a condition, like true or false, or when you need to wait for a specific condition to be true. Or another one is when you are reading input or processing data until a certain condition is met. So for example, to exit out of a program, you want to hit Q or quit. But until you hit Q or you type quit, it will always be false. And until you've met that condition of Q or quit, only then would you meet the condition. So that's one of many examples of why you would use while loops. And again, just like for loops, there will be other examples as well, but these are the common ones. So with the for loops, they are often preferred when you know the exact number of iterations you require. While the while loops, they are suitable when you need to continue iteration until a specific condition is met. So in this slide, I've got a very simple example of printing numbers from 1 to 10 without using a loop. And then on the right hand side or in the middle, we have a for loop, which shows how we do the same thing using a for loop. And we can see how many lines we save of writing the same code repeatedly. Now we can also do this using a while loop, and on the right hand side we can see that. But typically for this kind of scenario, the for loop is more concise for this kind of range based iteration. But the while loop provides more flexibility in controlling the loop condition and incrementing the counter. So you can imagine more complex piece of code where you are repeating the same thing again and again. And you can imagine how large this could potentially get. Whilst instead, if you use a loop, you can save on many lines of code. So although we're going to go through some better examples in PyCharm, this is a very simplistic example of printing numbers from 1 to 10 without using a loop versus printing numbers from 1 to 10 using a for loop and a while loop. And we can see with the for loop, we specify a range from 1 to 11, so it generates a sequence of numbers starting from 1 up to but not including 11. Therefore, it creates a sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we store this in our loop variable, my_numbers, and then we print this to the screen. And for the while loop, we also store this in a variable called my_numbers, which equals 1, but we increment the value of 1, so my_numbers plus equals 1, and we make sure it does not exceed 10. So while my_numbers is less than or equal to 10, print my_numbers. And because we are incrementing my_numbers by 1 at a time, this will print our range of numbers from 1 to 10. So effectively it does the same thing. And moving on to the syntax for a for loop is, for variable in the sequence specified, execute the block of code. Now let's have a look at some examples of how we create for loops in PyCharm. To start off with a simple example, we can use a string. A string is an iterable object because strings contain a sequence of characters, for example, for my string and the keyword in. So here we are going to print out my string using the for loop. So it's going to go through the sequence of characters and print everything within my string variable. So let's run the file. And it's printed out all the characters within my string. We can also use the range function with the for loop, and this will let you loop through a set of code a specified number of times. The range function returns a sequence of numbers starting from 0 by default, but we can change this, and it increments by 1 by default, but we can also change this as well, and ends at a specified number. So this is a very simple example saying using the command for loop, my_range in range 10. As we have the number 10 value in our range specified, this would print the values from 0 to 9. It excludes the 10, it's up until 10, so it excludes the 10. It starts from 0 by default and it increments by 1 by default. So it will print out 0 to 9. Let's run the file. And it's printed out the numbers 0 to 9. But we could also change it to start from a starting value, let's say 2, and we would need to specify a second parameter for this. So let's go with 21. So here we are saying print out 2 to 20. Let's run the file again, and it's printed out 2 to 20. But maybe we want to increment by 2, so we can do that as well by adding a third parameter. Let's print out by the increments of 2. So let's run the file again, and it should print out in increments of 2. And now we can see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it's incremented by 2 each time. Or we can do 5. And now it's incrementing by 5. We can see it stopped at 17 because the next value would be 22, but we have told it to stop at 20. Well, 21, but it always stops at the number before. Let's have a look at another example of for loops, but let's use a list this time. Let's start off with a clean sheet again, and this time we will iterate through a list using the for loop. To start with, I will copy and paste my list. This is my list, so I've got some objects within the list. One which is an integer, a float 5.5, London, Marrakesh, true, so I'm using a boolean value here. Paris 1, 2, 3, 4, 5, blue, Ford, and that's it. So we've got 9 objects within the list. And the for, this is the keyword that initiates the loop. And then we've got the variable my_loop. This is the variable that takes on the value of each item in the sequence during each iteration of the loop. And then we've got the keyword in. This keyword is used to specify that you are iterating over the items in the sequence. Then we've got the sequence itself, which is my_list. And this is the collection of items you want to iterate through. This could be a list, tuple, string, dictionary, etc. And last but not least, we are printing my_list to the console. So let's run the file. And we can see here it's printed out my list. It's printed out the 9 objects. It's actually printed them out 9 times as well. One more example I wanted to show using the for loop, and this is using a previous example of creating VLANs. In the previous example, we used the while loop to create the VLANs, but this time we are going to use the for loop instead. So I'm using the for keyword and the in keyword again and our variable VLAN. The range function with 1 to 11 generates a sequence of numbers from 1 to 10. The for loop then iterates over each value in the range, and for each value it executes the block of code inside the loop. And this is the more cleaner and more concise way to iterate through a range of VLANs compared to using a while loop. You would typically, in a real world scenario, place your code over here. If you had APIs configured, so it understands your commands and so on. And then at the end, we would print out VLAN configuration complete. So let's run the file. And on the right, we can see it's created VLAN 1 to 10 and then exited the for loop with VLAN configuration complete. So those are 3 different ways we can use the for loop in Python.
And moving on to the syntax for while loops, and the syntax for a while loop is while expression is true, followed by colon, then execute the statement or block of statements. Now let's have a look at how we create while loops in PyCharm.
We are on PyCharm and I'm going to show a couple of examples of how we would use while loops. And the first example is using a networking component, which is known as VLANs. You can see them as network interfaces, but more so they are logical network interfaces. They're technically known as logical subnets in your local area network. So this is my while loop example iterating through 10 VLANs. First we will create a variable VLAN equals 1, and then we will type the command of while for the while loop, while our expression VLAN is less greater than or equal to 10, colon, and this is where we specify our code. So we will start off by printing configuring VLAN and then the VLAN ID or the VLAN number. And below this, we would typically configure the VLAN settings, but we are not going to do that here. In a real world scenario, you would configure your APIs to configure the VLAN settings and so on, such as the VLAN name, the VLAN IP address, etc. And then at the bottom, we would specify VLAN plus equals 1, which will move it to the next VLAN to configure the next VLAN and so on. And this loop will carry on until it gets to 10. So let's run the file. And here we can see it's configured VLANs 1 to 10. So here we specify while to initiate the while loop, and then our condition. So this is an expression that evaluates to either a true or false. So while the VLAN is less than or equal to 10, the loop will continue executing as long as this condition is true. So in this situation, we are fine because right at the bottom, we've got the VLAN plus equals 1, which moves the VLAN to the next VLAN until eventually it hits 10. So the loop will then stop. But you can have situations where there's no way of exiting the loop because you have user input, for example, and there's no way of stopping the loop until you specify a particular command or a keyword. We will have a look at that example next. Let's have a look at another example for while loops. First, we will declare a variable with nothing inside it, and then we will start our while loop. So while feedback is not equal to leave, the variable feedback, and the variable feedback we will assign to an input, so it requires user input. How did you rate our services today? Poor, average, or good? And then I will paste the rest of it in. And here what we are saying is if feedback equals poor, please let us know why so we can improve our services. Or if the user inputs average, again, please let us know why so we can improve our services. But if the user specifies good, we We appreciate the positive feedback. And if the user specifies leave, this will exit the loop and print out leave the feedback questionnaire. Maybe it should say leaving the feedback questionnaire. But for anything else, it will print out, we did not understand your choice. Please choose between poor, average and good. Let's run the file. Let's drag it over a little bit so we can see the screen. How did you rate our services today? Poor, average or good? If we specify poor, and then it gives us the feedback. Let's go with average, good. And as we can see, it doesn't matter how many times we specify poor, average or good, it will carry on. Or if we specify anything else, it gives us the feedback of, we did not understand your choice. Please choose between poor, average and good. Again, it's not going to leave the while loop until we specify leave. So finally, if I specify the leave, leaving the feedback questionnaire, and then it exits the loop. So those are two examples of how we use while loops. And with the second example in particular, if you've noticed, we are using conditional statements with our while loops. Welcome back. In this video, we will have a look at arithmetic operators. We can use arithmetic operators to perform mathematical operations, and these operators include the addition sign, or sometimes known as plus, the subtraction sign, or sometimes known as minus, multiplication, division, and there's also floor division, modulus, and power of. Let's have a look at each of these and how they work. And the best way to have a look at these is using the Python console. So the first one was addition. If we do 5 plus 5 and press enter, it would give us the result of 10. So that's addition. To do subtraction, we can do 5 minus 4 equals 1. Multiplication, if we do 5 times 4, and we get the result of 20. Now if we do 20 divided by 3, it will equal 6 point, lots of 6's and a 7 at the end. So it's a floating number using a decimal point. However, with division, if we wanted the result to be an integer, which is a whole number, we can add another division symbol or a forward slash. So this would be 20 divided by, and then again divided by 3. And this time when we press enter, we get a whole number and it's rounded it down to 6. So it's given us back an integer. Then there's the percentage sign, which is modulus. And modulus is the remainder after dividing one number by another number. So for example, if we do 100 modulus 9, and that would equal 1. And this is because 100 divided by 9 equals 11, and this leaves a remainder of 1. And we can then use the double star, which we normally use 1 for multiplication. But if we use a double star, which is to the power of, so it means the power of, like for example 7 star star 3, and if we press enter we get 343. And in other words, the power of is 7 times 7 times 7. So multiplying 7 3 times. And the term for power of is also known as exponentiation. So that's it for these operators, and we usually use them on numeric values. But of course, with the operators we just used, we're in interactive mode, and we can use these in our standard Python files as well with our variables. So let's look at a simple example of how we would use one of these with our variables instead. If we minimize the Python console, and the first thing we will do is create a variable in underscore 5 underscore years equals 5, and then we create a variable called age, and for this we want the user to input something. So input what is your age, question mark, colon. Next we will create another variable called total underscore age equals, and then we will put the type in integer and put this into parentheses and put our variable in age. And this is where we can use our operators. So in this example I will use the plus, and then in parentheses put our next variable in underscore 5 years. So in effect I'm asking the user to tell me what the user's age is in 5 years time. So here we have 3 variables. The first variable is in 5 years time. We have the value of 5 to represent 5 years, and then we have age, and we ask the user for their age, and then we concatenate both variables, so the integer age and in 5 years time as well. And now we can print the result, which will be total underscore age, and this will give us the user's age in 5 years time. So let's run this. So what is your age? I will type 20 and it should give us a result of 25. So that's a very simple example of how we'll use arithmetic operators with Python. In this video, we will take a look at the assignment operator and what we can do with it in Python. The assignment operator in Python are used to assign values to variables. It allows a programmer to perform different types of operations and store the results inside variables. The assignment operator is the equal symbol. It assigns the right hand side values to the variables that is present on the left hand side. By the way, in Python, the assignment operator, which is a single equal sign, which is used for assignment when you are assigning a value to a variable. There is also a double equal sign, so just wanted to point out the differences here. So there's the double equal operator, which we use as a relational operator for checking if two values are equal. So this is different. Now back to the assignment operator. We can also do an arithmetic operation and an assignment in a single operation. And this is also known as compound assignment operators. And we will have a look at this next. First, looking at the left, we have the descriptions of all the assignment operators. Then the operator symbols themselves. So we can see in its simplest form, it's the equal sign at the top. And then we can see for the rest of them, it's some sort of arithmetic operation alongside the equal sign as well. Then we have some examples, so we can see some examples in the middle. For example, x equals 5, x plus equals 5. But what's the equivalent of these examples? So x equals 5 is actually x equals 5. But the next one down with the additional operator, x plus equals 5, is x equals plus 5. So that's the equivalent and the result is 10. So we can see all the way down we've got these different compound arithmetic operations. We can combine with the equal sign, the assignment operator. Let's have a quick look at some examples in PyCharm. So we are in PyCharm in the Python console, and what we can do from here is do an x equals 5, and then we can do an x plus 5, which should equal 10. But the other way of doing this is x plus equals 5. Enter. It doesn't show you the result, but we can do a print x, which would show us the result, and that's 10. Let's do x equals 2 instead, and then do x multiply equals 10. And let's print it, print x, and that's 20. So what we can see here is rather than writing x equals 5 and then x plus 5 and then print x, instead we can just write x plus equals 5 and then print x. Let's do one more. X star star equals 2, print x, and that's 400. And it's 400 because the last stored value of x is 20, so it's done 20 times 20. And that's a quick overview of the assignment operators. Welcome back to another video. In this video, we'll take a look at another operator, with this one being the membership operator. Membership operators are used to test whether a value exists in a sequence. And the sequence, for example, could be a string, a list, set, or a tuple. And the result of the operator, that is the output returned when using the operators, is returned in the form of Boolean operators, which is either true or false. Now the membership operators include two operators in particular, which is the in and the not in operators. So these are the operators that can verify if a sequence of characters exist in our objects, and then the result is returned in the form of a Boolean value, true or false. Now when we use the operator in, it will return true if a character or sequence of characters exist, and if they do not exist, it will return false. And the not in membership operator does the opposite. So if the characters do not exist, it will return true. And if they do exist, it will return false. Let's take a look at some examples. So we are back on PyCharm and I'm going to print out my string. I've already got it copied, so I've pasted it in, and I'm using a backslash here to ignore this quote because we've got one at the start of the string and we've got one at the end of the string. So I want to ignore this one. So we use a backslash for that. And let's say we want to confirm if the value 123 exists in my string. So let's print brackets. Now let's look for 123 and let's use our in operator. And then what we are searching in, my underscore string. So this is my string and this is what I want to confirm if it's included in my string. 123 in my string. So let's run this. We can right click and run membership operators. So this is another way to do it. And we can see we get a result, a boolean result of true. But if we put a 5 in here, so now it's saying 1, 2, 3, 5, but it's missing the 4 out over here. Let's run that and see what that gives us. And we get a false, because 1, 2, 3, 5 does not exist. And we can use the not in keyword as well. So if we do not in, it should return a true now, because 1, 2, 3, 5 does not exist. Let's run this, and we get a true, because 1, 2, 3, 5 does not exist. This is 1, 2, 3, 4, 5. So if I put the 4 back in here and run it, we should get a false now, because it's asking for not in, the opposite. So I get a false this time. And we can try it with other objects as well. Let's try it with my list. I'm going to paste my list in here. So let's confirm if MAR from Marrakesh exists in my list. So let's do a print, open bracket, and let's look for MAR in, and then it's my underscore list. Let's run the file. And we get a false, so it's the second one. It's still running the first one as well above in my underscore string as well. Let's try the full list object, Marrakesh, and now we get a true. And if we specify not in as the operator, we should get a false. Let's try and specify this with a small m instead and run that to see if it's case sensitive, and we get a true, the opposite. So if we are using the in operator, just so it's a bit more easier to read and understand, is Marrakesh in my list? It shouldn't be, because the m is a small m and my list has a capital M for Marrakesh. So let's run that and we get a false. And of course we can try it with a set and a dictionary as well, and we can combine these as well, the print and the my list. So if I paste in my set, now this is my set, I've got print, and then I'm looking for the word Sydney in, and then I've pasted my set inside this whole statement. So I've got London, Marrakesh, Sydney and 34. So if we run the file, of course it should return a true because Sydney exists over here. So let's run that, and we can see it returns a true. So that's a quick overview of membership operators. Welcome back to another video. In this video we'll take a look at identity operators, and what identity operators do, they look at two objects and check whether they are the same objects or not. And this is not looking at if two values are equal, but if two items are in fact the same item, or technically should I say they are of the same data type and they share the same memory location. When dealing with identity operators, there are two operators in particular. One is the is operator and the other one is the is not operator. The is operator returns true if both variables are the same object, otherwise it will return a false. And the is not operator returns true if both variables are not the same object, otherwise it will return false. So it does the opposite. So some of the use cases for identity operators are preventing object duplication in data structures, checking whether a variable is none. This is quite a common one and we will have a look at this shortly. Avoiding accidental aliasing in mutable objects. So this checks if two variables reference the same object in memory to avoid accidental modifications through aliasing. And checking caching behavior in immutable objects like integers. So let's have a look at the use cases in a bit more depth before we have a look at them in PyCharm. So checking whether a variable is none. I've started with this one and I've got two examples of this in PyCharm. So one of the most common use cases is checking whether a variable is none. So the is operator is typically used for this, as it checks if the variable points to the none object. And a none object is a special constant in Python used to indicate the absence of a value. Now looking at some code, x equals none. If x is none, print x is none, and then the output is x is none. This is a very simple example, but I'm going to show a use case in PyCharm next. When checking for none, using is, or that should say using the is operator, is the preferred choice because there's only one instance of the none in memory, and you're explicitly checking for it, so that's why it's used. Now this is use case number 2 for checking for the none object, and I'll show an example of this in PyCharm. But when writing functions, you often want to see if an optional argument was passed. If the argument was not passed, its default value will be none. And you can check for that using the is operator. So I'll be showing an example of this very shortly. Another use case, avoiding accidental aliasing in lists or mutable objects. So when we deal with mutable objects like lists or dictionaries, you want to check if two variables reference the same object in memory to avoid accidental modification through aliasing. So the code A equals inner list 12, B equals inner list 12, and then C equals A. And then we can print C is A and see if that's true or false. In this case, it's true. And another very simple and very similar example is checking caching baby in immutable objects like integers. So the code A equals 7, B equals 7, print A is B, and check the output whether it's true or false. In this case, it's true. And another example is preventing object duplication in data structures. So when working with objects like dictionaries or sets, you may want to ensure that an object is not duplicated by checking its object identity. So we've got object 1 equals key value, and then object 2 equals object 1. If object 1 is object 2, print these two objects are identical and will not be duplicated, and the output is these two objects are identical and will not be duplicated. Now let's have a look at some of these examples in PyCharm. The first thing I'm going to do is print out 3 list objects, and next I'm going to say D equals A. So I've got A, which has a value of 1 and 2, and then I've got B, which has 2 items, so 1 and 2 again, so these are exactly the same. And then I have got C, which has a value of 2 and 3, and as we can see, these are different from these two here. And so over here I have used the assignment operator to assign D to A. Now let's have a look at how the identity operator works. If I do a print, brackets, and then if I do a D, and let's use the identity operator, which will be is, and let's do a verification to check if D is actually A. So let's run this, and we can see we get A true, a Boolean result of true back, which makes sense because I have declared it over here, D equals A. So this returns true because they are in fact the same object. Now let's check if D equals B. Since A has the same value as B, so they both hold the same values. So let's verify if D equals B as well. So let's do a D is B, and let's run the file, and this time it returns a false. So although D equals A, and A has the same value items as B, D is not B. It's not the same thing. Or just for completeness, what we can do is copy this and do a A equals B instead, or A is B should I say, just to verify they are in fact not the same object, and we get A false. Now if I did a D equals B, or even a equals B, let's see what we get instead. So this time we're using the comparison operator. I'll change both of these to a double equal to use the comparison operator, and remove the ones above so we don't get confused with the results, and let's run the file. And as we can see, this time it's true for both of them because they hold the same values, A and B. So A and C should not be the same because they hold different values. Let's try A and C. So the third one should come back as false. I've missed out the parenthesis. Let me put that in, and let's run the file again, and there we go, we get A false. So let's print out the very first one again. D is A, and let's use the is not operator this time. And the is not operator does the opposite. So usually this would be true, but this time it will be a false. Let's print a duplicate of it instead. So we've got both results, and let's run the file. So the first one is true because D and A are the same objects, and the second one is false because it does the opposite, and so it's reversed the Boolean output. Just to finish off the video, I've got some more examples to show in PyCharm. So the very top one we have already had a look at shows the use case of avoiding accidental aliasing in lists or mutable objects, and the second one is preventing object duplication in data structures. Again, we had a look at this on the PowerPoint slide, and the last two is the two I wanted to focus on. So these two here, and these two is checking for the non-object, which is used to indicate the absence of a value. So x equals none, none means that x has no value or is explicitly empty, and the is operator checks if x and none are the same object, and because they are, it will print x is none. We can see already the results on the right hand side. So these are the results, by the way. This is for the first one, true. And then the second one, these two objects are identical and will not be duplicated. And the third one is x is none for this one over here. But the very last one is a common use case So when writing functions, you often want to see if an optional argument was passed, and if the argument was not passed, its default value will often be none, and you can check for this using the is operator. So we have it here, we are checking if a name has been passed. And if the name is none, which we can see here, if name is none, we are returning hello person, else we are returning hello and the person's name. And then here we are printing the function without passing a name. And on the second line, we are printing the function greet again, but this time we are passing the name Jack. And that's why the result is hello person, because we are not passing a name. And the second line, we print hello Jack. But the whole point is we use the is operator to check the value of the non-type object. And that's it for this video. That's a quick overview of identity operators. In this video, we are going to have a look at comparison operators in Python. Comparison operators are used to compare two values or variables or expressions. They evaluate conditions and return a Boolean result of true or false, which is important for flow control in programs. The first comparison operator we will have a look at is the equal to operator, and we have to use two equal symbols as a single equal symbol is used as an assignment operator when we assign values to our variables. So to use a comparison operator, we use two equal signs. The equal operator checks if two values are equal. It compares both the type and the value, so 5 as a string equals 5 would return false, since a string is not the same type as an integer. And on the right we have an example use case where it is checking usernames, and the double equal sign, the comparison operator, helps validate if the input username is admin. So it's asking us to specify a username, and if the username is admin, it says welcome admin. Otherwise, if it's anything else other than admin, it will say access denied. The not equal to operator checks if two values are not equal. This is particularly useful when you want to ensure that a value is not a specific unwanted result. And on the right, a use case for this is it's ensuring that a password is different from a commonly used insecure, easy to guess password. So it's asking us to input enter password, and if the password is not equal to 12345, then it will print password accepted. Otherwise, it will print common passwords are not allowed. Next is the greater than operator, which checks if the value on the left is greater than the value on the right. This is often used for ordering, ranges or thresholds. And in the example use case on the right, the greater than symbol is checking if the person's age qualifies them to vote. It asks the person's age, and if they are greater than 18, it prints you are eligible to vote. Otherwise, it will print you are not old enough to vote. Then there's a greater than or equal to, and this checks if the value is either greater than or equal to the value on the right. So the use case example on the right hand side shows the greater than or equal to symbol is used to ensure that any speed equal to or above the speed limit triggers a warning by printing you are over the limit. So if you are going at a speed of 60 miles per hour or above, it will print you are over the limit. Otherwise, it prints you are within the speed limit. Next is the less than operator, which checks if the value on the left is less than the one on the right. In the example use case, the code evaluates if a stock price falls below a certain threshold to decide whether it's good time to buy. If it's less than 100, it will print consider buying, the stock is undervalued. Otherwise, it will print stock price is above target buying range. Then there's the less than or equal to symbol, which checks if the left value is either less than or equal to the value on the right. And in the example use case, this ensures that discount does not exceed a 30% threshold. So if it's less than or equal to 30, it prints applying discount. Otherwise, it would be more than 30. And in that case, it will print discount too high. So that's the comparison operators. Let's have a quick look at them in Python's default code editor, idle. If I do 5 equals 5, that would come back with a Boolean output of true. If I do 5 is not equal to 5, that would come back with a Boolean value of false. 5 is greater than 3, that would come back as true. 5 is greater than or equal to 5. Let me do that again. 5 is greater than or equal to 5, and that comes back as true. And the last one, 5 is less than 3, and that comes back as false. Or we can do 5 is less than or equal to 3, and that also comes back as false. That's it for this video. That's a high level overview of comparison operators. In this video, we will have a look at using logical operators in Python, and we will have a look at some use cases as well, how the logical operators are used in Python. Logical operators are used to combine or manipulate operations on expressions. An expression is a combination of operators and operands that is interpreted to produce some other value. An operand is a variable that contains a specific value that allow you to perform operations based on multiple conditions. There are three main logical operators in Python, which are: the first one is AND, which returns true if both statements or operands are true. So we can see in the table, if it's true and true, then the result will be true. But if it's anything else, it will result in a false, because they both have to be true. So true and false won't work, because both of them have to be true. True and false are false, false and true are false, and false and false are false. The next one is OR. OR returns true if at least one of the conditions or operands is true. So we can see in the table, true and true equals true. True and false will give us a result of true. And false and true will give us a result of true. But false and false will give us a result of false, because at least one of these conditions needs to be true. So false and false, of course, gives us a false. And the third statement is a NOT. NOT returns the opposite. So if it's a true, it will return a false. And if it's a false, it will return a true. And this table shows us some brief examples of the AND or NOT operators and how they are used, but we'll be having a look at these examples in PyCharm. So here are some use cases, and you may understand this at the end of the video when we have seen how those operators work in PyCharm. This one is looking at the battery level check in IoT devices. In IoT devices, you can check the battery level status and whether the devices is connected to power on or not. So it's got the battery underscore level equals 15, and then whether it is connected to power, which equals false in this case. So if battery level is less than 20 and not is connected to power, so we can see the AND and the NOT operators are used in this one, and they're used to combine two conditions, checking if the battery is low and if the device is not connected to the power. Then we will print low battery, please connect to power, else we will print device has sufficient power. So if both are true, the user is notified to connect to power. Now here are three simple ones. So input validation, you can check multiple conditions to ensure user input is valid. Username Jack and the pin 12345. If username Jack and then the logical operator and pin equals 12345, print access granted. So it will only print access granted if both of these are true. Now, decision making in games. Logical operators can help evaluate the game conditions. Has underscore key equals true. Door underscore locked equals false. So if has key or, so we're using the or logical operator, door underscore locked, then we print you can open the door. And the last one of the simple ones is combining conditions. So logical operators are used in if statements to combine multiple conditions. For example, temperature equals 80 is underscore sunny equals true. If temperature is greater than 70 and is sunny, so we're using the AND logical operator here, then let's print it's a great day to swim. Let's have a look at some examples in PyCharm. First, we will have a look at some very simple examples of the logical operators, and then we will have a look at using logical operators with some typical use cases. If we create a variable x equals 20, and let's print x is greater than 10 and x is less than 30. And because we are using an AND condition, both of these have to be true, and they are true because x is 20 in this case, which is greater than 10 and less than 30. So let's run the file, and it's returned true. Or what we can do is change the statement to an OR. So this time only one of these have to be true. Let's change this one to 15. So because still x is greater than 10, 20 is greater than 10, even though it's not less than 15, it's greater than 15, it should still return true because one of these is true. This one is true. So let's again run the file, and we get true again. And because the statement is true, to get the opposite we can use the not statement instead. What we do here is we specify the not and use parenthesis on both sides. And now if we run the file again, we should get a false instead, and we get a false. Now if we look at a real world situation where we can run this, let's make something up like made underscore profit equals true, summer equals true. Now if we type if made underscore profit and summer, colon. Let's print book a holiday. Otherwise, if one of those is not true, let's print. Keep going and you will get there. So now, because both made profit equals true and summer equals true, it should print book a holiday. Let's run the file. And it shows it prints out book a holiday, but if we change this to an or instead, and let's change one of these to a false. Well, actually, in this situation, it will still print out book a holiday because either of these have to be true now, or so one of these have to be true, and because made equals profit is still true, even if it's not summer, we can still book a holiday. So let's run that again, and it still prints out book a holiday. But if we change both of these to false, this time it should print out the else statement instead, which is keep going, and you will get there. And we can also do all of this with user input as well. So if I start from the very beginning again, and let's type profit if input, how much money did you make today? And then we can do if profit is greater than or equal to 50 and profit is less than or equal to 100, let's print you made a regular day's profit. And let's also print good luck tomorrow, and if you make 100 or more, you will exceed your target. One thing I've missed out is I need to specify the data type of integer. And I've got my indentation wrong as well, so let's remove that. Let's run that. So it's asking how much money did you make today. Let's type in 70 and it will print out you made a regular day's profit, good luck, and if you make 100 or more, you will exceed your target. But if I type in something that is below or above the threshold, let's go with 101, it will print out nothing. So basically it's not printed out these statements, it's got nothing else to print out because there's nothing else here. We can add things in if we wanted to. Let's start by fixing this indentation as well. Let's just bring it back a little bit, and then we can use, let's say, an elif statement instead and do something like profit. So if profit is less than 50 or profit is greater than 100, let's print. So that needs to be on the same line. That's missing an I. That looks better. So if we run this again, how much money did you make today? And let's type in 20 this time. So it's below 50 and it should print out the second statement. So here we go. You did not make any profit or you exceeded your target. And that's a perfect example of using the or statement. So here we're saying if it's below 50 or it's above 100, then we want to print this statement out here. Where this statement we are saying if it's between 50 and 100, print this statement here. So we use an and. And this is just an example. There's thousands of use cases out there for this. It could be about the temperature, it could be about the time of the day, or anything else. And with not, you just specify the not statement as we did previously in between, and we can do that for this one as well. So this time if I specify 20 again, I should get the opposite and I shouldn't get this statement. So let's run the file again. And there we go, we get the opposite. You made a regular day's profit, good luck tomorrow, and if you make 100 or more, you will exceed your target. So I got the opposite output. And that's the last of the operators. That's how we use logical operators.
In this video, we'll take a look at the string index method. In Python, string indexing refers to accessing individual characters of a string using their position, or also known as the index within a string. Using the string index, you are able to find and print a particular character or sequence of characters within a string. And if a character is found, it returns the first occurrence of the index using numeric values, starting at 0. So with the index starting at 0, this means the first character is a 0 and the second character is a 1, and so on. You're able to use a -1 or a -2 as well, and in that case you can count backwards from the last character. So -1 is the last character and the -2 is the second to last character, and here is an example of how we may use the index method. But looking at the syntax, so the syntax is string.index, and then you specify the value of what you are looking for, and then a comma. And then you can optionally specify the start and end of the index, where you want the search within a given string to start and end, followed by a closed parenthesis. And one more thing about the index method, if a value is not found, it raises an exception. And this brings us on to another method for finding characters within a string, which is the find method at the bottom. The index method is similar to the find method. In fact, they are very similar. But when searching for a substring within a given string, the find method returns a -1 if the substring is not found, where the index method throws an exception. So these are the major differences between the two. And the use case for each of these is you would use the find method if you want to search for a substring but do not want to handle an error if the substring is not found. And this method is helpful when you expect the substring might not be present and you want to check the result before proceeding. Where the index method, if you wanted an exception to be raised when the substring is missing, this might be the preferred choice where the absence of a substring is considered an error and you want Python to return the error so that you can handle that error accordingly. On this page we've got 3 use cases for using the string index method. And the first one is accessing certain characters. So you may want to extract certain characters from a string. So the username equals Jack Sparrow and our first underscore character equals username. And in brackets, I've got the index position of 2. So the output of 2 will be C. So it starts from 0 for J and then 1 for A and then 2 for C. And the last character I've got -2, which is an O. So we have -1, which is the W, and then -2, the O. The next example is data validation, when you need to validate specific patterns, such as if you are checking a string starts or ends with a specific character. So I've got if my string, and then I've got in the brackets, the square brackets, a 0, so that's the index position, a 0. And then if it equals the comment sign, the hash, print comment. So we are indicating anything with a hash starting at 0, this is a comment. And the last example is a substring extraction. You can extract parts of the string. For example, extract telephone numbers, names, IDs, car registration plates, order numbers, or any other keyword from a string. And the example I have is about the email domain. So we are slicing to extract a substring from a larger string. So in this example, we are extracting the domain from an email. So in the first line, we've got email equals jack@my_company.com. So the line assigns the string to the variable email, and the second line is domain equals email, and then we have Python's built-in string manipulation functions, which extracts the domain part of the email address, the part after the @ symbol, and assigns it to the variable domain. This method returns the @ position of the first occurrence of the @ symbol in the email string. In this case, the @ is at index 4, because J is at 0, A is at 1, C is at 2, and K is at 3, and then we've got at position 4. And the +1 adding a 1 to the index of the @ symbol moves us to the next character, which is the first character of the domain. In this case, this index would be 5, corresponding to the letter M. And this is also string slicing as well, which we will be having a look at in the next video. It means taking the substring of email starting at index 5 and going all the way to the end of the string. So the slice extracts the substring from the 5th index onwards, which is my_company.com. It will make more sense when we have a look at the slice video on this part. And of course, the last part prints the domain, my_company. So those are some use cases. Let's jump into PyCharm and have a look at some examples. We are in my PyCharm application, and the first thing I will do is create a variable. So the variable will be my_string. This is Jaffa's string, 1, 2, 3, 4, 5, exclamation mark. Enter. And then x equals my_string dot index, bracket, quote s quote. Let's look for s within my string. And then we will do print x. Let's run the file. So it's found that s is in position 3 of the index, which is 0. It always starts with a 0, 0, 1, 2, 3. Let's do string and see what that gives us. And it says it's in index position 16. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But if we change the first letter into an uppercase, this time it should not detect it. And here we go. So it's returned an exception. So with the index method, it returns an exception when nothing is found, unlike the find method, which returns a -1. Let's actually try that. Let's put in find instead here. Find, and let's run that instead. And there we go. It's returned a -1 instead. And actually, it's just occurred to me with find, there's rfind as well. So it would find the last occurrence of the string or the substring sequence, and that's the same for index as well. There's index. So if I do index instead, and we can see there's two variants of is. There's is here and is over here as well. So if we type is over here to say we're searching for is, and let's run that, and we can see it's given us an index of 5. So 0, 1, 2, 3, 4, 5. It's found the second one. That's the last occurrence. If I remove the R and run it again, this time it's given us the first occurrence, which is a 2. 0, 1, 2. Another thing we can do is specify the start and end value. So we can specify, let's say 3 and 20. And let's look for the character or the value I. Actually, let's change this to 1 to start with, and let's run this. So it's given us an index value of 2. So it's saying start 0, 1, and then it's found the I here in position 2 because we started at 1. So it's included between 1 and 20. But if we say start at 3, it should ignore this one, 0, 1, 2. It should start at the S. So it should find this one here, which is an index of 5. Let's run this, and there we go. It's found the index value of 5, ignoring the first 3 positions, 0, 1, 2, 3.
We had a look at the index method in the previous video, and in this video we're going to have a look at the Python string slicing method. With indexing, you are able to access an element in a sequence using its position in the sequence, in other words, its index. So you are able to find out what position a particular character starts at, for example. However, with using the slice method, you can extract parts of a string. So maybe you want to extract some information from a string, like the email domain example we looked at in my last video. Although that was a video on the index method, we did have a look at how to extract the domain from an email, which is actually the slicing method. But it could be anything. It could be telephone numbers, names, IDs, car registration plates, order numbers, or any other keyword from a string. The slice method returns the extracted part in a new string and does not change the original string. And here is the syntax. Start indicates the position where the slice begins. Default is 0, so it includes the very first character. End indicates the position where the slice stops, and step indicates the interval between the characters to include in the slice. Default is 1, so every character is included, but you can include every second character, for example, by specifying this as a 2. By the way, slightly going off topic, here is the difference between the slice method and the indexing method. We can see the features on the left hand side: purpose, syntax, return, flexibility and errors. So for purpose, the slice method extracts a range of characters where the indexing method accesses a single character, and we can then see the syntax and what they return. So a slice returns a substring, and the index can return a single character or the position of a single character. In terms of flexibility, slice can skip characters, reverse or extract chunks, and the indexing only retrieves a specific position. And in terms of errors, you can specify out of range slicing, which is safe, which returns an empty string. But for the indexing method, out of range indexing raises an index error. Here are some examples, and the first example is extracting the first 3 characters, and a use case for doing this is if you are processing names, codes or words and need the first few characters, for example initials or a prefix. So we can see the word equals hello, and the second line we store this in another variable called first_3, and this equals the variable word from the first line. Now we have the slice method. We can see :3. So with the :3, this slice starts at index 0, the beginning of the string, and ends before the index 3. Because Python slicing is exclusive of the ending index, so it includes 0, 1 and 2. And because it's :3, we are not looking at the start of the index, we're looking at the end of the index. Because if we wanted to indicate something at the start of the index, excluding 0, we would specify this before the colon. So that's why it starts at 0, because 0 is default: :3.
The next example is getting the last two characters, so obtaining the last two characters. And this is useful for checking file extensions, for example .py or .txt or any other suffixes. So we can see in the blue the code we have word equals Python, and we want to retrieve the last two characters. So slice from the second to last characters to the end, and we can do this with a -2 colon, because the -2 index will start counting two characters from the end. So n will be a -1 and then o will be a -2. And then we specify colon. And if you can see, we have nothing after the colon, and having nothing without an end index means continue to the end of the string. So start from -2 and o and continue to the end of the string. So it's o and n. And by the way, we can see the output. So the first one is print first _3. So we are printing the output of this middle line, and the first three characters of hello is hell. And the next one was slice from the second to last character to the end. So the word was Python, and it printed out the last two characters, O and N. The next example is removing the first character. So a use case for this is you might want to strip a leading character like a pound sign in £100, and then we are going to store this inside a variable called without underscore first. And then we are going to slice the string inside the variable word, which is example. And we're going to start from position 1. So because it starts from position 0, the E will be excluded. So slice from the second character index 1 to the end, because there is nothing after the colon. And we can see when we print without underscore first, the output is example without the E. The next one is extracting a middle portion. So use case for this is, this can help extract specific sections of a string, like a substring from a text. So the example we have is word equals programming, and here we're using two positions, so 3 and 7, which slices from index 3 up to, but not including index 7. So it would be 0, 1, 2, 3, and we can see the output here, gram, so it does start with 3, and then it's 4, 5, 6, and we do not include 7, so up until 7, so it would be 6. So this is why it extracts the substring gram. The next one is extracting the entire string. So you may want to do this if you need to copy the full string without any modification for safe use in transformations. And we are slicing from the start to the end by not including anything before and after the colon. And the output, so this is the full word slice. The next one is skipping every other character. So we could do this. It's useful for creating patterns or extracting alternating characters. For example, a sequence of letters. So we have the word A, B, C, D, E, F. And here we are using a double colon because we're not doing anything with the first two, the start and the end. If you recall the syntax, we could use something called step. And we have indicated 2 in here, which is the interval between characters to include in the slice. So this is saying slice from the start, skipping every second character. And that's why we get the output of ace. So it's included A, it starts from the beginning. We've not indicated where we are starting from, so the default is 0. There's no end as well. We've not indicated anything at the end, so it goes on right until the end of the string. And then it's skipping every character. So A, C and E. And that's why the output is ace. We can also reverse a string, so reversing text is common in palindrome checks or for specific formats in text processing. So we've got the word equals backward, and if we indicate the step is a -1, this will slice the string from the end to the start because we have not indicated anything in the first two colons, but the step being a -1 would reverse the word. So we've got the word backward, and the output is backward in reverse. So those are the examples. I've done a quick PyCharm live demo where we go through a few very simplistic examples. And the first thing we will do is create a variable called myString. So my_string equals, this is Java string 12345 exclamation mark. Enter, print my_string, and then using the square brackets, let's find the third index in my string. So this would be 0, 1, 2, 3. So this should return the S. Let's run that. And we can see it's returned the character S. We can also see it says indexing over here. Performing indexing tasks. We can also start from the last character and work backwards as well. And as 0 is the first character, -1 is the last character. So the exclamation mark is -1, -2, -3, -4, etc. Let's go with -3 and it should give us a 4. And that's returned a 4. And if we wanted to print out more characters, let's say this is, we can do that as well. So that would be 0, 1, 2, 3, 4, 5, 6, 7. And we need to do it for 7, which is the blank space after the S, and not 6. And this is because it prints out everything up until 7, but not 7 itself. If we went for 6, it would not include the S. So we need to include the 7. And the way we do that is 0 for the start of the string, 2 dots, and then 7. And let's run this. And it's printed out this is part of my string here. And what else we can do is start it from a certain starting point by removing a value. So if we remove the 7, let's go with the 3 for the first value, and let's run that. So we can see it's ignored 0, 1, 2, and it started from the S, and it's got the remaining string printed out. And we can do it the opposite way as well. Let's type in 9 on this side. After the colon, let's run that. So we can see it's counted 8 strings from the start. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Because it does not use the 9. So it's anything before the 9. Anything before the number you specify. And for the last example, let's have a look at how it works with lists. So I've already copied one. Let's paste it in. Let's call it my list. Let's call it my list here as well. And just going a little bit off topic, PyCharm is really good because it gives you suggestions. For example, it's telling me I've got a white space between print and my list. I always do that. But to follow best practice, it's to remove the space. Now if we leave the values the same in here, it's going to print out up until 0.9. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it doesn't include 9, so it should include 1, 2, 3 and the comma as well. So let's run that. And there we go. It's printed out my list up until the point of 3 and the comma as well. Welcome back to another video. In this video we'll take a look at functions, what a function is and how we would create our own functions. From a high level perspective, a function is a block of code that performs a specific task, and functions help with writing less code. And what I mean here is a block of code belongs to the function. So rather than writing the same code again and again within the program, we just call the function every time we need it. If you have been following my Python video series, we've already used some of Python's built-in functions. For example, the print function for printing things to the console, and the input function for letting the user input something using the keyboard. Also the length function to determine the number of items in an object, and the type function to determine the type of data we are using. For example, a data type list, or a set, float, integer, etc. Although technically speaking, the last two are referred to as methods because they are tied to an object. And behind the scenes, these functions are, again, blocks of code. We don't need to write these blocks of code each time we need them, as that's what the function is there for. We use the function instead. We can also pass parameters and arguments into the function inside the parenthesis. So we can see each function has an open and closed parenthesis straight after it. So we can also pass parameters and arguments into the function inside the parenthesis. Basically, parameters are placeholders defined for values that functions require, and arguments are values or information that we specify in place of that parameter. And by the way, I do have a dedicated video on this, so a dedicated video on parameters and arguments within functions. And one more important thing about functions, the function should already exist when you call the function. So it's best to place your functions at the top of the code. This means wherever you call the function within the code base, Python knows that the function already exists because it's already seen it at the top of your code. And now if you go to the official Python documentation, python.org, here is the link. Here are the other built-in functions that Python supports, so we can see all of them here. We have the input function here, and we have the print function here, the power of function, the absolute function over here, the length function over here, the range function, the round function. So these are all of the pre-built, predefined functions that come with Python itself, and you can read more about these on the official documentation. And this slide is on creating our own user-defined functions. So when we create a function, or when we define a function, we use the def keyword, which is used to define the function. So we start off with def, then we specify the function identifier, which is a name for the function. So you give the function a name to identify the function, and then a function ends with an open and closed parenthesis, and optionally parameters inside them, and a colon, which indicates the start of the function's block of code. And sometimes we need to return the result of the function back to the caller, and this is where we specify a return statement. Now, before we dive into PyCharm and start to create functions, in blue we can see a block of code to create VLANs from 1 to 10, and I may be using this multiple times in my program. So I'd rather create a function for it, and then I can call upon the function rather than repeating this block of code everywhere in my program. We are going to have a look at this one as an example in PyCharm, but just to have a look at how we would do this, here's the same block of code on the right hand side. Then we've got the def keyword to create the function, and then our name of the function, I've called it VLAN_ID. Then we've got the open and close parentheses followed by a colon. And then of course our block of code. That block of code should be tabbed. So the top line in red defines our function, and then wherever we need to call the function within our program, we specify the name of the function, which is VLAN_ID in my case, followed by the open and close parenthesis. Let's have a look at how this works in PyCharm. We are on PyCharm, and let's type in some code to gather the user's name and age, and then we will convert this into a function. First, let's run the file just to make sure it's running without any errors. So I did miss a comma. Enter your name. So I'll enter my name. And then age. So the program runs fine. I could have also done formatted string instead. And let's rerun the file again just to make sure it works, which it does. So now we can define it as a function. And to do that, we type in def for define. And this function I want to call user_ID to gather the user ID for a user. Open and closed parenthesis followed by a colon. Right now we have to indent the code so that Python knows it's part of the function. So now that's created the function, and our function is called user ID. And as usual, a function has an open and close parenthesis. So let's run the file. And it doesn't actually run the file because we have to call the function. Now all this code is part of this function here. We've only defined the function. We have not called the function. So even the print function as part of this code is not going to be executed as it's part of the function itself. We need to call the function for any of its code to be executed. So the way we do that, just like the print function, user_ID, open and close, parenthesis. And now let's run the file again. And there we go. So now it's running the code. So if I need this block of code again in my Python program, I just need to run the function, which is this here. So now let's start off with a clear screen. And let's create our VLAN example. So we have configured our code to create VLANs 1 to 10. Let's run the file to make sure the code runs, which it does. Now let's create it as a function. So again, def, let's call this one VLAN_ID, open and close parentheses, followed by colon, and let's indent everything. And that's it. So if we run the file now, it's not going to run the code because we need to call the function. Let's call the function VLAN_ID. And let's run the file again, and this time the file runs perfectly fine. And that's it for this video. That's how we create functions. So we can reuse code by calling the function. Welcome back to another video. In this video we are going to take a look at parameters and arguments and how they are used as part of Python functions. Let's have a brief look at what parameters and arguments are. Parameters are placeholders defined for values that the function will require. And arguments are values or information that we specify in place of that parameter. and these values are passed in as arguments. So you can see it as a parameter is the variable or variables listed inside the parenthesis within the function definition, and an argument is the actual value or values that were passed to the function when we call it. An argument could be any object as well, such as a string or an integer, etc. And below I have an example in red where we define the function. We can see the parameters in blue in the parenthesis after the def keyword. Def, by the way, stands for define, which we use to define the function, and then the function name, which is profit. So def profit, and in blue are my parameters, profit_1 and profit_2. And in this function we are basically adding profit_1 plus profit_2, and then we are printing total_profit to the screen. Now further below we've got profit, and then in brackets we've got 30 and 40, the values 30 and 40. And when we call upon the function we specify the arguments, which are the actual values, which in this case we call upon the function profit. And in here we specify our arguments, which are for the parameters. So we need two of them because we've got two parameters. And these will be our values for profit_1 and profit_2. So let's say I have two businesses, and the first business made 30 euros or $30 or £30. And then my business 2 made 40. So I can put these values in here, and the output will be the result of the two values added together. So as we can see, parameters are essential in Python functions because they allow functions to accept input, making them more flexible and reusable. Now I have a more simplistic example of a function without parameters versus the same function with parameters. So on the left is a function without parameters, and on the right is a function with parameters. So we can see a very simplistic use case, and it may help you make more sense of it. So on the left we are greeting people, and the greeting is generic, which says hello people, and this function cannot be customized. So we have def hello, and then we do not have any parameters used, and then we are printing hello people to the screen. And when we call upon the function, the output is hello people. Now using the same function with parameters, or we can see it as enhancing the functionality, on the right hand side we use a parameter inside the parentheses called name. So now that we have this parameter in place called name, we need to specify one argument every time we call upon the function, and then we print hello, and then we have specified our parameter again, name. So now it knows it needs to fulfill this parameter with an argument every time we call upon this function. And when we have called upon the function, we specify our arguments. So I can specify names in place of the parameter, which is Jack and Jill. So I've specified people's names, Jack and Jill, and we can see the output is hello Jack and hello Jill. So these are two very simplistic examples. On the right it's about greeting people using their names, and on the left is about adding two values together. Let's have a look at some live examples in PyCharm.
And now we are in PyCharm. I'm going to paste my first bit of code, which is our user ID function. So in our previous video on functions, we created a function called user ID where the user can specify their name and age. But let's say we specified the name and age for the user. So let's remove the two lines requiring input from the user. Now if we defined a name called Jack and the age of 40, it runs as expected. We can see Jack is 40 years old. But then what if we needed more users and their ages as well? So let's paste in another user ID. And now we have Jill, and she's 30 years old. So let's run the file, and we see Jill is 30 years old. Using the function, it's printed out the last variable name and age. So this does not work really. So it's printed out Jill at age of 30. It's not printed out Jack at age of 40. So what we do instead is we define and use parameters and arguments. And a parameter is the variable listed inside the parenthesis in the function definition, and arguments are the actual values that were passed to the function when we call it. Again, an argument can be of any data type, such as a string or an integer. And the way we do this is we remove these variables, and in the parentheses we can specify our first parameter, name. And then when we call on the function here, user_ID, inside the parenthesis, we specify our value, Jack. Now if I run the file, I've got an error because age does not exist. So I need the additional parameter of age, and we add another argument, our age, 40. Now let's run the file again. And this time it says, perhaps you forgot a comma, which I have here. So let's add a comma and run the file one more time. So now I get Jack is 40 years old. So one thing we have to bear in mind, if we have two parameters, we have to have two arguments. So if I remove 40 again and run the file, we can see it's complaining here saying missing one required positional argument, age. Because it knows about this, it exists within the parameter itself. So again, we need to add age with a comma, and it runs. Now we just duplicate this line, and then we can specify the user ID for Jill and run the file again. And we can see Jack and Jill has been printed to the console. So this time it works fine. Now we can create lots of these user IDs like we just did for Jack and Jill. And so this is one example of how we use parameters and arguments. But let's have a look at one more example. Let's have a look at the examples I've been using in previous videos, which is about profit. So adding two numbers together. We have a function called profit, which is in our parameters. We have profit1 and profit2. And what do we do with profit1 and profit2? We store it in a variable called total underscore profit, and we add them together. Profit1 plus profit2 would be stored in the variable total profit, and then we will print total underscore profit to the console. Now again, if I miss one of the arguments, we can see we will get the same error. So if I put in 40 again, so that's our first profit, our first argument, 30, and our second profit, our second argument of 40. Let's run the file, and the result is 70. And that's a high level overview of parameters and arguments. The Python return statement is a key component of functions, and for that matter, methods as well. So usually we call a Python function and it does its thing. It executes the block of code as part of the function, and then it continues through the rest of the program. However, there are times when we need to get information back from the function. This is also known as returning information back to the caller when we call upon the function. So technically speaking, a return statement, which is a statement by the way, where the print is a function, the return statement terminates the execution of the function and sends the return value back to the caller code, so you cannot type any code after the return statement. And in red we see the user ID function, which is made up of parameters profit1 and profit2, and then we add these together, profit1 plus profit2, and then we return total underscore profit. And when we call upon the function in the second set of code, we print total underscore profit to the screen. However, it's easier to understand when having a look and running the code itself, so let's jump into PyCharm and have a look at that. So going back to our previous example, when we had a look at parameters and arguments, we have a defined function called profit. And because we have the print function within the block of code as part of the function definition, it prints fine and we see the output of 70. It adds 30 plus 40 together. But we do not necessarily need to print the output every time we run our function. It could be a function that does a specific task, but you do not need to necessarily print the output to the console. So we do not always need this statement here. So let's remove the print line from our block of code, which defines the profit function. Now, if we run the file, we get nothing, which again may be fine in some use cases. We may run this function in lots of places in our code, and we do not necessarily need to print the output. But let's say there's a specific time somewhere in our code we need to print the output to the console. So let's use our print function over here. Let's print it to the console and see what happens. Let's run the file again. So previously we had nothing, and this time we get some output, but it's not the output as expected. We get a none. So it's telling us there is no output from the function. And this is where we need a return statement, because we need to return the information or the output of whatever the function did, whether it's a value or some other object. We need to return the output to the caller. So without the return statement, we're not able to print anything. So this is where we add the return statement. So the keyword is return, and what will we return is we will return the total underscore profit, so the value of profit underscore 1 plus profit underscore 2, which is stored in total underscore profit. So let's double click this. And as already explained, once you specify the return function, you're not able to specify any more code as part of this function block. Nothing else will run. And let's run the file. And this time we can see we get the output we expected, which is the value 70. So when a function takes an argument, like it is here, it's taking two arguments, 30 and 40, and it performs some kind of operation. So we can see over here is adding the two numbers together, and then it returns the value or the object. As if it did not have this statement to return the value, there's no value being returned. There's no value being sent back to us. So although we gave it some arguments, so without this line, we did not ask it to return anything back to us, but adding this line in, now it's returning something back to us, which is a value. And this value that the function returns to the caller is known as the return value. And all Python functions have a return value, whether that's explicit or implicit. So in effect, it's returning the function's result back to the caller, the output, the result. And when I say back to the caller, the back to the caller part is this part here, where we are printing it to the console. So we are calling the function profit with our arguments inside it. And as we have seen, if we do not use the return value, there is still a return value which is none. And this will be the case if we do not use the return statement, or even if we do use a return statement with nothing specified after it. So let's remove total underscore profit and run the file again. We see again it's come back to none. And we do not need to directly print this to the console. We could put the result inside a variable. So now we are storing the output of these arguments, and what happens to these arguments is determined by the function definition. And now we are printing total underscore profit to the console. So let's run the file. And of course, I've removed it from my return statement, so let's add it in again and run the file. And that's it for this video. That's a high level overview of how return statements work in conjunction with functions.
Welcome back to another video. In this video we will have a look at Python modules. So imagine this is your main program, the box on the right hand side in black, and all of your code is in here. But now that you've been working on it for a while, you have a bunch of functions, classes and variables in here, and the file starts to become very large and looks very heavy on code. So you have lots of code in this file, and so this is where modules come into play to separate some of that code into separate files. So you separate your related functions, classes and variables into different files. Then you import these files, or even subsets of code within the files, into your main program as of when you need them. So modules contain definitions of functions, classes and variables, and help organize by grouping related functionalities together. And by using modules, you can break a large program into smaller, manageable and reusable parts. So by doing this, it helps us write clean, organized, efficient and maintainable code. Let's go over these bullet points before we have a look at modules in a live demonstration. So in its most simplistic term, a module is a file with a group of related Python code inside it that we can import and use elsewhere. We use these modules to organize and group our code into separate files, and then we import them in our program when we need to use the code within the modules. For example, rather than, let's say, creating 20 functions in our code, we could just separate these functions into separate Python files, which are known as modules, and import them into our main program when we need them. So rather than having lots of functions in a single file, it's better to group them together and put them inside modules. And by grouping code, it keeps our files less congested and bloated, and our code would be much better organized and easier to manage. And we are not repeatedly creating the same code. Also known as dry, don't repeat yourself. It's one of the best practices of writing code. So they are there to organize related functions, classes and variables, or any blocks of code in the same file, and the file name is the module name with the suffix .py appended to the end of the module. And to import the module, we use the import command followed by the module name. So import profit, for example.
I'm going to skip this part and we will come back to it. So on the next slide, we can see the types of modules, and there are three types. One is the predefined module. There are predefined and built-in modules, and you would still need to import these even though they are built-in. User-defined modules, so you can create your own defined modules, your own user-defined modules. So basically create your groups of functions, classes and variable definitions and your other code, and save them as a .py file. And there's your user-defined module. We will do this very shortly. And the last one is external modules. External modules need to be downloaded, and you can install them using a package manager like pip. And going back to the built-in predefined modules, And these are some of the common modules in Python, which are datetime, used for manipulating the dates and times, HTML for parsing HTML pages, JSON, encoding and decoding JSON format code. So Python has a built-in module called JSON, where you are able to read JSON documents with the JSON.load method, or you can convert your data into JSON files with the JSON.dump method. Those are two examples of how you would use the JSON module. Then there's login and event login system for applications. Maths are a very popular module for performing mathematical functions. Nmap, used to discover hosts and services on a computer network. Random number generator, so generate pseudo random numbers. OS, using OS operating dependent functionality. The sys module, access to system specific parameters and functions. RE for parsing regular expressions. And time provides various time related modules. Now I've only listed a few of the modules. To get an insight into the full list of Python modules within the standard library, by the way, so there are many libraries, we can have a look at these modules on the python.org webpage. It's called the Python Module Index, which we can access on the link from the right hand side. And if I bring my web browser across, so the Python standard library contains over 200 modules, but varies between distributions. And we can see all of the modules in here available to Python. So we can go to the module index on the Python website on this link here, and you can see all of the modules, or you can browse by the alphabet. So if we hover down, we can see all the modules here, and we can open them up to see how they work, to understand how they work. So the math module is a very popular module, looking at mathematical functions. And if we go in here, we can see how the math module works and all of the methods that are part of the math module. So we can use these mathematical functions in our Python script, for example, math.floor. So there's lots of these. If I hover down, and I've done a separate video earlier in my video tutorials on this particular module, so you may want to have a look at that. But for this video, we'll have a look at how we use the math module and we get access to all of these methods. So going back to the PowerPoint slide and going to the previous slide in particular, and if you have been following my videos, you would have seen I have done some functions. And one of them is the profit function. So this is a very simple function which adds two numbers together. So it's representing two online businesses. But in this example, I need three separate functions. So for example, if I had three online businesses, I'll call one profit 1 and the other profit 2, and the other online business would be profit 3. Now if I wanted to work out the total profit for profit 1 and profit 2, I would run function 1, which is the total underscore profit, which is profit underscore 1 plus profit underscore 2, and this would give me the result of profit 1 plus profit 2. But if I wanted to work out the total profit for my online business 1 and online business 3, I could use function 2, which is profit 1 plus profit 3. And then function 3 does online business 2 and online business 3, so profit 2 plus profit 3. So let's have a look at these three functions, how we add it into a Python module, and then we can import it into our main Python program so we can utilize the functions. We are now in PyCharm, and what I'm going to do is paste in my three functions. So I've pasted my functions into first pyfile.py. I've got my function 1 separated by space, function 2 and function 3. And we can see the names of each function: profit underscore 1 underscore 2, profit underscore 1 underscore 3, and profit 2 underscore 3. If we save this now as a new file, or should I say module, and we will call it profit. So profit.py, and let's click OK on that. And that's it. We have a module called profit.py, and we can utilize this module or import it into our other Python files. So if we go back to first py file, let's remove the three functions from here. Now let's say this is our main Python file, our main code, and we need to import a module. And in this case, we need to import the module profit. So how we do that is we specify import followed by profit. And we can see it's already there for us to select. So let's double click profit. And that's it. We've imported our profit module. So now what we can do is if we type profit followed by the dot operator, or sometimes it's called dot notation, we can see our three functions here. So profit underscore 1 underscore 2, profit underscore 1 underscore 3, and profit underscore 2 underscore 3. Now as all I need to do is double click one of these, type in the print before the function, and put it inside parentheses. We can use our function. So this function takes two arguments, as we can see in the module. We can see we've got two parameters, profit underscore 1 and profit underscore 2. So we need to specify two arguments. These are our two numbers that we are going to add together. So let's go with 10 and 20. Now let's right click and run the first Py file. And we can see the result on the right hand side, which is 30. Now we can also access part of a module. You do not need to import the complete module into your Python file. And this is done using the from keyword. So in this situation, we could import a specific method from the profit module. So let's hash this line, and instead here, let's use our from keyword. So it's from, followed by the module name from profit. And then which function do we want to import? So it's from profit import, and then we specify the function we want to import. So let's go with profit. And we can already see PyCharm has detected the three functions for us. So let's go with the top one here. Now previously we needed to specify the module name followed by the function name, and then we added our values in here. But when we import a specific function from a module, it already knows about the module. So we only need to specify the function this time. So it's print, and then our function, which is profit underscore 2 underscore 3 here. And let's go with two different numbers this time. Let's go with a 5 and a 10. So we should get 15. Now let's run the file, and we get 15. So because it already knows about the module, you just specify the function followed by what the function does, the arguments in our case. But if you are importing the complete module, as we did earlier, import profit, we need to specify the module name followed by the function name. Now, although we can use the dot operator, or also known as the dot notation, to see what's available to us inside the module, or we can open up the module file, I suppose, we can also find out what's inside the module using the dir function. The directory function. Python's directory function is used to display the names of all the functions and the variables present inside a module. And we can do this using the print dir for directory, and then the module name. So let's go with profit. Now let's run the file. So I have an error because I've not imported the module. We changed it to import a specific function inside the module. So let's import the module itself, profit, and now let's run the file. And we can see the result on the right hand side. If I scroll across, we can see our three functions right at the very end. Maybe if I move this screen to the bottom left, it might be easy to see. So now we can see at the very end, I've got my profit underscore 1 underscore 2. I've got my three functions. And of course, we can do this for the built-in modules as well. Let's import math, double click math, and now let's specify math as our module we want to print the directory for to see what's inside the math module. So let's run the file. And again, we have to scroll to the right hand side to see everything. We can see all of the functions, the methods inside math. For example, pi. But a better way to do this for larger modules, when you've got lots of things going on inside the module, is to run it inside a for loop. So the way we do that, for item in directory math with a colon, and then print, and let's print our items. Now we can run the file. I've got a double parenthesis in here. Let's remove one of these and run the file again. And we can see it's listed it out from top to bottom this time. Now we can utilize any of these methods in here. Let's use one. Let's use the square method. Let's change our code here and print math followed by the dot operator. Now let's pick our method, which was the square. Now let's find out the square root of 3 and run the file. And we can see the result over here for square root of 3. Now one last thing, if you use an overly long name for your module, you can use an alias for it just to shorten it up and make it easier to use. So for example, math, we can do as and give it an alias name of M, for example. Now we can reference it as M instead of math. And you can see why this would be useful if you are creating your own modules with difficult names and you are following a specific name case or a naming convention. And again, we ran the file and it's picked up the same result. Just to double check it's working, let's specify the square root of 5. And that's a high level overview of modules. So just to bear in mind, modules are a logical group of functionality that programmers can import in order to reuse their code or set of statements. And a module is just a name followed by the .py extension. And with the use of modules, it makes it easier to read, manage and organize your code, especially in larger Python projects. And one very key goal of creating a module is to prevent dry, so don't repeat yourself. Once your functions and classes and variables are inside the module, you can import them into other files rather than creating and duplicating the same functions, classes and variables in your different Python files.
In this video, we will have a look at the differences between modules, packages, libraries, and frameworks. We have covered off modules in the previous video, so you may want to have a look at that. And a module is a file that consists of functions, classes, objects, and other code. Basically, it's a file with a bunch of definitions and statements, and this file or module can be imported into your other Python files when you want to use the code. It's easier to manage and maintain this way. It's easier to manage and maintain the code into separate files when you have a lot of code. So your code is stored in separate files to make it easier to manage and maintain. And this is also due to something called dry, don't repeat yourself. So you don't have to keep repeating your code in different areas of your code. You just import the module that's already got the code inside it wherever you need it. And a few of the common examples of modules are math, date, time and random. And these modules are part of the Python standard library. So when you install Python, these modules amongst many other modules are installed with them. And moving on from modules, for larger projects, modules are grouped together and are available as packages. So a package is a collection of modules. So the packages are used to organize these modules or to distribute a set of functionality together. So you group all of these modules together that does a particular thing. For example, a group of modules may be packaged together to meet a specific requirement, such as authentication or logging, etc. And two popular packages are NumPy and Pandas, which actually can also be classified as libraries, which I'll explain very shortly. Now, for even larger projects, packages can also be grouped together, and a library is used for this. So a library is a group of packages. However, packages and libraries, the terms are used interchangeably, and this is very common. So you may want to see it as Python libraries are a bunch of predefined, pre-written code that can fulfill a specific requirement. They are designed to save time and effort by offering ready-made solutions to common requirements. Again, it may be for authentication purposes, logging purposes, image processing, data manipulation, or machine learning, or anything else. And examples of libraries are NumPy for numerical analysis, such as advanced mathematical functions, Pandas for handling large data sets for data manipulation and data analysis, requests for making HTTP requests, Matplotlib for data visualization, and there's a ton of libraries out there as well. I think there is approximately 140,000 libraries out there to use for all sorts of use cases. Now, where it can get confusing is that the terms library and package are often used interchangeably. Some applications are referred to as libraries and packages, for example Pandas and NumPy, and this is because a package which consists of modules, that's what a package is, it's made up of multiple modules, can optionally include sub-packages. And if we recall, that's the basic construct of a library. A library is a collection of packages. So with a package consisting of packages within itself and modules, it can meet the criteria as being called a library as well, because sub-packages are effectively packages. So as a summary, most refer to a package as a collection of related modules, where a library consists of a collection of related packages. And moving on to the last term, which is framework. Framework is a collection of libraries and tools, but beyond this, a framework also provides a set of rules, conventions, and tools to help you structure your code and build applications more effectively. It actually provides a framework in a way that guides you, so you don't have to do things manually yourself. Examples of Python frameworks. So Django is a very popular web framework used to build web applications. It comes with a bunch of built-in libraries and allows for the migration of databases to another database. Flask is a micro web framework written in Python. It is classified as micro framework because it does not require particular tools or libraries. It has no database abstraction layer, form validation, or any other component, where pre-existing third-party libraries provide the common functions. And then Web2Py is the last example of a framework. Web2Py is an open source web application framework allowing developers to program dynamic web content using Python. So to summarize everything here, a module is a file saved with a .py extension and consists of functions, classes, variables, and other blocks of code, also known as a file that contains definitions and statements. And a package is a collection of modules. A library is made up of a collection of related packages. A package, by the way, can be reclassified as a library because it may contain sub-packages and modules. So sub-packages means it contains a group of packages, which classifies it as a library as well. And then finally, a framework is usually a collection of libraries, but more importantly, it provides a set of rules, conventions, and tools to help you structure your code and build your applications.
In this video, we're going to compare frameworks to libraries. This is an area many people are confused in. So let's have a look at an analogy comparing frameworks to libraries.
So how exactly is a framework different from a library? So for example, there's lots of similar steps with applications the developers build, and it's likely many of the requirements you need to fulfill has been done before, and for these kind of tasks, libraries have been built. For example, an application you're working on needs logging, or it requires authentication, or it may just need to respond to HTTPS web requests, or RDP SSH connections, or it needs to connect to another server, such as a database, and so on. So even if the application you're building is unique, you still need to do all of these things, which are very common requirements or problems. And libraries exist for this very reason. You can see libraries as a bunch of code that have been purposely put together to solve common problems. And libraries can be used as many times as required to help you build your different applications. And there could be two completely different applications you're building, but you will still use the same libraries to build certain features. For example, let's say you're a plumber and an electrician. Some of the tools you will need will be the same, such as a tape measure and a drill. And this is the same for libraries with the different applications you're building. Libraries are your tools, the hammer and the drill. Now with framework, it's about building pretty much the same kind of application, but bespoke for different companies or different homes. So let's say you build bathrooms, you install the pipes, add the toilet, sink and bath. Now with this in mind, you're repeating the same tasks. You're using the same tools and methods or patterns to build these bathrooms. So with building bathrooms in mind, you create some very specific system that helps you measure and build the pipes for your toilet, and then it does the same for your sink and then the bath. It also detects leaks in your pipes to make sure your pipes are connected securely. It reminds you to tighten all of the connections and guides you through testing it all. So the tool is like a framework which is very specific to a particular system, in this case building bathrooms. So you're still able to build different bathrooms with different layouts and different measurements, but you would be guided by this tool and you are only able to build bathrooms. You cannot use it to do your electrician work or build your bedroom, for example. So comparing this to a library, with a library you build what you like and use the library as your tool to help you. So these could be your hammer, drill, etc. And you could use these to build a bedroom, to build a bathroom, to build any room in your house. With a framework, you would be using a particular system and it would guide you and keep you on track and ensure you're doing the things in the manner of how the framework has been designed for you to follow. So you cannot use the framework to do your electrician work or build your bedroom. It's designed for bathrooms only, or let's say in the IT world, it's designed for particular web applications only, unlike a library. So frameworks help you do the job and guide you, but you don't have the flexibility. And with libraries, you're basically on your own. So you have no guidance, no template, the framework, but you have the libraries to use anytime you need them, regardless of what you are building. So while the use of libraries is an available option, the preference often tilts towards frameworks. And this preference arises from the frameworks providing more guidance and being reliable, and facilitating the seamless extension functionalities through the tools they provide. And the use of libraries can be as challenging as executing a specific operation, requiring users to grasp the functionalities of each task. Unlike libraries, frameworks offer a structured flow, providing a basic foundation. This structured flow not only simplifies the learning curve, but also empowers the programmers or developers with better control over the applications. So with all that being said, libraries can be used for a specific requirement, but for an end-to-end application, a fully fledged application, most would tend to use a framework. Welcome back to another video. In the last video, we looked at the differences between a module, a package, a library, and a framework. And in this video, we'll take a closer look at libraries. First, let's go over some high-level details on what a library is. A library is a collection of pre-written code that you can use in your program by importing it in. Libraries typically provide functions, classes and variables, and objects. Basically, they are statements and definitions that you can use to perform specific tasks without having to write the code from scratch. So libraries are there to use to meet specific requirements. Libraries save time and effort by offering ready-made solutions to common requirements, so you don't have to write code from scratch yourself. There is a library called the standard library, and the standard library comes with a ton of commonly used modules, and you can see a complete list of the modules at the website over here, python.org. It's called the Python Module Index. It's basically this website here, and it shows us the complete list of modules within the Python standard library. So here are all of the modules you get with the Python standard library, and we will have a look at a few of these modules, the common ones anyway, such as the math module, as well as the random module, and the other one, the date time module. In fact, we will take a look at these next. So how do we get to see these modules? So we can see a complete list of the standard library, as we have already seen on the standard library index, or we can take a look at the standard library within our local systems, as these modules are just files, and we can see where they are typically stored. So the user local bin is for Unix based systems, or the program files Python lib is if it's a Windows based system. So these are the paths for the respective operating systems where you will find the libraries. Next, we'll take a look at the standard library within our local system. So I'll do a demo of this, as these modules are just files that we are able to access. So let's hover over to them now and take a look.
Now, if you don't know exactly where your files are, we can import a module. Let's say we import the sys module, and then if we run sys.path, it shows all of the paths for Python. So what we will do is x equals sys.path, and then we will print x. So sys.path is a built-in variable within the sys module, and it contains a list of directories that the interpreter will search in for the required module. So now if we run the file, we can see all of the paths for Python. If I scroll to the right, in particular, we can see C program files, Python version 3.11 lib. Or what else we can do, and this can be for the sys module as well, or for any other module. Let's go with datetime module instead. So let's import datetime. And then what we do is print its location by using a dunder method, which is a special type of method with a double underscore before and after. And the one we are after is called file. Now let's run the file. And what we can see is where the module is located. So again, program files, Python 3.11, library, and then we see the module, datetime.py. Now if I go to my Explorer and open up documents, let's go to my C drive, program files, Python 3.11 lib, and then let's search for D. I should get the datetime module inside here, and here it is. And we can see all of the other modules in here as well. So let's go back up to datetime and double click the file. And the file opens in PyCharm. And we can see the datetime module. Of course, there will be a lot of things going on inside here. But the whole point is you now know how to locate a module from the standard Python library, which is pre-installed when you install Python. So let's close the datetime.py module. And of course, the datetime module was just a file saved with a .py extension, although there's much more going on in the code than the ones that we created. So we already have datetime imported. What we can do is something like current underscore date equals date time dot, and the one that I am after is the top one, date. So let's double click date and again use the dot notation, and I can see the methods inside here, which is the first one. So we will double click today, and then we will print current underscore date to the screen. Let's run the file. And as we can see, this provides us with the current date of today. Or we can import another module. So let's go for this module here. Let's import random. So the first thing we will do is create a list. Let's call the list cars. Cars equal. So I've created a list of cars: Ford, BMW, Audi, Mercedes and Toyota. The next thing I will do is create a variable my underscore random underscore list equals random dot notation, and from here I will pick out list, not list, sorry, choice, this one here, double click choice, and inside the parenthesis we will pass cars as an argument, and finally let's print cars to the screen and run the file. Actually, it's printing out my cars to the screen. What I want to do is, what I actually meant is to print my underscore random underscore list to the screen. Let's run the file. So this time it's picking out a random item from my list. So the first time it's picked out BMW. If I run it again, it's picked out Toyota, again Mercedes, back to BMW, Ford, Audi. So it's randomly picking out an item from the list cars. And of course there's many other modules in here. There's the operating system module if you want to have a look at your operating system or do anything with it. So all of the files, so all of the modules are in here if you wanted to play around with them. If you wanted to gather some information with your operating system, this would be the module you need.
Welcome back to another video. In the previous video we had a look at the Python's built-in library and how to utilize it. In this video we will have a look at how to download and install external libraries for Python. So where do we get these external libraries from?
So just like software, they are in various locations and you would have to find them on the internet, but a good place to start is at pypi.org. Let's open up the browser and have a look at that. So we can download packages and libraries from pypi.org. So these packages you can install with something called pip. Pip is a package management software used to install and manage software packages. It makes things seamless when you are installing libraries and packages. But other places you can download packages from would be places like GitHub, Bitbucket and Anaconda. So if I open up another browser, and from Google I can type something like Anaconda packages, and we can see here Anaconda package list. And Anaconda aims to simplify package management and deployment. It is more focused towards data science packages suitable for Windows, Linux and macOS systems. Anaconda uses a different package manager than pip. It's called Conda. However, going back to Python PI, so PyPI stands for Python Package Index. The Python Package Index is an index of open source libraries or Python packages that have been contributed by the public community that we can download and install, and of course use it for whatever we need, for whatever purpose we need it for. In fact, if I scroll down, we can see it says the Python Package Index is a repository of software for the Python programming language. PyPI helps you find and install software developed and shared by the Python community, and you can learn more about it here. But pip is the Python installer package for PyPI, and it comes pre-installed with Python. So if it comes pre-installed with Python, you can imagine it's quite fundamental to Python. So this is definitely the source for packages, although there are many other sources as well. Just to give you an indication, there are approximately 140,000 libraries out there. So going back up, we can search for the project we want, or we can use the browse project, and it gives you a filter to browse with. So at the top you've got framework, then topic, development status, license and so on. The topic one is always a popular one for me. I like to view things by topic. For example, you can download something if you're interested in databases, desktop environments. Further down there's games, we can see education, we can see games and entertainment and so on. Board games, let's click on one and see what we get. So if I click one of these, it might be a good example, it might not be.
So we can see the release date of this package, and there's not much detail in here, so that's a bad example. Let's scroll down. Let's have a look at this one, a library for reading and writing files using the smart game format. Whatever that means, let's open up the tab, and we can see there's a project description and how we download it and the documentation for it, etc. So it gives you information about the library and how to download it and use it. And it's even giving you a link on how we would download it. So it's pip install and then the package name. We can actually download this package. So let's copy the link, and you can share your own packages here, by the way. You just have to register and follow some instructions. With all these packages, you can install them using the pip installer. This is a very simple way of installing packages right from your console. And the command prompt is used to install the Python package. So let's open up the command prompt. Let's ensure Python is installed. Python -- version would be a good one. And we can see it confirms the Python version. We could have also done just Python, which would have entered us into the Python console, but we don't want that. So for pip, what we do is we can just type pip actually to see what we get, and we see some information about pip. So it's telling us how to use pip, which means it's already installed. I can see version here, so it looks like it uses the same command as the one here, Python -- version. So let's try that as well to see what version is installed. Pip -- version. And we can see it's pip 22.3.1. That's installed on this local system. If it's not installed, we would receive an error message. Otherwise, we receive instructions on how to use the program. Actually, at the top, I could see install packages, different command options, download, uninstall, freeze, inspect, list, etc. So you've got lots of options with pip, but the one we want is the install option, the one that we copied from the link from the website here, pip install sgf-mil. So let's try that. And if I right click, it's pasted what I copied from the website, pypi.org, and let's hit enter. So it looks like it's done it because it says installing collected packages, and then it says successfully installed sgf-mil. It's even telling me a new release of pip is available and how I would update that as well. By the way, if you don't have pip available on your Python version, it comes with most Python versions unless you downloaded it from elsewhere other than python.org. You can go to the browser and type something like get pip, and if we go to the top link, we see how we would install pip. So it says pip is automatically installed if you are working in a virtual environment using Python downloaded from python.org, or using Python that's not been modified by a redistributor to remove. And then it gives you information on how to install pip. But for us, we've got it installed, and we've also installed a package using pip, and it was quite seamless. We didn't see anything, it just installed it. So the way we would verify that this application has been installed, we can type pip list-v, and this shows us the packages installed on our system. So we can see sgf-mil has been installed, and we can also see the version as well as the location.
In this video, I'll be going through some of Python's built-in functions, in particular the ones that deal with numeric values. So these are absolute, power, range, round, and sum. I'm going to go through each of the functions, and then we will have a look at them in PyCharm. The first function is the absolute function, which returns the absolute value of a number. For positive numbers, it returns the number itself, while for negative numbers, it returns the number without the negative sign. And a use case for this is calculating the distance between points. Next is the power of function, and this returns the value of one value to the power of another value. The power of function returns the value of a number raised to the power of another number. It also has an optional third argument, which is the modulus value, and the modulus value helps to find the remainder of the division after raising a number to a power. And the use case I've got is compound interest calculations, but of course it can be used in many other mathematical computations such as exponential growth, physics and engineering, geometry, and many other things. So I'm listing one use case for each of these just to give an example, but there are many other use cases. The range function returns a sequence of numbers. It accepts up to 3 arguments: start, stop and step. The sequence starts from start, stops before stop, and increments by step. And a use case of where it's used is in batch processing in data analysis. Then we've got the round function, which rounds a floating point number to the number of decimals specified. By default, it rounds to the nearest integer if no decimals are specified. And a use case for this, actually I've got a few use cases, which is rounding to custom intervals, currency formatting and invoicing and billing. And the last one is the sum function. So the sum function calculates the sum of all items in an iterable, like a list or a tuple. It also accepts an optional second argument, which is an initial value to start summing from. And a use case for using the sum function is cumulative totals in games or applications.
The first one is the absolute function, ABS, open parenthesis and closed parenthesis. And this returns the absolute value of a number, which means positive representation of the number we specify. The absolute value of a number is never a negative number. It can return the absolute value of the given number in integer, float or a complex number. So we have specified the absolute value function here and specified a negative number inside it, minus 321.25. And we are going to store this information inside my underscore ABS variable, and then we are going to print my variable. So let's print the file, and it turns it into a positive number, 321.25, which is the absolute value. So the absolute value is 321.25. And if you're wondering what the absolute value means, it refers to the number's distance from 0. And they are very much used in math and physics, especially when you need positive numbers and you cannot use any negative ones. So this is an instance of where you would use the absolute function. If we clear the screen, the next one is the to the power of function, which returns the value of one value to the power of another value. For example, 6 to the power of 3, which basically is 6 times 6 times 6. So here we can see its function has 6 to the power of 3 inside it, and we are going to print the variable my underscore pow. So let's run the file, and we can see 6 times 6 times 6 is 216. You can also add a third number in here, and if you add a third number or parameter, you can use the modulus operator. So let's put in 3 and run the file again, and this time we get a 0. Let's change that to something else like 7, and we can see this time we get a 6. Next we will have a look at the range function, and the range function returns a sequence of numbers. You can also specify the increments, which is 1 by default, and you can also specify the numbers of where you want to start and stop. This one in particular works very well with the for loops, as we have seen in the previous videos on for loops. So this code will print the values of 2 to 9. So you always go one number above the last number you want to print. So that's why we have gone with 10. And if we want to increment by 2, we would add that as the third value as well. So we can do that here. Let's increment by 2 and let's run the file. So we can see 2, 4, 6, 8. If we remove this altogether and run the file again, this time it would print the digits 2 to 9. Incrementing by 1, which is by default. Or we can do something like print everything right up until the value of 15. So we can put 16 in here and then run the file again. Now we can see it's printed 0 to 15. And that's the range function. So let's clear the screens again and have a look at the round function. And the round function will round a floating point number to the number of decimals we specify. So I want to round this value here. Let's run the file, and it's rounded it by 3.82. So the one here, it's rounded up to 2. And the reason for that is because I've got 3 over here, so it's rounded across 3 digits, 1, 2, 3. But if we actually take this out, let's run the file again. And this time it's rounded 3 to 4, maybe because 0.8 is closer to 4. So let's change this to 4, and it should round down to 3 now. So let's run the file again, and now we can see it's rounded down to 3. Actually, let's try 3.49. That should round it down. If we try 3.5, I think it should round it up. which it does. So the optional parameter is quite good. So we can do 5 instead. So this time it should round to the 5th digit. 1, 2, 3, 4, 5. So this one, 8, it should round up because the next value is 6. So let's have a go. 3.57687. So 6, it's rounded up to 7. Next we have the sum function. The sum function is the sum of all items added in an iterable. So objects like lists, tuples, sets, dictionaries, strings, all of these are called iterables. Let's take a look at an example and let's look at a tuple in particular. So let's create a tuple. So here is my tuple on the first line and we've got 195 inside my tuple. The next line we create a variable called my_sum, which equals our function, which is sum. And then inside our function, we're passing my_tuple within the function, which is the line above. And then we are printing my_sum to the console. So let's run the file. And we can see it's added these together. So it's given us 15 because 1 plus 9 plus 5 equals 15. Let's add 10 in there, which should now equal 25, and run the file again and it equals 25. So we can continue with this and it will keep adding them together. And this is why it's the sum of all items added in an iterable.
Welcome back to another video. In this video we'll be having a look at the Python math module. So what is the Python math module? The math module provides a range of mathematical functions and constants, and the math module can help with performing complex calculations, numeric analysis and mathematical operations. So we will be having a look at how to use the math module in PyCharm shortly, but before we start using the math module we need to import the module, so we do that with the import math command. And there's many use cases for using the math module, but I've got some examples, which is data analysis, graphics and game development, financial and economic models, and scientific and engineering calculations. So the math module is a module consisting of multiple methods, and we will have a look at a couple of example methods used with the math module. So let's jump into PyCharm and have a live look at using the math module.
Python has a math module which will give us more math methods, and the command to do this is import math. To import the module, and we type this all in lowercase. And now if we type math dot, we can see all the functions or the methods inside here. There's quite a lot of them. We've actually just used one of them, which is the power of, down here somewhere, and there's some new ones in particular with 3.11.3, which is the version I'm running. So using the dot operator, we can see all of the methods the math module comes with, and we can see the power of is right at the top of the screen. Double click and then 3 space 3, 3 to the power of 3, and then we could run the file and it would give us the result. If we had printed it to the console, so let's of course print it, and I forgot the parentheses, so let's put the parentheses in and then run it again, and we get 27 because 3 times 3 times 3 equals 27. Let's try another one. Math dot, let's go for a common one, which is floor or seal. So if we specify a floating point in here, 2.5, and run the file, of course let's remove the first line and print to the console and put it in parentheses. Let's run the file and we get 3, so it's rounded it up. If we specify 4, still get 3, 1, still get 3, it's rounding it up. But if we use floor instead, now it's rounding it down to 2. Let's go with 7. So floor rounds a number down to the nearest integer, and seal rounds the number up to the nearest integer. But of course there are many other math methods as we've seen here, and you can have a look at the official documentation to understand the purpose of each method and what they are used for. So that's a basic overview of the math module.
In this video we will have a look at Python file handling, where we have various operations we can perform on files. Python file handling is about handling of Python files, and this could be reading a file, writing a file, deleting a file, amongst other file handling operations. So here we see open, create, read, write, rename, append and delete files. File handling tasks can be undertaken using different platforms, so Windows, Linux and Mac operating systems. And here is the OS module directory I've taken a screenshot of. So we would typically import the OS module, which is the operating system module. So it works with the operating system dependent functionality, and you may recognize a lot of these commands. For example, in blue, I've highlighted some of the Linux-like commands. For example, chdir, which changes the path of the current working directory, chmod, which changes the file permissions. We've got kill for killing processes, rmdir for removing a directory, mkdir for making a directory, and so on. And I'm going to be working with the Windows operating system. And we will take a look at the ones in yellow, and the open function is a key function in particular because Python uses the open function to work with files such as opening, reading and editing these files. And then there is path, which allows you to verify if a path exists to a file or a folder, and rename, which will rename a file or a folder. And we will have a look at each of these in PyCharm shortly. So here we are. The path variable implements operations on path names and the syntax is os.path. And then there's rename, which renames a file or a directory, and the syntax is os.rename. And then you would use the source and destination files, or if it's a folder, a directory, you would use source underscore dir underscore fd and dst underscore dir underscore fd. So you would need a source and a destination, and the original file or folder, and what you are changing it to, the destination. Now with handling files, the open function is one of the most commonly used functions, and it allows you to read, write and append files. The syntax for the open function is open, open and closed parentheses, and inside here there are two parameters, file name and mode. File name, of course, is the file name itself. You can either put in the file name if the file is in your project working directory in PyCharm, or you would put in the full path name with the file name. So where it sits in the operating system, and there's quite a few different options for the mode. We will have a look at this shortly. Actually, I have an example here. So open and then my file, which is the file name. So the example, open myfile.txt, and then the mode in this case is R. R is for read only, but actually this is the default anyway, so I don't need to specify R, but I have done here. And then these are the options. So to open a file, we can use the built-in open function, and the following modes are supported. So R opens a file for reading purposes, and this is the default, and will produce an error if the file does not exist. And then there is W. With W, it opens a file for write operations. However, when you update the file, data will be overridden to the existing file. So it will overwrite the data. And if the file does not exist, it will create a new file. Then there is A, which allows you to append a file. This is similar to the write operation, but the difference is it will not override any existing data. It will add data to the existing data. And X, this is purely just to create a file, and it will return an error if the file already exists. And optionally, we can specify if the file should be handled in text or binary mode. So text mode is a T, but this is the default, and just like the R for reading a file, it does not need to be explicitly specified because it's the default anyway. And then there is B for binary mode. So these are the core concepts of file handling in Python. In the next set of videos, we will have a look at live demos on handling these files, doing file operations in Python.
Now I'm on my Windows desktop and I have a file called my_file and I have a folder called my_folder. So we will have a look at how to access these using PyCharm. So I've got PyCharm open over here, and we can check if a file or a directory exists using the path module. The first thing we will do is print. So the Python OS module lets us work with files and directories, and it's a way of using operating system dependent functionality. So it's something we should know about and of course import into our file. So the first thing we will do is have a look at the operating system directory to see what's inside it. And the way you do that is print open and close parentheses dir and open and close parentheses again OS. OS is for operating system. Let's run the file. And this happens when we have not imported the OS module. So let's import the OS on the first line and run the file again. So we can see everything on this line as part of the OS module. So we can see name, package, spec, exists to verify if something exists. We can see chdir, chmod, the Linux-like commands, mkdir, name, open. So open and path we will be using shortly. Remove, rename, replace, remove dir. So all these are operating system dependent commands. Right at the end, so we will be using that one as well. And it's good to be familiar with what's inside here. Now the path to my file needs a double backslash rather than a single backslash, and this is because backslash is a special character in Python. The backslash is used to specify escape sequences like \n for new line and \t for tab, or \r for carriage return, and so on. So if you need to specify a path, by the way, you need to specify a path if your file or folder is not in your project, in your working directory. So when specifying a path, you would either use the double backslash instead of one to avoid syntax errors, or you could use a forward slash as well. They would both do the same thing. So the Python OS module lets us work with files and directories, and it's a way of using operating system dependent functionality. So to start off with, let's remove this one and let's specify the path. So the path equals, and let me paste this in. So we have the double backslash instead of the single backslash, or we could do it like this as well. Now if we type os.path.exists, and actually if we go back to path dot, and we can see all the functions and variables inside here. So we're using the top one, .exists. And then let's specify path. So we're passing path, which is path here. Let's hash one of these. So we're using this one with the forward slash, and then it's colon, enter, and let's print the path exists. And if it doesn't, let's do an else statement. The path does not exist. So let's run this and we can see the path exists. And we can try it out with the other variation over here. So if we unhash this, let's hash this one. So now we're using the double backslash. And if we run the file, we can see the path exists. And we know the path exists because it's on the desktop over here. Now going back to PyCharm, we can also confirm if it's an actual file. So if, and for this we use os.path, and then we have exists, the one that we just used. Instead we are looking for is file. So is file is the third one over here. We also have is dir as well. We'll have a look at this next. Is file, and then we want to pass in our path again, our path over here, and we can print this is a file, and if it's not a file we can do an else, print this is not a file. So let's run it again. So the path exists and this is a file. Now for argument's sake, now let's change the path. Let's change it to my files 2. Let's see what happens. So let's run the file again, and we can see now it says the path does not exist and this is not a file. And we can do the same thing for a directory as well, a folder. So let's do my underscore folder. Same thing again, but I'm going to do folder instead. Of course it's not a .txt. Let's remove the extension and let's hash the path one out. So we'll use my underscore folder, this one, and let's create a new if else statement. So if os.path dot, and this time we'll use the is directory, and let's pass in my underscore folder, and let's print this is a folder, and if it's not a folder, let's print this is not a folder. Let's run the file. So it's got an error because these ones are referring to path. So what we can do instead is we can change this to path instead, just to make it easier, and change this to path as well. So we can see the result of these as well at the same time as see the result for the is directory. Let's run the file. So we can see it shows the path exists because my folder is on the desktop. If we have a look here, it's this one here, my underscore folder. So that's fine. And then this is not a file, that's correct. It's a directory, it's not a file. And this is a folder, which is correct as well. Maybe if I hash this one, let's unhash the very top one. Let's see what results we get. And this time we get the path exists, and this is a file, and this is not a folder. So that's how we verify the paths of files and directories, and to confirm whether they are files or folders. So now let's have a look in PyCharm how we rename a file.
Now if the file was in my project folder, we wouldn't need to specify the full file path like we have done over here. So this is the project folder, Python project, and the file is not in here, it's on my desktop as we can see over here, my underscore file. So we need to specify the full path as we have done over here. So the first two things we have done is import the operating system module, which has all of the operating system dependent functions like path, open, write, rename and so on. And then we have specified the path. Now to rename a file, we're going to rename my underscore file. Actually, we don't need this. Let's hash this out. So to rename a file, it's os.rename. And then in the arguments, we can see we can specify a source file and a destination file, or a source file folder and a destination file folder. So this command will do files or folders. And what we can do is copy this path and rename it. So the source is this path and the destination will be the destination path, but we will rename it to my underscore file underscore 2. And let's run the file. So it shows the process has finished. And the way to confirm this is to have a look at my desktop to see if it's renamed. And we can see here it's been renamed. Also, if I have a look inside it, I just want to confirm it's still got my content. So it's not removed any of my content as well. And we can do this for my underscore folder as well, I guess. So we can do folder here and folder underscore 2 over here. Let's run the file. I've accidentally put a double F in there, but that's fine. It will hopefully prove the point. So my underscore folder has been renamed. Now back on PyCharm, we'll have a look at how to open a file, and we can use the built-in open function. And this function has two parameters, so we can pass in two arguments, and one is the file name we want to open and the other is the mode. So we already have the import OS to import the function, the open function, which is part of the OS module. And we have the path to my file, but actually it's called my underscore file underscore 2 now because we changed it in the previous video. As we can see over here, my underscore file underscore 2 and my underscore folder as well. Let me just remove the double F. But it's called my underscore folder underscore 2 as well. So if we type my underscore file underscore 2 equals, and we can see the parameters in the open function. So there's more than file and mode as well. There's buffering, encoding and errors. But we are just going to focus on these two, which are the most common two. And now if we copy the path from here and we pass that in, and then it's a comma and then the mode. So let's stick with R for read only. And I'm missing the apostrophes here. So I need apostrophes around the file name. Next, we will print the content of the file, and we can do this using a for loop. So before we print it, we will have a look at the content of the my underscore file underscore 2. So the content is hello, this is my file, have an amazing day, 1, 2, 3. Let's go back to PyCharm and run the file. So we can see the content, hello, this is my file, have an amazing day, 1, 2, 3. However, with Python, as usual, there are more than one way of doing things with Python. So this is using the for loop, but we don't have to do it using the for loop. There's a more simplistic way. Instead, we can do print and pass in my underscore file underscore 2, and it's the dot read method here. So we can see the options in here. So we want to select the dot read method, double click that, and let's run the file again. So we can see, hello, this is my file, have an amazing day, 1, 2, 3. We can also do print my underscore file underscore 2 and use the read line method or read lines. Let's stick to read line, and if we run the file, so this will read one line, hello, this is my file. If we specify 1 inside here, let's run it again, it will only print out the first character, H. Let's specify 10 in here, run it again, so it prints out 10 characters. Let's copy and paste this command and see what that does, and let's run the file. So it prints out the first line and the second line. And of course, we can use a for loop as well to loop through the lines. And that's it for this part. That's how you open and read the contents of a file. Next, we will have a look at how to write to a file. To write to a file, to start from the beginning, we first import the OS module to be able to use operating system dependent functions. And in particular, for this one, the open method.
So we will be using the open method and passing in the path name to the file, and we will open it up in write mode, which is the W character. So the read mode is the R character and the write mode is the W character, and for append is A. So just to note, the write mode overwrites anything within the file, where the append mode adds the content to the end of the file. Now looking at the file, we can see the path, it's on the desktop. We can have a look, and the name is my_file_2.txt. So if we minimize PyCharm, we can see it here. So my_file_2, and the content within it is hello, this is my file, have an amazing day 1 2 3. Now if we go back to PyCharm, and to overwrite the content of the file, we use my_file dot and the write method. So we see the write method over here, and within here we can write something. The content has changed, test 1 2 3. And it's always good practice to close the file as well. And for this we use the close method. And let's open up the file again in read only mode. Change the W to an R. And to read the file we will use the read method. And finally again we will close the file. So here we are opening up the file, the path of the file, and in write mode, and then we are changing the content of the file, and then we are closing it, and then we are opening it up again in read only mode and reading the file. So we should see the process has completed for writing to the file, and then we will check the file, and we will also print the new content to the console by reading the file again. So let's run the file, and we can see the content has changed, test 1 2 3. And let's have a look at the file itself. Let's cross this off and double click the file again, and we can see the content has changed, test 1 2 3. Or another way to write content to the file is to write the text as part of a variable and add the variable in instead. So if we remove all of this, let's create a new variable called my_text, and the content will be hello, this is my file, \n for new line. So we're using some escape characters here. It's an amazing day, \t for tab, 1 2 3 4 5 \r for carriage return. And let's finish it off with 6 7 8 9. And let's use the write method again, but this time we will pass in the variable my_text. And let's open up the file again in read only mode. So change the W to an R, and let's print my_file.read. So we can print the content to the screen. Let's run the file, and we can see hello, this is my file, it's an amazing day 1 2 3 4 5 6 7 8 9. And we can confirm this by actually having a look at the file itself. So let's cross it off and open it up again, and we can see the content inside here has changed as well. We can also use another method, it's called the write line method, and the write line method can write a sequence of strings to the file from an iterable, such as a list or a tuple. So if we cross all this off again, and rather than me typing it all out, let me copy and paste a list and a tuple. So I've got a list called my_text_2 equals, and then this is my list. So list, another test, \n for new line, 1 2 3 \n for new line, 4 \n. And then I've got the tuple as well, which is pretty much the same content, but the tuple is stored under my variable name my_text_3. Now we can use the write line method, so it's my_file dot, and we can see in here the write lines method. And let's pass in one of my variable names. So let's go with my_text_3. So we will see the content has changed to this content here. And let's run the file. I've made a mistake, that should be in the parenthesis. And let's run the file again. And the process has finished. We could print the output to the console, but to save a few more seconds, let's check the file itself. So if I double click the file, we can see here the content has changed, tuple, another test, 1 2 3 4. Let's do the same for the list as well. So if we change this to my_text_2, so we are passing in my list instead this time, and we will see the keyword list. Let's run the file. The process has finished, and if we double click the file, we see list. So up until now, as we've noticed with the write mode, it overwrites the content of the file. What if we did not want to overwrite the content of the file? We just wanted to add to the file. So this is where we use A, the pen mode. So the current content is this content over here. Let's append the file this time. Let's change the W to an A, and I will remove these, and let's paste in some content. So my underscore text equals hello, this is my file, \n for new line, it's an amazing day, /t for tab, 12345 /r for carriage return 6789, and then we are using the write method and passing in my underscore text. But as it's now append mode, my string will be added to the end of the content. So actually, just to complete this, let's also open up the file again and let's read the content of the file. So let's run the file. So I've made a mistake there. I've got my underscore file in this path. It should be my underscore file underscore 2. So now we can see the content has been added to the end of the file. Let's have a look at the file itself. And then if we double click the file, we can see, hello, this is my file. It's an amazing day, 12345 6789. And in fact, we see it 2 times because I ran it twice. So if we go back to PyCharm, the first time I ran it is when I had a mistake in this code. When I was pointing it to my underscore file, we still ran the code to write to the file, and then we ran it again. And that's the end of this video. That's how you write to the file, but the problem with writing to the file is you overwrite the content. So we also have the append option, which adds to the end of the file. Next, let's have a look at how we close a file. So I have a file open, my underscore file underscore 2. We have opened the file here, open a file, my underscore file underscore 2 equals open, and then we open the file in read-only mode. And then we printed the content of the first 2 lines of the file using the my underscore file underscore 2 read line methods. And what we can do is if we print my underscore file underscore 2 dot, and we can see the options inside here, and one of them is closed. So if we double click closed, this will check if our file is open or closed, and it will give us a Boolean result back of true or false. So if we run the file, we can see at the bottom here it says false because the file is open. By the way, there's another way of opening files which closes them for you, so we don't have to close them, and we will have a look at that shortly as well, and that's with the with statement. But in this situation, we need to close the file. So after we have completed the reading and writing files in Python, it needs to be closed using the closed function. And files do need to be closed after we have read them or we have wrote to them, because this will free up system resources the file was using, and it will ensure data has been written to the file. Otherwise, in some situations, changes may not show up on the file until you have closed the file. So the way we do that is use the close function. So if we run myfile2.close, and let's print the Boolean result again to confirm it's closed. So the first time it should say it's false, but the second time it should say it's true. So now we have false because we hadn't closed it, but then we ran the file.close, and when we printed it, now we can see it's true. So the file has been closed. And that's it for this video. That's how you close a file. Next is a quick one. We will have a look at how to create a new file. So at the minute we've got file equals open, and then we've got the file name, and then R for read file. If we change this to X, X is to create a new file. However, if we try to create a file that is already present, my underscore file underscore 2. If we have a look at the desktop, we can see my underscore file underscore 2. Now, if we run the file, we can see we receive an error, file exists error. So best practice, you should always handle these errors using error handling. So it will throw up an error if the file already exists. So let's change the file to my underscore file underscore 3 and run the file again. And this time it says process finished. So let's have a look at the desktop, and we can see over here, we see my underscore file underscore 3 has been created. And that's how we create a new file. Now we will have a look at how to open files using the with statement. So there is a with statement, which is a statement which is good practice to use when working with files. So it's used in exception handling to make code cleaner and easier to read. Also, when you open a file, you don't need to close the file. It will do that for you. And because they are properly closed down, it frees up resources. It also ensures the changes are written properly back to the file. So now if we use the with statement with the open function, open parenthesis, and specify my file path, and then we need to specify the keyword as file colon, and then on the next line we print file.read. If we have a look at our desktop, if we have a look at the file, we can see the content within our file. So now if we run the file, we get the contents back. So this is best practice to use the with statement.
So with the open statement, if we have noticed, we have not closed the file. We don't have to, because using the with statement ensures the open file is automatically closed after the flow of execution of the block of code. So when we open a file and execute our block of code, the with statement closes the file for us. So it's good practice, and because they are properly closed down, it frees up resources. We can also use the write option with the with statement as well. If we change this to file.write, it would be whatever it's called over here as file. So if I call it my underscore file, I guess I'd call it my underscore file over here. And then if we remove this dot, and we can see the write option in here. And then in here we can specify our content as we have done previously using the write option, or we pass it as a variable. The content has changed. That should do it. Let's run the file. And as we can see, it's unsupported, not writable, because we have not specified our mode. I did not specify one, and if you do not specify one, by default it opens it up in the read mode. So let's specify the mode. And the mode will be a W for writing to the file. Let's run the file. One more thing I missed the comma, and let's run the file again. So this time the process has finished. Let's check the file, and let's open up the file again. And now we can see the content has changed. In this video, we'll have a look at how to handle errors in Python, in particular with file handling. So I've done a separate video on error handling, and we are just having a recap in this video, because when dealing with files, it's easy to bump into errors. So we need to have a look at how we deal with them. So the first thing we've done is imported the OS. So we have OS dependent functions like the open function. And then we are opening up my file myfile_2.txt in read-only mode. Next, we are printing the output of my file to the console, and then we are closing the file. So it's a very simple piece of code, opening up and reading a file. Now, if we run the file, I see the content has changed. If we have a look at the desktop, we can see the file here, the content has changed. Now, if I introduce something else that does not exist, let's go with my file 2222. Now, if we run the file, we receive an error, file not found error. And this is bad because the program stops working. It stops there, it halts. It doesn't run anymore. So if we introduce error handling techniques on how to handle this error, the program continues to run. And this is something we want to do as much as possible with potential errors. So we will introduce some error handling. And the first thing we will do is type try. So try this line of code. And if it fails because it's bumped into file not found error because the file does not exist, print the file does not exist. Otherwise, if there are no errors, let's use the else statement to carry on and read the file. Let's tab these across. So what this is saying is try and open my file in read-only mode over here. But if the file is not found error is detected, print the file does not exist. And if no error is found, go ahead and read the file. Or should I say print the file to the console. Now if we run the file, we get the file does not exist, because this file does not exist on the desktop. Let's go back to the original file to make sure it still runs, and the original file still runs, which we can see here. By the way, I've done a dedicated error handling video, so you may want to watch that one, but that's how you handle errors when working with files.
Welcome back to another video. In this video, we'll take a look at error handling in Python. Being human, we are going to produce errors in our code. So we need to deal with errors in our program. A prime example is when there is a user input error. The user specifies the wrong type of value, and the program was not designed or written for the value the user has specified. So how do we overcome this in Python? What can we do to handle errors? In Python, there are two main kinds of errors, and these are called syntax errors and exceptions. Syntax errors, also known as parsing errors, where you have not followed the syntax and written something syntactically incorrect. For example, 10 equals x, which is not allowed in Python because you cannot declare a variable starting with a numeric value. And then there are exceptions, where errors are detected during execution are called exceptions. And these are nothing to do with the syntax, but more so the program was not able to deal with something. For example, imagine you're pointing x to the console, but that variable x has not even been defined. This would produce one of many possible exceptions, in this case a name error, or let's say you are concatenating a string to an integer, so you would get a type error for this because you cannot concatenate a string to an integer. And Python has many built-in exceptions to handle many types of errors. So we can see some of the common ones. For example, assertion error is raised when an assert statement fails. Arithmetic errors. This is a base class for numeric calculation errors, and then there's specific ones in relation to arithmetic errors. For example, zero division error when you are dividing by zero, if you are trying to divide by zero. Overflow error, which is an arithmetic overflow. And the third one is floating point calculation error. File not found error. This is raised when an operation attempts to open a file that does not exist. And this is a subclass of the OS error exception. Import error. Import error raised when an import statement fails. So when you are importing something. Type error raised when an operation is applied to an object of an inappropriate type. And right at the bottom we have value error. And this is raised when a function receives an argument of the correct type but an inappropriate value. In fact, let's move away from PowerPoint and take a quick look at a couple of these errors.
So here we are going to produce a zero division error. Let's divide 10 by 0. And then if we run the file, we can see it's produced a zero division error. And the reason for it is division by 0. Or we can do print x, which is not even defined. So if we run the file again, we would get a name error. Name x is not defined.
So now that we have had a look at a couple of these errors, if you have noticed, the program stops when it produces an error. We need to deal with the exceptions or the program would crash and it would not be able to continue with the rest of the program. So with Python, it has built-in functionality to deal with these errors, and there are some keywords or some statements that help with handling these errors, and the first one is try. This is where we try to run the code, and this is where we check for errors. It contains the code that might raise an exception. The next one is except. Except is if we do run into an error, then we run the block of code associated with except. So except is there to handle particular exceptions. So with the first two, we try, and if that fails, except if we get any errors, then we run the block of code associated with except. Next is else, and else will run the block of code associated with else if there were no errors. So try has to be successful for else to execute, and else contains the code to be executed if the try block does not raise an exception. And then there is finally. Finally always runs. It runs regardless of what happens to the code, and this is really there to clean up your code, so to close any files and so on. So to summarize, we check for errors with the try statement. If we get an error, we run the block of code under the except statement. If it never raised an exception, in other words, try was successful, then we run the block of code associated with else. And finally, we always run the block of code associated with finally. I'm going to give you 3 examples of using the exceptions and using the try and except keywords. And then we will have a look in PyCharm on how we would use all 4 of these with our code. So here I have 3 examples. The first one is a generic exception to catch all types of errors. It's a base class for all built-in exceptions. So although in this example, Python raises a value error because the int function is attempting to convert its argument into an integer, but as ABC is a string containing non-numeric characters, so it cannot be converted into an integer, this produces a value error. So using a generic exception, this will catch all types of errors. And for the generic error, it will print caught a generic exception occurred. The second one in blue is an index error. I use to catch any indexes that are out of range. So as we can see, we tried to print 5 to the console, but the elements in my list are these 3, 1, 2, 3, 0, 1, 2. So the indices are 0, 1 and 2, where 5 does not exist. So this time we are specifying the type of exception, which is the index error. So this raises an index error. And with the index error, it will print error list index out of range. And the last one is a permission error because the user did not have the right permissions to open a file in this path using the right operation. So with this error occurring, this will print error permission denied. So these are some very basic examples of using the try and except keywords. let's have a look in PyCharm how we will build these two as well as the other two, else and finally, so try, except, else and finally, around our code.
In PyCharm, let's keep it simple and let's do something like, let's request a person's age and specify the int function for integer to convert the user's output to an integer, because it's a string by default, but we want to convert it to an integer. So we want to know the age. We're going to ask the user, what is your age? And we are going to pass this off using the int function. So let's run the file. What is your age? If I specify 20, it prints the age out to the console, as we have specified this in the second line here. But if I run the file again and I type the word 20, we receive an exception, and this time it's called a value error. Invalid literal for int with base 10 20. It's basically saying it's not an integer or it cannot convert it to an integer. Python is not happy that we passed the word 20 to the int function. It was expecting a numeric value, or it can only do this with a numeric value. So we need some way of handling the errors, and this is where we can use the keywords we just had a look at in PowerPoint. So we would start off by using the try keyword. It's almost like saying try to do something. And then there is the except keyword. So try this, except if something is not working correctly, let's do something different instead. So we will try to convert the user input to an integer by specifying try at the top of our code or above our first line of code. And we need to indent the code below it, as these two lines now belong to the try keyword statement, as these are what the code is trying to do. So the block of code indented below try will be associated to the try keyword. And then we add our except keyword at the bottom and write our code of what will happen if the user does not type an integer and instead the program sees a value error or any other type of error. You can put other exceptions in here as well. And for this we can print something to the user, and this needs to be indented as well, as this block of code belongs to the except clause. So it follows the same syntax as conditional statements. You have to indent the code. So let's print try, pass what is your age to the input function and print age to the console. Except value error, so in this specific exception we are looking for a value error, but we can look for a name error and other types of errors if we wanted to. We just specify more exceptions below this exception, and let's print please type an integer. So if the user types a word like 20 or hello, the except value error will catch the value error or the exception, and it will print please type an integer. Notice we're using a value error, so the program is being designed to catch a value error, but there are many other errors it can catch, and we can create many of these except statements to catch other types of errors, or even a catch all to catch all errors. But a catch all error is not specific enough, so it's difficult to understand what went wrong. So usually it's best practice we try and be specific with the type of errors we catch. Now if we run the code, we specify 20, that's fine, we get the response of 20. If we run the code again, we specify anything else like 20, the word 20, or even hello. Now this time it's caught the exception, the value error. So it's printing out please specify an integer. However, there's also another thing as best practice, and we should try to run the fewest lines of code as possible. Especially if it was a complicated and longer program, we should change the 2 lines of code underneath try to 1 and keep it as minimal as possible. Instead, what we can do is move line 3, printing age to the console, away from the block of code under try and move it to the bottom and without indentation to say we run this print function regardless. However, by moving the print function, although we have improved the block of code under try, we have introduced a new issue, because if we now run the code, it works fine if we produce an integer like 20, but if we type a word of 20, we receive a name error. Name age is not defined, and this is because age has not been defined. We tried to pass a string to the integer function or a word to the integer function that cannot be converted to an integer, so it never defined it. We got an error instead. and then we are telling it to print age, but we don't have the age as it could not convert it. And if you notice, the print function is not indented, so regardless of what happens above, whether the try is successful or not, it will attempt to print it to the console, even if there has been no successful conversion. And to resolve this issue, this is where the keyword or statement else comes into play. So the else clause is used. Else is a familiar keyword in conditional statements, which is used as a catch-all, and we can also use it here. So what the else is saying is, if nothing goes wrong, do the following. Or in other words, if the try is successful and it gathers user input and can convert it to an integer in our case, only then carry out the block of code under else, which will be to print it to the console in our case. Let's put the else in, and as usual, indent the block of code underneath it, which is one line in this case. It's just the print statement. So now what the code is saying is try retrieve user input and convert it to an integer, except if something goes wrong and there's an exception of value error, then print please type an integer. Else if nothing goes wrong, print age to the console. So it only does the else if the try is successful, otherwise it will execute the except keyword and block of code as part of it. Let's run the file. And if we specify 20 as numeric values, it runs fine as usual. So this was successful, so it bypasses the except block of code and it executes the block of code as part of the else keyword. But if we specify a string of 20 with characters, words, no numeric values this time, Python executes the except keyword and its block of code, and we see please type an integer. But as we can also see, it exits out of here, so it does not actually allow the user to specify an integer. We'd have to run it again. So what we can do instead, we can throw all of our code into a loop, into a while loop specifically, so it lets the user try and try again until it successfully converts it to an integer. And for that we will type while true with a colon at the top and indent the rest of the code. And this time, as part of the else clause and printing the age to the console, we need to break out of the loop if it's been successful, as otherwise the loop would run forever. And then we print age on a new line once we are out of the loop. At this point, however, we would have successfully converted the user input to an integer, hence why it broke out of the loop. So it makes sense to print regardless of the code above it. So we're going to print age to the console once the code above breaks out of the loop. Now if we run the file again, let's run it with the numeric value of 20, and it prints fine again as usual. Let's run the file again. Let's type in something else like ABC123, and before I hit enter, just to go over what's going on again, this time we start off by being inside the while loop, then the try part of the code was successful, so it skips the except value error here, and we end up breaking out of the loop, and then it continues to go down the lines of code. So the next one down is it happens to print out the age to the console, so it prints the age. So that's what's just happened when we printed 20 as a numeric value. Let's print out ABC123, specify an integer. What is your age? So we can see this time round we are in the while loop. It's not broken out because it's not received a successful integer value. It's not been successful passing it back to the int function. So it's false. While true, and then it goes through this and breaks out the loop, but this time it's not been successful, so it's asking again, what is your age? So if we type something else, hello, again, what is your age? It's not going to break out the loop. Let's type 20, and you see the point, it's not going to break out of the loop. So the only way we can break out of the loop is if we type a numeric value, which can be converted to an integer. So let's type 20, and it's broken out of the loop first, where we've got the break, and then printed 20 to the console, which we have over here. So we are using the value error, but there are also many other error types, as we can see on the screen here. So I've got this from the Python documentation, and you can create more exceptions here. So we could have copied this pasted it again below and changed this to a name error, for example, and then customized what we wanted to print to the console if we caught a name error, and so on. So you can specify as many exception errors here as you would require, depending on what you have in your code and what type of exceptions you want to catch. And then we have one more clause, which is the finally clause, and this clause runs regardless. So no matter what happens with your code, this clause will run. So it would even run if you hit an error, or if your code runs perfectly fine, this will run regardless either way. And it's typically used to place your cleanup code here. So for example, when you work with advanced Python programs, such as when you want to close handles to any open files, so you want to close down files so they are not being locked by an operating system, for example, or you have variables and objects, and when you need to release handles to those objects. So any of that cleanup code will go under the finally clause. However, in this demo, we don't have any handles open or any files open. So we would specify the finally clause at the bottom. And what goes under here is your code cleanup stuff. And that's it for this video. That's an overview of how to handle errors and exceptions in Python.
Welcome back to another video, and this video is on classes. Classes are fundamental to object-oriented programming languages, including Python. Classes promote the reuse of code, so not having to repeatedly create the same code, and they provide a clear structure for your program. Classes are also very easy to build upon when needed, so it's very easy to build upon the class and add more methods when you need more functionality. An object is an instance of a class, and object-oriented programming helps with the idea of abstracting real-world objects and how we would represent them in code. For example, a real-world object could be a car, a house, a laptop, an apple, a bank account, absolutely anything, and bringing that idea and representing it as an object into the world of programming. And classes provide the blueprint on how to create these objects. So like a blueprint, a class describes how you create an object. However, the class is not an object itself. It's just a blueprint on how to create an object. For example, imagine a blueprint on how to create cars, and you use it to create these cars, and you create instances of these cars with the blueprint. So more than one car. And these cars, of course, do not have to be the same. That's the whole point of instances. So the general construction is the same. They are cars, but certain things are different. It could be the make and model, or it could be features, could be the engine size, the fuel it takes, etc. But they were all built using the same design pattern given by the class, the blueprint. These classes are actually a custom data type, so you are creating a custom data type or a template for creating objects. Although we have the built-in data types such as numbers, strings, lists, tuples, dictionaries, you may need custom types as well when working with complex ideas to model things in the real world. And working with classes is a very deep topic of its own. You can create very complex objects. So we have seen the different data types assigned to variables. When we create variables, for example, integer values that work with whole numbers and strings that are referred to as text values. And this has an impact on how the rest of the program works, because you're able to do mathematical operations on integer values, for example. For example, 2 plus 3 will give you 5. However, if the value 2 and 3 are interpreted by Python as string data types, Python will concatenate them together. So 2 plus 3 will give you 23. And with classes, you're able to create your own custom data types. And the whole point of classes and what makes classes different from functions is that you can create instances of these classes. For example, lots of different types of cars that are represented by unique objects. So in the slide I have here 2 unique objects, car1 and car2. We'll be creating these very shortly. And these 2 objects are created using the blueprints or the construction of the class, which we have defined over here. So a class is made up of attributes and methods. The attribute, or you can see this as the state of the class, is defined using variables, and its actions or behaviors, or what the class does, is defined using methods. So the class is made up using attributes and methods. Attributes is the state of the class, and the methods is what the class does. And we can see the class cars. Here is the attributes. So this is the variables, the state of the class.
We can see make, model, fuel type, gearbox, colour and mileage. And then at the bottom we can see 2 car objects created. So these are the instances created using the blueprint or the construction of the class. So these 2 objects, car1 and car2, although they are different, one's an Audi A4, the other one's a BMW 4 Series, they are both unique, but they have been created using the blueprints of the class. And then we have one single method defined here. Of course, you can create as many as you like, and we will create another one in Python as well. By the way, this code will make a lot more sense once we have created it in Python, which we will do next. So we are in PyCharm and you define a class with the keyword class, and then we specify the name of the class. We will call it cars, followed by open and close parentheses, and then followed by a colon. And a colon, of course, just like functions, indicates the start of a block of code. So when I press enter, so here the cursor needs to be indented, and here is where we define our code for the class. By the way, for variables and functions, we always use lowercase letters and underscores to separate each word. But for classes, we use uppercase and uppercase for the first letter of each word. We don't use underscores. It's just the convention and the way it has been for classes. Now, before we start to build our code, let's say we wanted a placeholder for the class cars in our code. So we had no code to define here and it's empty. Other than creating the class itself with the class cars, if we run the file, we receive an error because it's expecting a block of code. So to get around this error, Python lets you use the keyword pass. And this is like the temporary placeholder when you are yet to create your block of code. So now if we run the file, we don't receive any errors. So your code can continue without any issues and you have that placeholder there for you to create your class as well. But we are going to create some code. So let's define our function. And the way we do that is with the define keyword, def. And next we will use the init method, which is the initialize method. So that is a double underscore init followed by another double underscore. And we can see PyCharm has found it. So if we double click it, PyCharm has completed the rest of it. So you need to open and close parentheses, and inside the parentheses we specify our parameters, and every function inside a class needs the self keyword as a parameter within the parentheses. The self parameter must always be the first parameter of any class function, and you don't have to call it self. You can rename it if you wanted to, but it's called self and it's best practice to leave it as it is. And self is just a reference to the instance being created. It represents the object it is building. For example, the cars Audi and BMW. BMW is a different instance of the car class than the Audi is, which Python knows about because of the self parameter. And the initialize method here. This method is to assign values to object properties in order to create the object in the way we want to create it. And this method is called upon every time a new instance is created. So it's needed. It's like a constructor. A constructor, by the way, is a special type of function called to create an object. And this is a method that initializes a newly created object. Otherwise, we would have to create the objects manually. So just see it as it's needed to create new objects. Now we will create our instance variables, also known as the attributes. These variables are called attributes or instance variables, and each of the objects usually has their own unique values assigned to them. So there is something else as well, it's called class variables, which we'll have a look at shortly. But these down here are called instance variables or attributes. And we need to create the variable starting with the keyword self again, so it knows about the object it is referring to or building. And as part of the parameters, including self, which is the very first one, we need to specify the rest of the parameters. So in our case, because we are creating cars, we will have make, model, fuel type, gearbox, color, and mileage. Now, if we press enter, next we will create our attributes. And I've missed the parameter color, so I'll add that in there as well. So we can see our attributes are matching our parameter arguments in here. So we've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And this all proceeds with the keyword of self before it. So it knows about the object it is referring to or building. So our cars will consist of unique values for the make, model, fuel type, gearbox, color, and mileage. And this will form our instances for a particular car represented by the instance object. By the way, this is not code that is running. Just like a function, this is code that we define. This is the blueprint which we will create our instances from. So next what we will do is create two instances. The first one will be car1, and we can see it's called Audi A4. It's diesel, automatic, it's grey in colour, and its mileage, it's done 20,000 miles. And the next instance we will paste in is car2. And we can see how these are created. So this is a variable name, car_2. So the variable will equal cars, the name of the class, as it matches the name here, class cars, followed by open and close parentheses. And then we specify our actual arguments. And these have to match the amount of times we have parameters for. And we do not need to specify the self keyword here. So it's just the arguments for all the parameters excluding self. So make, model, fuel type, gearbox, color, mileage. That's 1, 2, 3, 4, 5, 6. And we need 6 arguments. So 1, 2, 3, 4, 5, 6. And it's always good to make sure the file runs without error. So let's run the file. So far so good. There's nothing to output, but there's no errors.
Actually, we do have something to print. Let's print both cars to the screen, just to verify they are both unique object instances, and we can see both have unique locations in memory assigned to them.
So next, let's print something. So let's create a method to print the make of the car and the mileage it has done. So we can see we are calling our method miles. We are again using the self keyword inside the parenthesis, followed by a colon, which indicates the start of a block of code. And our block of code is to print this self.make. So we can see we are using our attribute make from over here, has done self.mileage. And we can see we are using the mileage attribute we've created down here. And what do we do to make use of our function? Well, first let's use car2, car_2. And here's a key bit. So if I use the dot notation here, we can see the methods or the functions we can use. Now if we have a look, we've got mileage, make, gearbox, model, color, and fuel type is down here as well. And if you can see, we do not have miles. We should have miles, and that's because I can see from here our indentation is a little bit off. So we just need to bring that back and this print statement back as well. And now let's have a look again, dot notation here. And now we can see the method for miles. So let's double click miles and run the file. And we can see it says this BMW has done 40,000 miles. We can also create something called class variables and give them a default value. So this is known as a variable of the class that is shared by all instances. And it's declared inside the class, but outside of where we declare our instance variables. So it sits in between. So let's say, for example, all our cars will have satellite navigation, regardless of the car. So this is like a default value that would be the same for all our instances. So anything shared, we create over here. So this is known as a variable of the class that is shared by all instances. And as we can see, it's declared inside the class, but outside of where we declare our instance variables. So where we declare these are our instance variables, which are usually unique depending on our values down here. But this class variable is shared by all our instance objects. The reason I have created this is in case we want to override it. So we can do that. For example, let's say car1 has two features. It has a sat nav and it has a sunroof as well. So down here we can do car_1 dot feature. Let's add heated seats in there as well. So it has 3 extra features, does this car. Now just to confirm that has worked, what we do is print and inside parentheses car_1 dot feature, and let's run the file. Now we can see car1 has specified sat nav, sunroof and heated seat. And to make sure this is only applicable to car1, because if we look, we specified car1 here, car_1 dot feature. Let's print car2 and run the file again. So there we go, car2 only has the satellite navigation. So that's a quick overview of class variables versus instance variables. By the way, we can also use formatted strings and format things out better. So the spec of this car is, and we can specify all our arguments. And then if we run the file, we can see that here, the spec of this car is, and then the details of the car. And of course, car1 has all the extra features, sat nav, sunroof and heated seats. Now let's build on this class one more time and add another method.
let's say we wanted to have some method to increase the mileage every time the miles increase. In fact, let's create a new instance for this, car3, and add the miles as a number rather than a string without the quotes. So we can do some real mathematical operations on numbers, not strings, unlike car1 and car2. So let's paste car3 here. And we can see car3 has 50,000 miles. And it's without the quotes, so Python has interpreted this as an integer value and not a string like the other two. Now let's create a method which will add 2,000 miles onto the current mileage. We'll paste that below the first method and fix the indentation. So this one is called increase underscore miles. Again, we have the self keyword in there, followed by a colon. And now what we are saying is self.mileage, which is here as an attribute. We will add 2,000 miles. Or we could have done times 2 or times 3 to double or treble the mileage, etc. But in our example, we just want to add 2,000 miles to the current mileage. And if you watched my function video on the return statement, it needs to return the result of the function. So we need to specify self.mileage here. Otherwise it will not print anything. And now what we can do is print. So this will be for car3. And if we hit the dot notation, we can see our options. And we see the new method of increase underscore miles. So let's double click that one. And now we can run the file. We should see 52,000 miles. And that's it for this video. That's a high level overview of classes. So just to recap, we give the class a name and then we can specify our class variables. We create the main blueprint for the main body of the class down here and our parameters inside here. Not to forget the self keyword is the first keyword inside the parameters and it represents the object it is building. And of course the special dunder method, which is initialize with the double underscore before and after. And this initialize function is called upon every time a new instance is created. It is also known as a constructor, which is a special type of function called to create objects. And then further down below we can create our own methods. So I've got two very simple methods here. And down here is our instance objects. So we have created 3 instances of 3 cars. In this video we will have a look at inheritance. We have already looked at classes and we created a class called cars. And then we created 2 instances of these classes. So we created 2 car object instances. And for this video we will have a look at class inheritance. Now let's say a company sells all cars with automatic gearboxes only and all of them have a spare tyre. So every single car this company sells has an automatic gearbox and a spare tyre. So rather than defining this on every single class we create, instead we can inherit those properties from a base class. So we have them defined in the parent, or it's even called a base class over here called all cars. And we could have anything in this class that every single car in the company will inherit. Then we can create other class definitions and we make the other classes a child class, or also known as a subclass of the base or parent class. And this company might want to break its cars down into the type of cars it sells. So estate, family car, saloon, etc. are shown in the middle boxes. And because all of the estate or family cars have 3 rows of seats and an extended boot, and the saloon cars have 2 rows of seats and a standard sized boot, we can define these attributes by themselves as well. And then we can create child classes of these classes, so we do not have to recreate these attributes as well. Now we have a third layer of classes, and these will be the child classes of the type of car classes. The middle ones, estate and saloon, and in here will be the details of each particular car, such as the make, model, fuel type, mileage, etc. And the class will inherit the properties of the parent classes, estate and saloon, and all cars. So we have just one child class in our example, and it can inherit from one or more parent class. So we can inherit from the estate class or the saloon class, for example. But since it's a car that can be of any type of car, it makes sense to inherit from all types of cars. So we may as well inherit from estate and saloon. By the way, this is also known as multiple class inheritance, by inheriting from one or more parent classes. So the child class can inherit from one or more parent classes. So we do this so we do not have to recreate code.
We don't have to recreate the automatic gearbox and the spare tyre, or even the extended boot and the 3 rows of seats for the estate car. We don't have to recreate them in different classes. We could just utilise the code that's already been created in the parent classes instead. And if anything changes in the parent classes, we just have to change them there, and the child classes will inherit whatever changes have been made in the parent classes. So let's have a look at this and how it all works in PyCharm. So for the purpose of the hands-on demo, let's create a 2-layer hierarchy. Let's create a child class and a parent class. Let's ignore the type of cars in the middle, the estate and the saloon. So let's create the very top box, all cars, with a spare tyre and an automatic gearbox. And then let's create the very bottom box, which will be a child class of all cars, and the bottom box will be called car.
We are now in PyCharm, and let's create the class all cars to represent all of the cars that we sell at the company. Now let's create the blueprint for our class and create the attributes. However, let's only specify the attributes that will be the same for all of the cars, as we have seen on the PowerPoint. So let's say every single car we sell will be automatic and will come with a spare tyre. So we can include this in the base class that will be inherited by all child classes. Now we will create a child class called car. This will be the blueprint to create each individual car. Now in our child class, which we will call car, we will pass the parent class all cars in the parenthesis. So we now have included a reference to the base class, or sometimes called parent class. And over here after self, we will specify the parameters of our attributes. So now the class car inherits all of the attributes of all cars, and it will also inherit the methods. We'll create some methods shortly of all cars as well. So anything in all cars, attributes and methods, will be inherited by the child class car. And in our car class, we will have the attributes, make, model, fuel type, colour and mileage. Now let's create 2 object instances, and these will be 2 cars. One will be an Audi and the other one will be a BMW. So car_1 and car_2 will represent the details or the specification of 2 cars.
Next, let's create a print statement using a formatted string to print the specification for car_1.
And every time we hit the dot notation, we can see the attributes or the functions inside here. Make, model, mileage, gearbox, colour. But if we notice, these are belonging to the car class, these 3 here. And the gearbox, all cars, belongs to the all cars class, as well as the spare tyre, all cars. And then we've got fuel type as well. That is part of the car class.
Now let's finish off the rest of the print statement and then we can run the file.
So the instance car_1 belongs to the car class, we can see here, and all of the attributes we have specified here, make, model, fuel type, colour and mileage, are all parts of the car class. We can see them here. Make, model, fuel type, colour and mileage. Now if we have missed the self keyword in here, now if we run the file, we can print our car and the attributes for car_1 and the print statement here. And we get the specification of this car is Audi A4 diesel grey 20,000 miles or 20,000. However, since we have a reference to the parent class, all cars, we're able to print the attributes for our gearbox and spare tyre as well. So we can use the inheritance feature here. So let's include these 2 attributes in our print statement at the very end. And now if we run the file again, we can see at the very end spare tyre included and automatic for the gearbox. So we can see we are able to print these by referencing the parent class, and this means we do not need to keep on repeatedly creating the code for those 2 parameters or those 2 arguments, since they are going to be the same for all cars. We just reference them in the base class and then use them when we need to. And this also works for methods as well. We can inherit methods. So let's add 2 methods to the base class. Let's make them as simple as possible. The first one will print the current miles the car's done. We will call the method miles and print this to the screen. Then reference the make attribute, this make of the car's done, and refer to the mileage attribute and then miles. So we are creating these methods as part of the all car class, the base class. Now let's print the statement by calling it car_1.miles. So down here we want to print car_1.miles, and let's run the file. So we can see this Audi has done 20,000 miles. The Audi belongs to the car class, but it's referencing the method that belongs to the all cars class.
So it's inheriting methods as well. We could make this a little bit more prettier. Let's run the file again. And that looks better. So this already has done 20,000 miles. If we create another one, let's add another method to add 2,000 miles to car2. Let's call it increase underscore miles, and it will be self.mileage plus equals 2,000. And we will use the return statement to return the value. So it's return space self.mileage. And to print the output, we'll use the print statement. Now we can see this method here belongs to the all cars class, but we will be using it with car underscore 2 here, which belongs to the car class. So let's, down here, it will be print parentheses car underscore 2 dot increase underscore miles, and let's run the file. So it's complaining it cannot concatenate strings with integer values. So let's change the mileage to be an integer value down here. Let's take the commas out and let's run the file again. And now we can see it's added 2,000 to 40,000 and it's come back with 42,000. So although we are playing with object instances car underscore 2, which is within the car class, we are using the method within the all cars class. And this might not be an ideal example to use to increase the mileage. A better example may have been to increase the cost instead. Let's say due to inflation all of the cars were increased by 5%. So that would have been a better example. But the whole point of this is you can inherit methods. We can also override a method by creating it again in the child class. So in our example, let's say we wanted to change the mileage to 5,000 miles instead of 2,000. Now when we run the file, it should print 45,000 miles and not 42,000 miles. So let's try that. And what we would do for this is let's copy the method to start with and paste it in again in the child class car, and let's change the value to 5,000 instead. Now if we run the file again, we've already got the print statement here for car underscore 2 dot increase underscore miles, and we can see it's printed out 45,000 instead of 42,000, so it's overridden the method. So you can do that for specific things as well. And again, maybe a better example of this would have been cost here as well. So let's say the parent class, we were increasing the price by £2,000 on all cars, but we wanted to override this for a specific car to £5,000, or 2% and 5%. Now there's another useful feature you could use if you wanted to see more information about the class. So what we would do here is if we run print and in parentheses type help, and then in parentheses again type the name of the class. For us it's car. And now if we run the file, we can see some information about the car class. If we scroll up, so from here it shows us the car class, and it shows us the method resolution order. So the order it takes, it starts off from a bottom top approach. So it looks at cars first, and then if it doesn't find anything, it looks at all cars, and then the built-in .object. And this is the order in which a programming language resolves a method or attribute, and is particularly important in Python as Python supports multiple inheritance. Object is the base for all classes that all classes inherit from it. Essentially, it has a lot of the default functions. And then we see the methods defined here as well. So you can see the methods it's picked up. It's picked up this method from all cars, increase underscore miles. Actually, it says it here, methods inherited from all cars, miles. So it might be useful if you wanted to troubleshoot further, or just wanted to have a look at some information about the class itself. And that's it for this video. That's a high level overview of class inheritance. So I've thrown this slide in after the video was done, just to explain multiple class inheritance. So if we have a quick look at this diagram, the child class called car at the bottom is inheriting from many parent classes in the middle, which are types of cars. And this is also known as multiple class inheritance. And this is achieved by putting all the names of the parent classes in the parentheses of the child class as shown in the bottom on the left hand side in red. So in black we see how to reference more than one parent class in your class, and then in red we define the class car, and then in parentheses we've got the parent class names convertible, estate, saloon and minivan. So now this class car is able to inherit from all of the above classes. Welcome back to another video. This video is on the super function. So the super keyword with the initialization method allows or provides access to attributes and methods present in the base or parent class when you are doing inheritance. So it's necessary for complex class hierarchies that use multiple class inheritance. Let's have a look at this in PyCharm. We are in PyCharm, and to begin with, let's create a class for all cars. We will now initialize the class. And because this class represents all cars, we will have things that all cars has. So all cars have a name of the make and the model, and whether the car has a spare tyre, and what the gearbox is, whether that's automatic or manual. So let's include these as the parameters and the attributes. Let's create the attribute self.make equals make and so on. So these are the attributes all cars will have. They will all have a name of the make and model, whether there is a spare tyre in the car, and what the gearbox is, whether it's automatic or manual. So these are all of the properties that every car has. So I'm including these attributes in the class all cars. Now let's create another class for the type of car, and the type of car will be a family car for this class. And as it's a family car, I want it to consist of the things a family car will most likely have. So let's just pretend this certain family car has the option to have a built-in child seat. It comes with many cup holders. It has additional features as well, such as a TV or the option to have a TV and other entertainment facilities. So now we have created the attributes of Family Car 2. So Family Car 2 will have a child seat, cup holders, and it will have some additional features as well. Family feature _1 and family feature _2. However, we still want to specify the make and model of the car and whether it has a spare tyre and if it's a manual or automatic gearbox. And these are the attributes of the all cars class, the one we just created above. And so if you've watched the previous video on class inheritance, and so as we have done in the previous video, rather than duplicating the same code as the class all car, we can reuse the code that's already been created in the all cars class by calling its initialization method. As that is best practice anyway, not having to duplicate code everywhere and reuse what's already there. But this time we will use something called the super function with the initialize method. So for a simple inheritance design, we can hard code the base class and use the name of the class all cars. And this will execute or run our all cars initialization method. However, when you have many more classes and multiple layers of inheritance, it's better to use something called the super function with the initialization method. The difference is, in the previous video, we hard-coded the parent class to call upon the initialization method, but in this video, we'll use the super function. So first, let's reference the parent class in the parentheses. And so now this class is a child class that will inherit the attributes and methods of the parent class. So next, let's copy the parameters from the parent class to the child class. So next we will call upon the super function and we will add the parent class parameters in the initialization method within the parentheses of the child class. So that's it, we have inherited these attributes. You can also inherit methods, by the way, if you watch my previous video on inheritance. That's got some good examples on there. So these are inherited now. So now what we will do is create an object instance called car _1, and it will be part of the family car class. So it will be part of this class here. So it's a Ford Cougar, spare tyre included, it's an automatic gearbox, premium child seat included, there's 4 cup holders, there's a TV and a coffee maker in this car. Now let's print all of this to the screen. And I'm using formatted strings to format the string a little bit better. To format the string itself, so one thing I've noticed, I've missed a Y, and let's carry on, and let's finish off the print statement. Now let's run the file to make sure it runs. Let me remove the I from specification and run it again. So the specification for this car is Ford Cougar, spare tyre included, automatic, premium child seat, 4 cup holders, TV and coffee maker. So what we see here is the attributes from the parent class, these ones here, which are covered make, model, spare tyre and gearbox. And then we have the attributes of the child class as well, the premium child seat, 4 cup holders, TV and coffee maker. So what the difference here is than the previous video, in the previous video the initialize method for the parent class was hard coded. The parent class was hard coded with all cars. So this is the parent class, and if we scroll down we have a child class here, class all cars, And then we are calling the initialization method within all cars, the parent class, so it's hard coded. Now the super function is based on what the class is inheriting from, so it's not hard coded. So it's calling the initialization method with the parameters based on the parent class, which is all cars. So now this is basically saying call the initialization method of the direct parent class. And because the family car is inheriting from all cars, it's going to call upon the all cars constructor function. So the super function is based on what the class is inheriting from, rather than it being hard coded. Now this means if we introduce new classes and inherit from another class instead, the super function will call upon the new class constructor automatically, as it's no longer hard coded, and this automatically maintains that hierarchy of inheritance inside of our code without having to manually change it. So super is the way to go rather than hard coding it, as because with a single inheritance it's not a big deal, it's easy and quick enough to change, but with many classes and multiple inheritance you would benefit from super for its dynamic nature.
Next we will take a look at polymorphism. Polymorphism means many forms, or something that can take many forms. For example, a person taking multiple forms by behaving differently in different environments, such as how you behave at work versus home. And in object-oriented programming, one of the common references is it usually refers to child classes that are inheriting code from a parent class or parent classes, are able to override those methods and attributes by giving them a different set of rules to follow than the parent classes themselves. So these methods and attributes in the parent class and the child class can have the same names but have different rules to follow. And inheritance with polymorphism helps minimize repetitive code, it organizes code better, and it makes it easier to debug code. Now, how polymorphism can be achieved? So let's take a look at the common types or examples of polymorphism and how they can be achieved. So the first way, and the most common way in particular, with class inheritance, this is used in class inheritance, is method overriding. I have showed this in a previous video, but basically we can override a method inherited by a child class from the parent class with a different set of rules. So this is method overriding. Now let's take a look at the method overriding code in PyCharm. Now in Python, when working with classes, we can override code that is in the parent class by recreating it again in the child class with a different set of parameters. Let's start off by overriding a simple variable. And the first thing we will do is create a class called car with a variable name equals BMW. Now I will create a child class called myCar and specify car as the parent class of this child class. And let's not create any code in this class for now. Now let's create an object instance called newCar, which will be associated with the child class myCar. Now let's print our object new_car and associate it to the parent class variable name of BMW. So new_car.name, and we should get the name back of BMW. Let's run the file. And it's thrown up an error because BMW needs some quotes around it. Let me put some quotes around BMW. And let's run the file again. So we see BMW. So this means our new_car object instance, which is associated with the child class myCar here, is inheriting from car because it's picked up the car name. New_car.name, and it outputs BMW. So it's picking up the variable name BMW from the parent class car. However, in the child class we can override this. So if we create a new variable name equals, let's call this one Audi, and run the file again. And now, although it's inheriting the name equals BMW, we have overridden it with the name equals Audi. So this is overriding the attribute or the variable. Let's do one specific to a method. Let's create a class called allCars, and I want to define a method to print this car has a spare tyre, as let's imagine all the cars our company sells come with a spare tyre. Let's call the method spare_tyre, and my print statement will say this car includes a spare tyre. Now let's create two classes, one class for Audi and another class for BMW, and let's make them both child classes of all cars. Next we will create an object called car_1, which will be created part of the child class Audi, and car_2 will be part of the child class BMW. Now if we print car_1.spareTyre, we see it picks up the method from the parent class allCars. Now if we copy the method and paste it in again as part of the child class Audi, and let's say although all cars come with a spare tyre, the vendor Audi is not offering
cars with a spare tyre. So we want to override the parent method with this method. So let's change it to print. This Audi does not include a spare tyre. Now if we run the file again, we can see the method in the child class has overridden the method in the parent class. And this is known as method override. So now we can see print, this Audi does not include a spare tyre. And just to make sure it does not impact the BMW, let's print car_2.spareTyre. And we can see it does not impact car_2, so it shows this car includes a spare tyre. So it shows it's still inheriting the method from all cars.
The next type of polymorphism is method overloading, and although the method overloading is supported in other programming languages like C++ and Java, it's not supported in Python. But just to cover it off and what it is, you can create the same method and it can exist multiple times in the same class. So you will see the same method name that will be present multiple times within a given class. And of course, different parameters will be used. However, with Python, no matter how many methods you create with the same name, it's always the last method that takes effect. So it's only the one method and it's the last method that will take effect. Now, with all that being said, there is an indirect way of using method overloading in Python to make some methods work, but I'm not going to cover it here. It's beyond the scope of this topic. But just so you know, there is an indirect way of making this work, and it basically sets default values to none and uses conditional statements to achieve method overloading in an indirect manner. And by the way, the differences between method overriding and method overloading is that overloading occurs within the same class, whilst overriding occurs in different classes. And the third way I'm going to cover off to achieve polymorphism is using operator overloading. So operators are able to behave differently according to the objects and the data types that are calling the operators. For example, operators behave differently if the data type was a string versus a numeric value. And Python translates the operator to which context it thinks you are using it in. So the meaning of the operator changes depending on how it's being used. So this is operator overloading. Let's take a look at some examples.
Here is a very simple example of polymorphism with using operators, and the first examples are generic to Python, not specific to classes, but after this I'll also cover operator overloading with classes. When using the operators with strings, they behave differently when using them with numeric values. For example, 2 plus 5 equals 7, but if 2 and 5 were strings, it would print 25. So with strings, it concatenates them together. Or how about 30 being the integer times the string 5? And if we run the file, then we get the number 5 printed 30 times. Or let's print 10 times Audi, and we get the string Audi being printed 10 times. So this is polymorphism with operators in general, context to Python. Let's have a look at operator overloading in context to classes and objects. Now with classes and objects, Python doesn't know how to add two objects together. So let's create a couple of classes. Let's create car_1 and then we will initialize it and give it a price variable. And let's create the variable, the attribute for price. Now let's create car_2 and we will do the same thing as car_1. Now let's create two objects, C1 and C2. C1 will belong to car_1 and C2 will belong to car_2. And we will fill out the arguments, so let's give each of these a price. Car C1 will be 5,000 and car C2 will be 4,000. Now let's imagine someone wanted to purchase both of these cars. How would we add the objects together? If we do print and then do C1 plus C2 and let's run the file. So we get an error, unsupported operand types for the plus operator, car_1 and car_2. And this is because Python does not know how to add two objects together. It does work, however, if we added the specific attributes like .price at the end of C1 and C2, but how do we get Python to work it out using only their object names? So now we get 9,000, but again, if we remove these, we want Python to work it out using only their object names. So let's remove these again. So currently the plus operator does not understand what these two objects are and how to add them together. And to understand how to do this, we have to understand what's going on behind the scenes. So we need to add some code to be able to let Python know how to add the two objects together. And let's start off by understanding the built-in magic or dunder methods in Python. So if we temporarily open up a new file file new, Python file, call it second file. Now when we do a equals 1 and b equals 1, and then we print a plus b, and then if we run the file, we get the result, we get 2. And this is because the plus operator in the back end of Python is actually using something called the magic method. It's a double underscore add, and then it's followed by another double underscore. These are special methods that start and end with a double underscore. And these methods are invoked internally from the class depending on the feature we want to use in Python. For example, the plus operator in this case, it invokes the method double underscore add double underscore. And built-in classes in Python define a number of magic methods, and we can see how many magic methods are inherited by a class using the dir function. For example, we can see all of the things defined in a float class by printing dir and float in parentheses. So if we run the file, we can see lots of dunder methods, and actually the second one we see is the add dunder method, and of course there's lots of these supported. And we can even do something like this to show the add method in action directly. If we do something like a equals 50, we can print. So we can do a and then the dunder method of add, and then in brackets 2. So this is saying a, which is 50, add 2. And then if we run the file, we see 52. So that's how the operators work. And this is not only for add, it can be for subtract or any of the other dunder methods. And there's many dunder methods. So if we do underscore underscore, we can see all of them over here. So there's lots of them, but they are also on the Python website. So I've got a screenshot of them. So going back to the PowerPoint slide, and we can see they are on python.org. But if you go to this page, data model, you can see lots of these dunder methods. On the bottom right, we can see x is less greater than y and what calls it. We can see x dot and then the dunder method. LE, which stands for less than or equal to, and then y, or x equals y, so that calls for x dot equals and then y. So you know which dunder methods to use and what they do. So this is again on the Python website, python.org, and the page in particular is called data model. So now that we have a bit of background information and we know the add method is used in the background, well, we need to overload this method. And we found out what overloading means. It means creating the same method again multiple times. So we have the built-in method, and in this case it's the addition method we want to overload. But of course you can do this for the other operators as well. So now if we go back to first PyFile, we can create a method underneath here to overload the plus operator. So let's define a new method. And we can see it has self and other inside here. So let's double click it. And just to make it clear, I like to specify other as other underscore object. So we define a new method with the double underscore add double underscore method, as this is the method we want to overload. And in here we get self and other, which will represent our two instances. So now what we need to do is we need to return self.price, and then it's plus other.price or other underscore object.price in our case, as we changed it. And by doing this, Python now knows when adding two objects, we would be adding their associated price variables. Because if we read it, it says self.price. So the first object instance .price, and then this is the second object instance .price. So if we now run the file, and we can see it's added them together. If we just scroll down a little bit so we can see the code as well as the output, we can see C1 plus C2, it doesn't have the variable price tagged at the end of each object, and it's still able to add both objects together. So we have now overloaded the operator with the functionality we need. And now there are two versions of it. The add dunder method that is built in, and the one that we just created to be able to add the prices of the two objects together. And this is known as operator overloading. By the way, we can also create methods for the other operators as well. Just do underscore underscore and we can see all of the dunder methods inside here. And that's it for this video. Thank you for watching. That's a high level overview of polymorphism in Python.
Welcome back to another video. In this video we'll have a look at Python encapsulation as part of object-oriented programming modules. Encapsulation in Python is one of the fundamental principles of object-oriented programming, and it's in particular important when you are sharing your code with other programmers, which is people who want to work on the same code. It refers to the concept of bundling the data, which is the attributes and the methods, which are the functions that operate on the data into a single unit known as a class. And encapsulation helps in hiding the internal details of an object and restricting direct access to some of its components. Another way of looking at it is encapsulation is wrapping up these attributes and methods together. Similar to a capsule you eat, like a medical capsule, it's all bundled or wrapped together. It's really about protecting the attributes, the variables and methods within a class, and you are able to restrict access to the variables and methods that form part of the class. So there are three naming conventions that are used, which are public, protected and private. However, in Python there are no actual keywords of public, protected and private, which there is in other programming languages like C++ and Java. So instead in Python we do this using something called access modifiers, and Python equivalent is the use or the absence of underscores. So using encapsulation and these access modifiers, we are basically restricting access to the class from outside of the class or the derived class. Public is the default and the methods and the variables are unrestricted and you are able to access them as you wish from anywhere within the program. Public does not use any underscore symbols before the attribute or the method, which means it's unrestricted. However, giving other coders the unrestricted ability to be able to access the class and modify things, they can, from a low risk perspective, do something that does not meet the requirements or the standard of the program, and from a high risk perspective, they can potentially break the program. So we need some way of giving coders controlled access. Then there is protected, and with protected, you can declare data members of a class to be classified as protected by adding a single underscore before them. However, with protected, it does not actually enforce anything. It's there to let people know that it's been classified as protected. So it's like a warning or a message to say the variable or method is protected, but it does not actually prevent access to the variable. And finally, there is private. The private access modifier is the most secure and enforces controlled access. Well, it does to the naked eye anyway. However, in reality, it's not that secure really. It basically performs a process called name mangling, in which it changes the name, so you can still access it if you was aware about the name change that happens internally on the back end. Anyway, we will have a look at this towards the end of the video. So with private, you can declare data members of a class, which are the variables and the functions to be classified as private by adding a double underscore before them. So in summary, with public, anyone can use that code within the class or outside of the class. Protected can be used within the class and within the child class as well when you're using class inheritance. But with private, nothing outside of the class can access the attributes and the methods, including no access from any child classes either, or derived classes. So to summarize, it's important to note that Python is a language that values simplicity and readability, and it follows the principles of we are all consenting adults here. So while you can use encapsulation to signify intent and provide some level of protection, Python does not strictly enforce access control like some other languages do. So developers are trusted to follow conventions and use encapsulation responsibly. And if we do use private, how do we then provide access? So with private mode, it stops you from accessing variables or methods from outside of the class or a child class. So how do we access private members? For this, we use something called getters and setters for when we want to access private data, the attributes and the methods. And getters and setters are basically methods or functions. You can call them functions. And with these methods, we can set conditions to make them more secure, which becomes more clear in the hands-on demo, which we'll be doing very shortly, after looking at the next part, which is the use case of why name mangling was introduced. So further looking into name mangling, Python name mangling is a mechanism that changes the way a class, attributes and methods are named to make them less likely to accidentally conflict with attributes from subclasses. So while many sources on the internet assert that name mangling is designed for establishing private attributes, actually its primary purpose is to mitigate name clashes in class inheritance rather than enforcing privacy. So name mangling proves especially valuable when safeguarding against accidental overrides of attributes or methods in subclasses. So the use of two leading underscores in attributes and methods can effectively prevent subclasses from unintentionally overriding them. So if you are creating a parent class, which will contain attributes or methods exclusively for the base class, then it's in this situation where you would consider employing double leading underscores in their names. And this means you're able to use the same names in child classes, and you will not accidentally override the variables or methods in the base class, as this mistake does commonly occur. Right, so enough of the PowerPoint slides, let's look at a demo of encapsulation. Now we are in PyCharm and we will create a class called car, and then we create a constructor and initialization method and pass make, model and price as the attributes as part of the class car. We then create a list of our attributes, self.make, self.model and self.price. And next we will create our object instance and pass in the values. Because it's a car, we will create an Audi A3 and it will cost £5,000. So we'll specify the int value of 5,000. And next let's print all of these and run the file. And it's not finding the attributes because I have not specified a capital C for car. Should be car with a capital C to match the class up here. So you should find the attributes now. So let's create some print statements for make, model and price, and let's run the file. And we can see it prints Audi A3 5000 to the console. And what else we can do is we can change the price. So even though we are outside of the class, we are able to change the price. So here is our class. It could even be in a different file. This is a very simple example. We may have thousands of files, and then we've got our object instance here. And because the class is public, there's no underscores before the attributes. Other people with access are able to make direct changes to the class. So let's run the file. And we can see that's changed to 6,000. So this is not a good thing. We need protection for our classes, especially when we are working on larger projects and other programmers need access to our classes. So we need a controlled fashion how other coders and programmers can access the classes without breaking anything, without damaging anything to our code, our classes. And this is where the getters and setters come into play. So using getters and setters is the most common way to give programmers access to classes in a controlled fashion, and we can set conditions for them as well so they don't break the code. So for example, at the minute we've changed the price to 6,000, but someone else could easily change 6,000 using characters and convert it to a string instead. So something like this. Now let's run the file again, and we can see it's changed to 6,000. And of course this is now a string, not an int value. So this could easily break the code. We may have been doing something with the price. We may have been adding a percentage cost to the price. We may have been increasing the value by 10%. So it's not going to be able to increase the value of 6,000 written in characters with 10%. It's going to break the code. So this is where getters and setters come into play. And let's have a look at that now. Now to protect these values, we can specify a double underscore before them. So let's do this just for the price attribute. Double underscore. So 2 underscores creates a private attribute, and this means the attribute are only available for the members of the class and nothing outside of the class can access them. And now if we run the file again, we receive an error because the attribute is now private. Car object has no attribute price. So how are we able to read these values or write to these values? And we do that by methods known as getters and setters. So to read a value, we would define a method as part of the class. And as we are still inside the class and we are creating this method as part of the class, it's able to get the value. So we will call this getter method get underscore price, and it will return self.double underscore price. So the getter function get underscore price will help us retrieve the price in an indirect fashion. But let's also create a method to set the price as well. So that's again df to define the method. Let's call it set underscore price. And we will also pass a value to set the price of the new value. And itself dot double underscore price equals value. So now we use these two methods, these two functions, the getter and the setter, to retrieve the price from the class or to set the price in the class. So now we have the print function to get the make and the model, and we will change this one to the function c1.get underscore price, double click the method, and it needs an extra parenthesis at the end. So let's run the file, and now we can see it still retrieves the price of 5,000, the one that we set over here. And if we try and set the price, c1.price equals, let's go with 6,000, and let's run the file. We can see it doesn't change the price, so it's still 5,000. Or we can change it back to the string value 6,000 and run the file again, and we can see it doesn't change the value. It's still 5,000. We have a look at our car C1 and then the dot operator. We can now see we don't have the price available to us. So we've got the make available to us, the model available to us. We've only got the methods available now. The getter and the setter get underscore price and set underscore price. So we cannot change it. There's no double underscore price or there's no dot price. So the way we change it is using the set underscore method. So let's click set underscore price and we can pass a value inside here. So let's go with 7,000 and let's run the file. And now we can see using the set method, it's changed the value to 7,000. Right, so now we have covered that. Here's the key bit on encapsulation. Now that we only have the setters and getters functions available to us to change and read from the class, well, what's the difference from accessing the class directly versus using these setters and getters methods? And this is because with these set and get methods, you can additionally have some validation code added to them. So it may be so you're not breaking the function with your code. So you can set certain conditions with the set method, for example, and this is the key concept of encapsulation. You set these setters and getters, and with these setters and getters, you control the access to the class itself. So let's have a look at an example of how we do this, and we use conditional statements. So let's set up a conditional statement on our set function. So set underscore price, and then we pass in a value as we have done here, 7,000. Let's specify a conditional statement and let's say if the value is greater than 1 million. So let's print. That seems rather costly. Has there been an accidental addition of extra zeros added to the price? And then maybe we can do another one as well. If the value is less greater than 1,000, let's print. Let's print that appears to be quite inexpensive. Check the price again. And then finally else, we set the value. So let's scroll down and let's change this. Let's add some additional zeros. I've got 1, 2, 3 in there, so let's add another 3 and let's run the file. I've made an error. Let's remove the equal operator. So it's if value is greater than 1 million and let's run the file again. Again, one more error. I've missed some indentation of the last statement, setting the value, and let's run the file again. So you can see our statement here. That seems rather costly. Has there been an accidental addition of extra added zeros to the price? Maybe I need to remove that. That reads better. That seems rather costly. Has there been an accidental addition of zeros to the price? Something like that. Now let's remove some zeros and try the less greater than 1,000 and run the file. And there we go. We get that appears to be quite inexpensive. Check the price again. So our conditional statement is so far working. If we add a 0, now it should hit the else statement and set the new value of 7,000. Let's go with 9,000. I think we used 7,000 before. Let's run the file and we can see it's changed it to 9,000. So you may now see the benefit of using setters and getters. It's indirect access to the class, so it protects the class. It adds an additional layer of security, and you can control how programmers interact with the attributes within the class itself. Whereas if the attributes were public, programmers have unconditional access to the class. And finally, there's a single underscore as well. Let's add the single underscore before the model attribute and run the file. So we need to add it into our print statement and let's run the file again. So we can see it runs. It's just a warning to say this is protected, but does not actually enforce anything, unlike the double underscore. So that's a high level overview of setters and getters, and you can see why they are beneficial. They give you that indirect access to the class, but it's very controlled. So you can set these conditions to say a programmer can access these values and they can change these values, but they have to meet a certain set of conditions. They cannot input something that will break the code, or they cannot input something that does not follow the standards that has been set for the class. And that's it. That's a high level overview of setters and getters. Now the one bit I forgot to show is the name mangling procedure that happens in the background. Now let's have a look at private mode in a bit more details, in particular with name mangling.
So we can see self.double_price is in private mode. And what we can do here is if we print directory for the instance of C1, so it's print dir, so it's print dir and then C1 in parentheses. Now if we run the file, now we see the directory for instance C1, which is this instance here. And the very first one we see is _char, which is the name of the class, followed by double_price. So our name is double_price, but it's prefixed _char, the name of the class, as part of the name mangling procedure. So we can see it's mangled the name with the prefix of an underscore followed by the class name. If we hover to the top here, we can see our class is called char. So it's prefixed it with the class name. And if I scroll to the very end, we can also see _model and the make attribute as well. And we can see our method setPrice as well as getPrice. So they're all at the end over here. But going back to this mangled name for the private attribute, what's to say we cannot use this name instead? So if we get the price for the mangled name, we can do that instead. So let's print, and it's C1 dot, and we can see the mangled name is hidden in here. So it's not visible in the options here, but of course we can type it in. So it's _char, __ or double_price. And that should do it. So if we run the file, we can see we get no errors and we do get the price back. So although we have set this variable to private, we are still able to access it using the mangled name. So therefore it's not very secure at all. And referring back to the PowerPoint slide, its real use case for using name mangling is to avoid name clashes with derived classes, so subclasses like child classes. So that's the real use case for name mangling. By the way, in this video we have mainly been looking at attributes and how to make them protected and private. But let's have a look at how we make a method private. So the way we do that, I've just copied a method, so I can just paste it in. So let's paste it in here, and the method is called public to private method, and then with it we print test public to private method. And how we make methods private, we just add a double underscore before them, the same as we do with attributes. So that's our private method. Now let's try calling it. So if we do C1 dot, and same as private attributes, we can see we do not see the methods, or should I say the private methods. We do see the set price and the get price. Those are the methods, the setters and the getters, but we do not see our new method, public to private method, and we do not see it with a double underscore or without a double underscore either. So you might guess what I'm going to do next. Let's try and access it with the name mangling procedure. Or maybe we should just run the file again to see if it's in the directory. So missing a bit at the end. Let's scroll back up and add the parentheses self keyword and double colon, and let's run the file again. And now we can see our mangled name of the public to private method, and we can see it's prefixed _char at the beginning of it. So this is the name mangling procedure. So if we copy this, and then if we print C1 dot and paste it in, of course I've got to put my parenthesis in there and at the end as well, and let's run the file. So I've done that slightly incorrect. We're already having a print statement in there. We just need to call it, call the method, and run the file again, and we can see it says test public to private method. So we could access it using its mangled name. And so now we have seen how to make attributes and methods private or protected, and how we can access them with setters and getters and enforce some conditions on them using conditional statements. And we've seen how we access attributes and methods using name mangling. And last but not least, let's not forget name mangling's main purpose was to avoid name clashes with subclasses. So if you've got the same names in parent classes and child classes, that's when you would use name mangling. That's its intent, why it's in Python 4. It's used to avoid name clashes. Thanks for watching Encapsulation in Python.
In this video, we will take a look at Lambda functions. Lambda functions are like regular functions, but they do not have a name, so we cannot call upon them like we can with a regular function. And for this reason, not having a name, they are also called anonymous functions. Lambda functions can take in as many arguments as required, but only have a single line expression, and it's assumed whatever it executes will get returned, which actually means we do not have to use the return keyword with our Lambda functions. And a Lambda function evaluates and returns only a single expression. So what's the use case for Lambda functions? Why do we need Lambda functions? The use case for Lambda functions is that a Lambda function can be passed into other functions. So a function can take in a Lambda function as an input or return a Lambda function as an output. Or you can even do both of them. Map and filter are two common examples, and they can be used in conjunction with an iterable. So we'll have a look at examples of these, but iterables, by the way, are strings, lists, dictionaries, tuples and so on. Basically a series of items and values. And you can use Lambda functions with other functions or for functions that you only need to run once in your program without the need for a full function definition. Or another example would be for creating an event handler for teak into widgets such as buttons, for example, when you are creating a graphical user interface. And this is the syntax for a Lambda function. So Lambda itself is a keyword, which is saying what follows it is an anonymous function. So Lambda, and then it's followed by arguments with a colon, and then the expression. And we can see the description of the syntax. So Lambda is a keyword for defining the function. Then the argument or the arguments is a placeholder for a variable or variables that will be used to hold the value you want to pass into the function expression. And a Lambda function can have multiple arguments depending on your requirements. And then anything following the colon will be the expression. And the expression is the code itself you want to execute in the Lambda function. So we can see the regular function on the left hand side, and it's specified and it starts with the def keyword followed by the function name. On the right hand side, although we have put it in my_elif, a variable, it doesn't have to go into a variable, it can be specified on its own. So Lambda, the arguments, colon, followed by the expression. And it doesn't have a name, so how do we call upon the function? So one example is to use it inside a variable like I've done here, my_elif, and then followed by the Lambda code. Then we can call upon the variable name. But this in fact is like a regular function then, because we've specified a variable name. A Lambda function doesn't usually have a name. So Lambda function in its own works in conjunction with other functions, which we will have a look at in PyCharm in the demo. Now looking at two functions in particular, which is the Python filter function and the map function, which are two functions built into Python. We can use both of these in conjunction with other functions, and in particular Lambda functions. So looking at the filter function, as the name of the function implies, the filter function does some filtering. It can filter through an iterable and is able to select or extract items using a given condition. And the syntax for a filter function is the word filter, and then in parentheses we pass in two parameters. So it can be a function, it can be a regular function or a Lambda function, and then followed by the iterable. The iterable can be a list, dictionary, tuple and so on. And then the other function is the map function, which executes a specific function on each item in an iterable, like a list, dictionary, tuple, etc. And this may actually sound like a for loop. So it behaves similar to a for loop, but without having to use a for loop, of course. So we will have a look at the map function as well. And the syntax is very similar to the filter function. So you use the name of the function, map, and then in parentheses you pass in two parameters. And that's a function, could be a regular function or a Lambda function, and then the iterable. So with all that being said, let's have a look at how Lambda functions work in PyCharm. So I've logged into PyCharm and we are going to have a look at Lambda functions. So how do we use a Lambda function? And one way we can do this is the way we create a variable. So we assign it a name. We can assign them to a variable, but then there's no point of using a Lambda function, because then we can use a regular function instead. But we can do it this way anyway. So for example, with a regular function, we can create some code, 2 times x, so 2 times whatever value we pass. So if we passed the value 5 in a regular function called my_function, and we returned the result, and if we run the file, we get the result, which is 10. Now using a Lambda function to write the exact same thing, we would do. So we would start off with the keyword Lambda,
followed by the input value. So lambda as the keyword, then x colon 2 times x. Now, because we have this lambda function that has no name, we cannot run it because it doesn't have a name. So how do we call it? So the one thing we can do is run it by giving it a variable. So my underscore elif for lambda function equals, and then the code, the expression. Then we can print it. So print my underscore elif. And now let's pass in the value of x, which will be 5. So because we've assigned it to this variable, we can run the variable. So let's run the file and we can see we get 10. So it's the same thing as the one above, but this time we've passed it into a variable and then we've passed in the value and then we get the same result. But typically you wouldn't pass it into a variable. Then it's like a regular function. We've given it a name. So we may as well use a regular function instead. So now we'll have a look at the typical use cases of lambda function, where they are actually used. And they're used in conjunction with other functions like the filter and map function. So let's have a look at the filter function first. And the filter function can filter through an iterable and is able to select or extract items using a given condition. So to start off with, let's create a list of numbers and assign it to a variable called my underscore list. I've just copied it from my notepad, so I'll paste it into PyCharm. Now let's extract all of the odd numbers from the list. And for this, we will create a lambda function. So this is my lambda function using the modulus operator that will extract all of the odd numbers. The modulus operator, also known as the remainder operator, works on integer values and expressions and figures out the remainder when the first operand is divided by the second operand. So this is the lambda function. Now let's specify it as part of the filter function. So we can put this into parentheses and then specify our filter function, so filter. And if we remember, there's two parameters, so we are passing two things inside here. One is the lambda function, or it can even be a regular function, followed by the iterable. In our case, it's my underscore list. And then we will assign this to a variable called odd underscore numbers. And now we can print this to the console. So let's do print. And then we would say my odd numbers are, and to pass in the list keyword followed by our variable odd underscore numbers. So let's run the file. I have made a mistake because my underscore list is in small and it's got a capital over here. So let's change that and run the file again. And odd numbers is not matching odd number, so we've missed the S. Let's run the file again. And this time it runs. So my odd numbers are 1, 3, 5, 7 and 9. So this is my lambda expression to filter out odd numbers. And then I've used it as part of the filter function, and the filter function takes in two parameters. And then we have assigned all of this to a variable called odd underscore numbers. And then we have printed this to the screen. We could have easily done this for even numbers as well. We could do this now by removing the exclamation mark, so not equals to, and using the double equal sign, so the equal operator, and then run the file again. This time it would filter the even numbers. So of course that should say even numbers are, and then we can see it's filtered out the even numbers, 2, 4, 6, 8, 10. Let's change it back to odd numbers since the description is for odd numbers. My odd numbers are. Let's have a look at the map function now. So we can now see the use case of lambda functions and how they work to complement another function to do something. So the map function executes a specific function on each item in an iterable, similar to a for loop. So I'm going to create a really simple map function which would multiply my values within my tuple. So I've copied a tuple, let's paste it in. So I've got these values here, and then let's create my lambda function. So this is my lambda function, it's saying x multiply x. So whatever the value x is, it will multiply it by itself. So now the lambda function will be part of the map function. So it's map, and then in parentheses we have the lambda function, and then we would specify the iterable. So it's my underscore tuple that we would be running the lambda function on. Close the parentheses. Now let's assign the map function, which has the lambda function passed inside it and my underscore tuple, and we will assign this to a variable called multiple underscore values. And last but not least, let's print it to the console. So we pass in the list and then our actual variable multiply underscore values. So what this should give us is each value should be multiplied by itself.
So 1 times 1, 10 times 10, 5 times 5, 20 times 20, and 4 times 4. So let's run the file. And we can see the results here. So 1 times 1 is 1, 10 times 10 is 100, 5 times 5 is 25, 20 times 20 is 400, and 4 times 4 is 16. Or since my tuple is a tuple, we could change this to a tuple. Let's run the file again. It gives us a tuple instead. So that's a high level overview of Lambda functions. So we can use Lambda functions with other functions, as we have just seen, with the map and the filter functions, and we can use them in other situations as well. In this video, we will take a look at list comprehension, which is basically looking at a shorter way of creating lists using less syntax. List comprehension is typically written as a single line of code, and it's usually easier to read as well. So you are creating lists with less syntax and they are easier to read and therefore easier to understand as well. And a common example of when using list comprehension is when you want to create a new list by applying an expression to each element in an existing iterable, such as a list, tuple, or a string, or by iterating over a range. So in a nutshell, list comprehension, it's basically code that allows you to create a new list from an existing list using less code. Usually you would use a for loop, but using list comprehension, you can do everything you do with a for loop using one line of code. And Lambda expressions used with certain functions, such as map, filter, and sort, can mimic list comprehension. And although I've done a dedicated video on Lambda expressions, we will have a look at examples of these, as well as examples of list comprehension, after we have had a look at the syntax. So this is the syntax for a list comprehension. So we've got my underscore list equals, and then the expression for item in an iterable. And the next one is expression for item in iterable if it meets a certain condition. And we will have a look at both of these in PyCharm next. But just to finish off, and last but not least, I've got some sample code. So we've got a for loop and it creates a new list called my underscore list, and then it appends some characters called characters in my list, and it adds these to our new list called my underscore list. So this is my for loop and we can see it's been created using 3 to 4 lines. But if we do this using list comprehension, we can see a couple of lines of code. So the main line is the main line of code, and then we are printing it. So my underscore list equals, and then we've got the expression, and then we can see it creates my new list. For my new list, so that's the for loop part, include characters in my list. So we'll run these 2 lines of code inside PyCharm. And at the bottom, we can see the syntax description. So the expression, so this is the operation or value that will run on all the items within the iterable. Then we've got the item, which is the variable representing each element or item in the iterable. And then we've got the iterable, and this is the sequence to iterate over. For example, a list, string, or a tuple. And the last one is a condition. So a condition is optional and filters the elements, or the items you can call them, elements or items, to be included in the new list. So a filter helps decide whether or not an element or an item should be added to the new list. I've logged into PyCharm and we will have a look at list comprehension. So a lot of the times we use for loops to perform various tasks with our lists. And I have copied a list, my underscore list, with some numbers and characters inside it. So I'll paste these in. Next, we want to append some characters to the list. So we create a for loop, which is typically how we would do it, using a for loop, and append each character in my list. And finally, we will print it to the console. So we have created a for loop to iterate over my list and append the characters to my new list. So I have a list over here called my underscore list, and then we have created a for loop for my app underscore list, include these characters, so characters in my list. So it will iterate using my for loop to include these characters, and then on the second line we can see my underscore list, which is my underscore list over here, append my app, which stands for appending, my appending list. So to my list over here, it will append my appending list, which in effect are these characters. And then we print my list to the console. So if I run the file, we can see, so 1, 2, 3, these are the new, that's the existing list over here. And then it's appended these characters. So these characters are all new items, elements in my list. Or we could have had a new list. So actually, originally, it was an empty list. That's why I called it create a list. And then it will add these characters in my list to my list.
So if we run the file again, we can see characters in my list. Now although it works, it took us 3 to 4 lines to do all of that, as we had to create a new list over here, my underscore list equals, and the symbols to create a new list. And then we created a for loop to iterate over each of these characters in my list. So although it's called characters in my list, we had to iterate over each of the characters, char, etc. And then the action, and then what we are going to do with the for loop. So here, my underscore list dot append, so we are appending the characters to my list. And finally, we printed my list. Now, using list comprehension, using the syntax, let me grab the syntax. So I have copied the syntax and I'll paste it in. So the syntax is list and then its expression for item in iterable if condition. And let's create all of this we created with a for loop using list comprehension. So now what we can see is one line of code. So if I scroll all the way to the top, and then we can see we create my new list and then my for loop and then what we do with our for loop. So that's 3 lines of code. So all of this we have replaced with one line of code here. My underscore list equals my underscore new underscore list, and then our for loop for my new list include these characters in my list. So this line of code replaces these 3 lines of code over here. Now if we run the file, we can see we get the same result using the for loop as with list comprehension. We can also create a nested list comprehension, which is effectively a list comprehension within another list comprehension. So what we will do here is we will create my nested list. So I've created a new list called my underscore nested list, and then my expression 0 to 5, and then the for loop. And so it will iterate over 0 to 5, and it will include, so 0 to 5 means our range of 6 numbers, 0, 1, 2, 3, 4, 5, and we will create 3 of these list comprehensions within our list comprehension, and then we will print my underscore list. So if we run the file, we can see it's printed 3 lists of 0 to 5 within each list. So it's printed our 3 nested lists. Now the way we would do the same list using a for loop is, so this is the way we do it using a for loop. So here we create our new my nested list. This is to create an empty list, and then for our for loop for the 3 nested lists include range of 3. So there is 3 of them. And then my nested list, which is my nested list over here, the one that we have just created. Append the 3 nested lists. So append this 3 times as the range is 3. And then for the range of numbers 0 to 5 in range of 6, which is 0 to 5, do the following below. So the following below is my nested list, in square brackets, the 3 nested lists, dot append 0 to 5. So it appends the range of numbers 0 to 5 within the 3 lists. And let's run the file since I've got print my nested lists. So we can see it's done the same thing using the for loop, printed my 3 nested lists. Now let's take a look at a list comprehension using the if condition. And I'm just going to copy and paste all my code in here in one lump sum. So I've pasted my code in. We've got a list my underscore numbers underscore list, and we've got a list from 1 to 10, and then we've got create a new list containing numbers 5 or more. So it creates a new list called 5 or more, which equals n for n, include my underscore numbers underscore list, but only if this condition here is met. So the if condition is if n is greater than or equal to 5. So this is saying only print anything greater than or equal to 5. So we should get 5, 6, 7, 8, 9, 10 back. And then it's printing my new list to the console, 5 or more. Let's run the file. We can see here 5, 6, 7, 8, 9, 10. Also, Lambda functions with certain functions can mimic list comprehension. So first, to point out the difference, so list comprehension is primarily used for creating a new list by applying an expression to each item in an iterable, and optionally filtering the items based on the condition, as we have just seen. Where Lambda functions are used to create short one-line functions in situations such as for passing as arguments to other functions like the map, filter or sorted functions. So let's look at another example of comparing list comprehension to Lambda functions. So here on line 40 I've got my underscore list, range 1 to 5, line 41. So I've called it my underscore 1 to 5 underscore list. And I've got my values 1, 2, 3, 4, 5, and then print my 1 to 5
list to the screen. Now if we print it, we can see right at the bottom it's printed 1 to 5 to the screen. Now here's my list using list comprehension. So on line 45 we can see my underscore list underscore comprehension. So using list comprehension, what we are going to do is multiply each value by itself. So we can see it does x times x. X is multiplied by itself. 4x, so it iterates through the loop, including my 1 to 5 list. So that's my 1 to 5 list over here. So it's going to iterate through 1, 2, 3, 4 and 5. And then it's going to print it to the screen. So if we run the file, we can see 1, 4, 9, 16 and 25. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. Now, having a look at how we do this using a Lambda function, let me copy and paste the code in on line number 48. And here is my Lambda function used in conjunction with the map function. I've done a separate video on the map function, and that's in my Lambda function video. But basically the map function executes a specific function on each item in an iterable, like a list, dictionary, tuple and so on. So it's similar to how a for loop works. So my underscore lambda underscore list equals the keyword list, and then we use the map function. Inside the map function we pass two parameters, so our arguments, and these are, and this one lambda, which is x colon and then x times x. And then we are running this expression over the items in my list, which is my 1 to 5 list. So it's the same thing really, x times x, we can see it over here, x times x. So the value of x will multiply by itself, which is 1 multiplied by 1, 2 multiplied by 2, and so on. So if we run the file, so before we run the file, we can see 1, 4, 9, 16 and 25. This was produced by the list comprehension over here. If we run it again, we can see it's being produced twice now. So once by list comprehension and the next one by a lambda function. Just to give you another example, here's another lambda function on line 53 used with the filter function. So we can see the filter function here. So the filter function filters out items based on a given condition. And this one uses a lambda function to output even numbers from my list. So my list is my list over here. So if we run the file, we can see even numbers 2, 4, 6, 8 and 10. I've covered this off in more depth in the lambda function video, by the way. And then the other example, using the filter function to filter out 5 or less items. I think I've covered this one a little bit further up here, but that might have been a list comprehension. So we're using a lambda function here. And if we run the file, we see 1, 2, 3, 4, 5. So it's ignored 6 to 10 because of the code here. So it's going to print out anything where x is less than or equal to 5 within my list. And that's it for this video. That's a high level overview of list comprehension. We've seen list comprehension, how it saves us a little bit more code in comparison to for loops. And then we've seen nested list comprehension, how we can nest lists within a list. And then we ran some code of list comprehension and how it compares to lambda functions.
In this video, we will have a look at a method which is part of the function tools, which is called the reduce function. Now, the reduce function is able to reduce elements or items or values, you can call them elements, items or values, within an iterable, such as a list, tuple, dictionary, to a single cumulative value. And the way it works, it performs a process starting on the left of the iterable. So let's say the iterable is a list, it will start on the left of the list on the first two elements or items. And it does its process, whatever the process is. In this case, it's adding them together, and it repeats the same process until there is only one value left or item left. And then the result is returned and printed to the console. And here is the syntax. So the syntax is reduce, open and close parenthesis, and then we can pass 3 arguments inside it. The first 2 are required, which is the function, the process we are going to perform, and then the iterable we are going to perform the function on. So the iterable we are referring to, and the third is optional. And this is called initial, or it can be called the initializer. And the initializer is placed before the items of the iterable in the calculation and serves as a default value when the iterable is empty. And as we can see in the example, as the reduce method is part of the function tools module, I have to import it in. So we've got import func tools. So we have imported the function tool module, or we could have just imported the reduce method from function tools. That will work as well. And then next we have my underscore list, and it equals lots of characters. So characters in my list. And we can see each character is its own element or item in the iterable, and we can see this by the apostrophe used at the beginning and end of the character. So each character has an apostrophe at the beginning and then at the end, and then a comma, and then it's the next character, and so on. So this is its own element or item. Now we have got the main line of code, and we're storing it inside a variable called my underscore single underscore item. And then this equals functools dot the reduce method. And inside the reduce method, I've got two arguments. So we've got a lambda function. So function, what we do, a process. And in this function, we've got two values, a and b, and we are adding a and b together. And then we are doing this on an iterable, which is called my underscore list, which is the list above. And finally, we are printing the result to the screen, my underscore single underscore item, and we can see the output. So the output is characters in my string, and this is a single value. So we have reduced it to a single value. So let's have a look at how this works in PyCharm. Now, to give an example, I did a separate video. This was part of list comprehension, where I added some characters to a list using a for loop. So I did a for loop. Let's paste the for loop inside here. So I have a list called my underscore list, and I've got some elements inside here. We can see 1, 2, 3, and then these are the new. And then I've got my for loop. So for my appending list, include, and then it's include these characters in my list. And what we are going to do with these characters is part of the next line. So my underscore list, which is my underscore list here, we are going to use the dot append method to append my underscore app underscore list, which is this one here. So we are appending these characters in my list to my list over here. And then we are printing my underscore list. So if we run the file here, we can see my list. And we can see at the beginning is 1, 2, 3. These are the new, which is my current list over here. My underscore list, 1, 2, 3. These are the new. But then we see characters in my list, and we can see these are all their own elements, because we can see the apostrophe at the beginning, at the end, separated by a comma. Or just to remove the initial part, 1, 2, 3, these are the new. Let's start off with an empty list. So what do we do with the characters in the list to reduce them to a single value? So there's multiple methods of doing this, but one is to use the reduce function. So each character was added as a separate value or item, but we want to reduce it to a single value. So what we can do to begin with is import our function tools. So because the reduce function is part of the function tools module, we will import the func tools module. Next, we will paste in my list. So we can see my list, and we can see each item or element is separated by these apostrophes, separated by a comma. So we can see everything is a separate element. We want to reduce it to a single value. So here's my main bit of code, and we will store it inside a variable called my underscore single underscore item equals functools.reduce. And we can see the three arguments here. So we need to pass in the function and then the sequence. And then this is optional, which is the initialize parameter. So we are going to use a lambda function inside here, and we are going to perform this function on two values, a and b. So what we are going to do with them is we are going to add a plus b, and then we are going to perform this on my iterable, which is my underscore list. And next we will print the result, my underscore single underscore item. Let's run the file, and we can see characters in my list as a single element. So as already mentioned, it performs this starting from the left hand side on the first two elements, a plus b. So it adds c to h, and when it's done this, it repeats the process again. So c and h become one value, and then when it repeats the process, this time it adds c and h to a, and then it repeats the process again until eventually the result is a single value, characters in my list. So looking at the third optional parameter, I'm going to undo my changes, so my underscore list is back to the original format. So the third parameter is the initialize parameter, and let's type in anything for sake of argument just to have a look at how this works. So this is an optional parameter, which is the initialize parameter, and the initializer is placed before the items of the iterable in the calculation and serves as a default when the iterable is empty. So now we've got an element called hello in there. This should be placed at the beginning of the result. So let's run the file, and we can see it's placed at the beginning, hello. Maybe we need a space in there as well, and let's run it again. Or hello, these are the, and run it again. So hello, these are the characters in my list. And of course, if we don't have anything in my list, let's remove everything and run the file again. And as we can see, if the list was empty, it will still run and the initialized value will be present in my list. And that's it for this video. That's a high level overview of the reduce function, which is part of the function tools module to reduce items in an iterable to a single value. Welcome back to another video. This video is on Python regular expressions. A regular expression, or regex for short, is a sequence of characters that forms a search pattern, and it's used to find a particular pattern within a given string. If you are looking for something in a large data set and it's something complex, or it could even be something basic but has a certain pattern structure to it. For example, it may begin with something but it has to end with something, or it may be all capitalized or all small, or a combination. It may be a range of numeric values, it may be certain characters or symbols, and they may start at a certain position and finish at a certain position within a string. And there's some repeatable characters within the string as well. So all these kind of things you want to make a regular expression for, to be able to find this search pattern. And regular expressions are supported by many programming languages, including Python. And Python has a dedicated module for this actually. So to work with regular expressions in Python, you need to import the built-in RE module. RE stands for regular expression. So this module has been purposely built to assist with regular expressions. And most of the methods within the RE module work with something known as raw strings. This is because regular expressions makes use of the backslash symbol. And if you've been following my course, you know that backslash symbol is the escape symbol. And Python uses the backslash symbol in regex expressions as well. So Python, outside of regex expressions, uses the backslash symbol as its special characters, also known as an escape character. So there is a conflict, and for that, as a workaround, Python makes use of the raw string notation. And we can see an example in red on how to use the raw string, which uses a small or a capital R. In our case, we're using a small r, but this turns it into a raw string, and we can have a look at an example in a second. So if we have a look at an example of using the backslash with a raw string versus without a raw string, we can see in the top example my_raw_string equals r to transform this into a raw string. And now if we have a look at the the \n, usually Python interprets this as an escape character, \n, which is a \new line. But now that we have interpreted this as a raw string using an R, or you can use a capital R, we can see the result, the output. So my raw \n, so it's literally pasted the \n rather than creating a new line. So the string hasn't moved into a new line. But looking at the second example, we have not used the R to convert it into a raw string. So we can see Python has interpreted the \n as an escape character, a new line. So this is where the raw string comes useful. It ignores escape characters. So we can see it's moved string into a new line. And last but not least, expressions can be very simple to find or match a particular word, or a very complex example. For example, if you wanted to find a specific component from a URL, such as a domain name path or query parameter and so on. So regex expressions can be as complex as you like. Now that we have a very basic concept of regex expressions, now let's have a look at all the tools associated with regex expressions. To start off with, let's have a look at the methods associated to the RE module that we will be using to search for or match on regular expressions. So the first one is compile, and although I am going through the theories of all of these, it will make more sense when we have a look at these in action. So when we do the hands-on demo, a lot of these will make more sense. The compile method, this creates a regular expression pattern object, and then we can use this pattern object to search for a match within a given string using other methods such as search or match. Now again, this will make more sense when we have a look at it, but this is useful because when using the pattern multiple times in a program, rather than creating the pattern each time, it's better to create the pattern once and then use it where required. So this is the use case for compile. So there's benefits to this because in the future, any changes needed to that pattern, we just update the object, the one object, which would impact everywhere it's used within the program, rather than changing the pattern everywhere it has been referenced directly. So it scales well in a larger program and therefore more maintainable. Then there's match, and match returns a match if a match is found, but only at the beginning of a string. Next is full match, which returns a string if the whole string matches the regex pattern. Search is the next one, and with search this returns a match if there is a match anywhere within the string, and will only return the first occurrence that matches the specified pattern, and search is a common method used. Then there's find all, another common method, and this returns a list containing all of the matches it finds and returns them as a list of strings, with each string representing one match. Next is split, and actually with split we will demo this one now. So this returns a list where the string has been split at each match. And as we are going to be using the first three methods, let's have a quick look at this split method, and then we will have a look at regex expressions and how to build regex expressions in more depth. So using split, it splits an input string, and you can specify the maximum number of times you want to split it into an array of substrings, and you can define the position as well. Now I'm going to paste a string in here. So my string equals your order number is, and then the number. Thank you for your custom. Please give us a call if there's any issues. Now let's say we want to split the string at each white space character, and for this we use something called the \s, which is to match on white spaces. We will be having a look at all of the meta characters next. So just for now, just know that \s is for white spaces. And then there's a plus as well, and the plus is saying the \s has to occur at least once, but can occur unlimited amount of times. So how we write a regex expression. So we will store it in a variable called r1 equals, and if we do re dot, we can see all of the functions and methods and everything else in here, and we can see split. So split has 4 parameters: pattern, string, max split, flags. So you can specify the maximum number of splits, but you have to specify the pattern, which is the regex pattern, and then we specify what string we want to run this pattern on. So let's select the split method. Now in here we will specify our regular expression, and it's \s to match on white spaces, and then plus to at least match once, but match unlimited amount of times. And then what are we running this regex expression on, which will be my underscore string. Next we can print the result of r1. Now if we run the file, we can see the result. The split method has split each word by white spaces, and you can see they are all in their own elements now. Another thing we can do is a conditional statement. So if we do if my underscore string, and if there's a match, we print there is a match, else we will print no match. So if we run the file again, we know that there is a match. So it should print there is a match, which it does down here. Next, we will jump back onto the PowerPoint slide, and the next one is sub. So you can replace one or more matches with a string using the sub method. So let's say you wanted to replace the order number with order cancelled because the customer cancelled the order. Let's actually have a look at this one now in PyCharm. So we will stick to the same string, but over here we will change this to sub. So re dot, we remove that, we do a dot, we should see sub inside here. So sub has a pattern, replication string, count and flags. Let's go with this one. So what I'm going to do is replace my order number with order number has been cancelled, and then we are going to run this on my underscore string, and then we're going to print r1, and then I've got my conditional statements here as well. So let's run the file. So we can see your order number is, and then it says order number has been cancelled. So that's probably not a great example, but you get the concept. You can use it to replace things. Now back to the slide to learn about regex expressions. So the next page is on how to build these regex expression patterns, and for this one of the tools is the meta characters. So various operators and symbols are used as something known as meta characters, and the meta characters are special characters, and you can see them as rules to help define the regex patterns. And when we start having a look at these in PyCharm and creating some patterns, we will use this as our reference guide. So we can see at the top left, I'm not going to spend too much time with this because we're going to have a look at each one of these in PyCharm. But dot means match on any character excluding new line. And then the star matches 0 or more repetitions of the regex pattern. We've got some examples here as well. For example, the dot is to match on any character between 1 and 3, 7, 8, 3, 2, 1. And that any character between 1 and 3 can be obviously any character. So as long as it sees the 1 and the 3, and then it will pick out whatever this character is, well, it will match on it. And then there's plus, which matches 1 or more repetitions of the regex pattern. Question mark matches 0 or 1 repetition, or you can call it occurrence as well. Then there's a caret sign, matches the beginning of the pattern. Then the dollar, which matches the end of the pattern. Then we've got the backslash, which is used before a meta character to instruct Python to treat it as a normal character, because dot and a plus is a meta character, We can see it here, and we can see it here, but for example, dots are used in URLs, so we don't want it to treat it as a meta character. So we can see here, interpret the dot as a literal period and the asterisk as a literal asterisk, rather than as a regex meta character. So this will mean it will ignore that it's a meta character, it will treat it literally as a dot or a star or a plus. And this is important, for example, in URLs where you use dots, for example, you don't want it to treat it as a meta character because you're searching on a dot. So the backslash is used for that example. Then there's the vertical line or the pipe, and it's an either or, so you can do find ABC or you can do find XYZ, for example. So find this sequence of characters or that sequence of characters. Then there's a set. We are going to have a deeper look at the set, but for now represents a set of characters, also called a character class. I've got a dedicated slide for sets coming up. Next is the curly brackets, the exact number of occurrences. And one example I've got is you can specify 3 in there for www when you are specifying a URL. Then there's the normal brackets. This is known as a capture group and is returned as a group of regex expressions. Next is a regular expression, escape sequences or special sequences. So an escape or special sequence is defined using a backslash followed by a character to provide a function in order to define a regex search match criteria within a given string. So it's similar to the meta characters, and we can see a backslash capital A, it returns a match if the specified character found at the start of the string. Actually, I should have put a Z next to this one because a Z at the bottom returns a match if the specified character are found at the end of the string. Then there's the small b, returns a match if the specified character are found at the beginning or end of the word. Capital B returns a match if the specified characters are found anywhere within the string, excluding the beginning or end of the word. And then there's D for digits, so returns a match if the string contains numeric values, returns a match where the string does not contain numeric values for capital D. Small s, we've already had a look at this when we had a look at the split, so returns a match if the string contains a white space character, and a capital S returns a match if the string does not contain a white space character. And then there's small w, returns a match if the string contains any word character, so this is a popular one. So it can contain A to Z, 0 to 9, or an underscore. Then there's the capital W, returns a match if the string does not contain any word characters, so maybe a hyphen, a star, a special character, a symbol. And then there's Z, which is the one that we've already had a look at. So if a specified character is found at the end of the string. So again, this is another group of special characters to help us build our regex expression. Let's have a look at the third one. Actually, the third one is coming up next, which is the sets. But this one is a different way to group the previous two slides. So instead we can group it this way. So these describe a position. For example, the caret and the dollar, which was on the first slide, they match the beginning of the pattern and match the end of the pattern. And then on the second slide we had the backslash capital A, capital Z, start of a string and end of a string. Small b and capital B, beginning or end of a word, excluding beginning or end of a word. So these are all positional special characters. So we may want to group it this way instead. So it's a better way of grouping them instead by the position. And then here, matching types of characters. So the dot matches any character, excluding the new line. Small d returns a match if the string contains numeric values, and etc. We've had a look at the small w. Again, that's a common one. Returns a match if the string contains any word characters, A to Z, 0 to 9, or an underscore, and so on. So these match certain characters. And then there's more as well, so grouped by repetition. So repetition, where I showed the example of 3 for www over here, and the plus, so match it at least once, but it can occur unlimited amount of times. And character classes is on the next slide. So these are character classes. So a set of characters can be used to define regex patterns. So the first one is 0, 1, 2, 3, 4, 5, and it will return a match if any of the numeric values within the square brackets are present. And then there's 4 to 8, so this is a range. So these are a range, so between 4 and 8. I've missed the description out here. So this is a range between 4 and 8. So I have the description in this time. And then there's 0 to 7 or 0 to 8 in their respective square brackets. And this matches any numeric values between 0, 0 and 78 are found. And then there's the small a to z and big A to z in the same square brackets. This returns a match if any characters between A and Z that are either lowercase or uppercase are found. And then there's AXYZ returns a match if one of the characters within the set AXYZ is present.
And then the caret sign AXYZ returns a match if any character excluding AXYZ are found. And then there's A to J, which is like the 4 to 8 over here, returns a match if any lowercase characters between A and J is found. And that's it for all the tools that work with regex expressions, the tools to find a match on regex expressions, and the special characters to create these patterns. Next, let's jump into PyCharm and see how all of these work. So the first thing we will do is have a look at the directory. So I've got import re, import regular expression module, and if you've noticed I've got import pprint. So that import pprint, if we do print directory regular expression and run the file, we can see the directory, but it's horizontal. So I've got to scroll across. We're using import pprint, which is a module in Python, and it's a utility module, and you can use it to print data structures in a pretty format. Basically, it makes it more readable. It prints it out vertically. Actually, it's not done that because we haven't used pprint. So let's use pprint. So it's pprint.pprint. You can see all the parameters inside here. And then it's directory, and then it's re. And let's run the file. And now we can see it's printed it out in vertical format, so we can scroll up and down instead. And you can see all of the methods inside here. So now back to regular expressions. So all we need here is the import of the re module. And the first one, let's create a simple expression to match a pattern using the search method that comes with the re module. So let's paste our string in again. So I have my string equals, and then I have my string. Now over here we will create our variable my_search equals re.search, and then we will search for 39. And then what we're going to search against is my_string, and let's print the file. Print. And let's print the result of my_search. So if we run the file, we can see it's picked out the value 39 in my string over here. But what search has also given us is the span, so it spans from 30 to 32, and we can count across, so it'll be 30 to 32, and it also tells us the match, which is 39. So we've got to bear in mind that the search only finds the first occurrence. If there was another occurrence, it wouldn't match on it. So that's where we use the find all. But we will have a look at that shortly. And if it does not match, let's put in something else here, 89, and run the file again, we get none. So it starts at character 30 in the string, and it extends up to but not including position 32. So it's 30 and 31. So this basically tells us the search method has found a regex pattern of 39, which exists in my_string. But this is extremely basic. We are directly looking for a sequence of characters using the search method. We can also use another two methods, by the way, that are part of Python but outside of the re module, which is the find and the index functions. So this is outside of the topic of regex expressions, but just to show you, if we do r1 equals my_string.find 39, so it's looking for 39, and r2 equals my_string.index, and we are looking for 39, and then we are printing the result of r1 and r2, and if we run the file, it tells us the position, so the position is 30. So the find and index functions are very similar. Both of them return the index position of the first occurrence of the portion of the string you are looking for within the string, but the difference is that Python find produces a -1 as an output if it's unable to find the string, where index outputs a value error exception. By the way, I moved my conditional statements, so I want to put them back in. So we will match on one of them, and there is a match in this case. Actually, that's wrong. So it shouldn't be having a look for my_string. There's always going to be a match. That's why it's matching now. So this should say my_search actually. Let's run the file again. No match. It shouldn't be a match. It should be if my_search. The result of my_search we are wanting to have a look at. So what I'm going to do to make sure we do this as quick as possible. So in the first example, let's have a look at the .meta character. So I'm going to paste in some more code, and this time we've got my_string equals order number is, and then we have the order number, and then we have r1 equals re.findAll, and here we have order number is 5, and then we have the dots which match on any character except the new line character. We have it in there 3 times. And then we have 66, and then we are matching against my_string. So we have 5 here, and then we have 955. So those are the 3 characters here. So if we run the file, of course the conditional statement is looking for my_search. If I just change that to r1,
and run the file again, and we can see there is a match and it's found the order number is 595566. However, if we remove a dot, so there's now 2 dots, and we run the file again, we can see there's no match because there are no any 2 characters between 5 and 66. We can see 5 and 6 here, so there's 1 character, or we can see this 5, and then we can see 5, 6 here, 2 characters here, and 6 here, but there's got to be 6, 6 here. It's 5 dot dot 6, 6. So we're not finding this combination, so it has to be the exact number of characters. So the before and after have to match, and the number of any characters represented by the dots have to match as well. So you cannot put 2 dots when there are 3 numbers you are looking for, using the dots example in this case. If we put the dots back in and we change this, for example, to 3, of course it's not going to match again, so we are going to get no match. Or if we remove the 6 and change that back to 5 to see what result we get this time. So it does match this time because there's a 5 dot 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 6, and we can see here 5 dot 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 6. So that matches, and everything before the 5 as well. However, rather than putting in 3 dots as we've done over here, or even 4 dots, why don't we use the curly brackets to match the exact number of occurrences? So we can do 4. So 5 dot, and we want this to repeat exactly 4 times. And now if we run the file again, we can see we got a match. Of course, if we specified another value instead, let's go for 2. We can see there's no match this time. Now, because the dot operator will find any character, we remove all this and use a dot on its own. The dot meta character is to match on any character, excluding the new line. It should match on all of the string. Let's run the file, and we can see it's matched on everything here. And we used the find all method to do this. Let's change this to the search method instead to see what will happen this time. So we did get a positive result in terms of a match. There is a match, but as mentioned, the search method only matches on the first occurrence. So it's only matched on the O. We can see here match O. So it's only matched on the first occurrence because that's what the search method does. However, if we use the meta characters plus or star, so the plus has to have at least 1 occurrence or unlimited amount of occurrences, or the star can be 0 or unlimited amount of occurrences. These are repetition operators. So as we are only using the dot to match anything with the string and asking the plus to repeat it, so now if we are using the dot to match on any character, and then we are using the plus or the star as repetition special characters, eventually it will return everything because they just keep repeating. So if in here we specify plus, now if we run the file again, we can see we get the full match. Order number is, and then the order number. And this will be the same for star as well. If we run it, and we can see again, order number is, and we get the full order number. So the star matches 0 or more repetitions of the regex pattern, where the plus matches 1 or more repetition of the regex pattern. Before we go back to plus versus star, because they behave very similar but there are differences, I just want to have a look at flags with the search option and the meta character group. Next, I want to have a look at the capture group meta character. So the bottom one with brackets, and let me paste in my code in here. So we have my underscore string and it equals order number is, and then we've got a \n for new line and then the order number. This time we're using r1 equals re.search and dot plus, so it's searching on anything. And then we are printing R1. Let's run the file. So there is a match, and the match is order number is. And over here we can see it stopped where there is a \n for new line. So it matches only the first line. And for this we can specify a flag to avoid this as a third argument. So as we have seen in the parameters, there is a third argument, and that's the flag. And we can also use a raw string, but let's go with the flag just to demonstrate how the flag works. And in this situation, the flag will be re.S. Now let's run the file again. So now we can see with the flag, we get the full string back, which means it's treating the new line as part of the search and not excluding it. So it's not treating \n as a special character. So next we can have a look at the capture group, which returns a group of regex expressions. So over here we can do print r1.group, and let's run the file, And we can see using the group method, it's printed the order number on the next line. Now, if I change my code again, so I've got my underscore string equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and we are searching for 89.star. Gain.star means matches 0 or more repetitions of the regex pattern. So you can match 0 times or unlimited amount of occurrences. Now, if we run the file, we get a match, which is 89. And the plus has to match on at least one occurrence, but can be unlimited amount of occurrences. So many of the times I get the same result. However, where they differ is at the end of the string. If I try to match on 89.star, so I am saying 89 and anything after it, it returns a match. So we can see it spans 7 to 9, not including 9, so 7 and 8. And we can see the result of 89. But if I use a plus instead and I run the file, I don't get a match. There's no match. And this is because plus means at least one occurrence. So it's matched on 89, but the dot is any character after it. There is no character after 89, where the star is 0 times. So although it's got no match back, it still prints the output of 89. So just remember the star is 0 or more and plus is 1 or more. Let's have a look at the question mark, which is match 0 or 1 repetition. Let's do 2, 3 dots for any character, question mark 5, and run the file. Next, if we change the 5 to a 6, and if we run the file again, we get no match. Because although it repeats once, it cannot repeat more than once, so we don't get a match. We change that to a star instead, and let's run the file. We do get a match, because the star is 0 or unlimited amount of times, but the question mark is 0 or only once. So that's the difference between the question mark, the plus and the star. Also earlier, when I was having a look at the 3 dots, I could have done 1 and then done a dot star or a plus. Let's go with plus 9, rather than putting lots of dots. So here we're saying we don't know how many characters are in between 1 and 9. We just want to match on any characters between 1 and 9. So 1's here and 9 is over here. Let's run the file. And we can see matches on all of them using the dot plus special characters. So with the star or the plus associated with the dot, you just have to say begin with this number, 1 in this situation, and end with this, and we've used 9 in this situation. And we don't have to worry about if there are 1 or 10 characters in between. Next, let's have a look at the caret special character. So I've got my underscore string and I've got my order number here, order number is, and my order number. And then we've got R1 and we're using the find all method. Character order number is 3. If we run the file, we get no match because there is no 3. If we change that to 5 and run the file again, now we get order number is 5. So this will capture anything that starts with that pattern or sequence of characters in that exact order. And the dollar does it at the opposite end. So as long as it ends with it instead, so the dollar would go at the end here. If we run the file, we wouldn't get anything. But if I pasted in the end of the string and I ran the file again, we can see we get back the string and there is a match. Now let's say for example we have an order number and we wanted to match on all of the numbers from the first 3 values or the last 3 values, or it could even be names in a company. You have 5,000 employees and you wanted to find anyone with the name Jack as the first name or the surname, but for now because my example is the order number, we will stick to the order number. So I have my order number, which is 1, 2, 3, 5, 5, 6, 6, 4, 4, 3, 2, 1. And then I have my find all method. I'm having a look for either 1, 2, 3 or 3, 2, 1. So let's run the file. And we can see there is a match and it brings back both 1, 2, 3 and 3, 2, 1. If I change one of these, let's remove the 2 and run the file again. And we can see this time it only brings back 3, 2, 1. So that's how the either or special character works. And again, as a reminder, if we put back in the number 2 and change this to search instead and run the file, we can see search only matches on the first occurrence. I've not really used much of the match one, but we can use this one as well. And we get none because it doesn't match from the beginning of the string. Let's specify order in here, order, and run the file again. This time we see we get a match because order starts from the beginning of the string, and if we remember, match only matches from the beginning of the string. There is also utility built into PyCharm. If we hover over the formula and we press Alt and Enter, you can check the regular expression with a sample. So over here we do 1, 2, 3, and it gives us a tick. If we did something else, 4, 5, 6, we can see, or 5, 6, we can see expression and example does not match. So it's a good tool to use to test the formula. So we have used the search method, the match method, the find all method. Let's have a look at the compile method and why we need to use that sometimes. So let's say I have a string and I wanted to match anything from U to Z. And let's say we wanted to use this regex pattern 20 or more times in our program. So rather than using the pattern 20 times, let's compile it once and reference it wherever we need to use it. So I'm going to reference it twice using the search method. The first one is to search my_string, and the second one is another search requirement to search my_string_2 using the same regex pattern. Now if we notice, we can reference the same pattern using its name, match_u_z. To start off with, let me paste in my string, and my string equals, and it's just some random letters. So my string equals, and this is my string. This is how we use the compile method. So I've pasted it in. The variable is match_u_z. Of course, you can call it whatever you like, equals re, and then we are using the .compile method. And in here, we are matching anything from U to Z. Once we have done that, we can build our search patterns. So next, I will specify my search criteria. So I've created a new variable, my_search, and this will equal re.search as usual. Usually we specify the U to Z inside our search parameter as an argument, but this time we are going to reference our pattern already created, match_u_z, and then we are printing my_search. Now I can do this many more times in my program. So this time I'm having a look at another string, my_string_2, and it's got lots of names in here. And then my_search_2, this time it will equal re.search. And again, we are referencing our pattern. We are referencing u-z using its name here. And then printing the output of my_search_2. Let's run the file. That's produced an error because R1 doesn't exist in here. So let me change that to my_search for now. And let's run the file again. And we can see the first one matches on W. So in here we should see a W, which is over here. That's the first letter between U and Z. And the second one matches on U. John, Jack, Jill, and Julie has a U. Now imagine I had to change this formula to make it much longer and much more complex. Or it was already long and complex. I just had to change the formula. Well, I just need to change it once over here, rather than changing it all over in my program. But for our example, we won't make it much longer and complex, but we can add to it. So we can see it already produces a match for each of these strings, but let's use the .plus meta characters so we can see the rest of the string as well and run the file. And it's going to do nothing if it's inside the set. Let's specify it on the outside of the set and run the file again. So this time it's a better result because we can see where it starts at W, and then we can see the rest of the string. So W over here and the rest of the string, and we can see the U and the rest of the string. So the rest of Julie's name, and then we can see James XYZ. And the best thing about it was we just updated the code once. So we can see where the compile method comes in handy. We just had to update the code once, which trickled down into the rest of the program, wherever it was referenced. So next, let's move on to escape sequences. So let's remove all of this and replace it with some more code. So here's my string, and here's r1 equals .findAll \A, and this returns a match if the specified characters are found at the start of the string. And we've got your order here. We need to change this to R1, and let's run the file. So we can see there is a match and it returns your order, and it's case sensitive as well. So let's change the y to a small y and run the file again, and we don't get a match. Let's replace the search pattern with something else. Let's go with R for raw string, \bu. So the \b returns a match if the specified characters are found at the beginning or the end of a word. And you have to use the R, so Python interprets this as a raw string, and raw string is required when a string needs to contain a backslash for a regular expression. And you don't want the backslash to be treated as an escape character, as usually the backslash works with escape characters, such as a \n for new line, a \t for tab, or a \r for carriage return. So we use a raw string so it doesn't treat it as an escape character. Got too many commas in here. And if we run the file, because we're using the find all method, it's returned u twice. If I remove the raw string, we can see the \b has changed colour and it doesn't work this time. So let's put the raw string back in. So we can see u over here at the beginning of a word, and we can see u here as well at the beginning of the word again. This is not at the beginning or at the end of the word, so I guess that's why it's returned it twice. So let's use the \d to see if the string contains any numeric values. We can see it does. We've got the order number here. Or let's try a capital D where the string contains any value other than numeric values. And we can see it's printed everything other than the numeric values. So it's even printed out the white spaces and the \n, but no numeric values. Or let's try a capital W, which is an interesting one. So it returns a match if the string does not contain any word characters. Let's run that. So you can see it returns white spaces, commas and \n, but no numeric values or no normal characters. Next, let's have a look at sets. So sets are in square brackets. Let's have a look at all the characters between A and J and run the file. And so it's extracted all the characters in the string between A and J and returned that to the screen. Or we could use some numeric values as well, 4 to 8, and run the file, and we can see 4, 5, 6, 7, 8. Now let's have a look at combining these meta characters, these sequences and sets. So I'm going to paste in some code here. There are always different variations of spellings. For example, adapter spelled with an E or an O, so we can do that over here. So I'm looking for my_search, re.search. I'm looking for adapt, and it could either be an E or an O, and then ends with an R. So let's run the file. It's complaining about the conditional statement again. Let me fix that one. So looking at the result, we get a match, and the match is adapter. So I guess if I change that to an O and run the file again, it still returns a match. If I spell that completely wrong with an A, this time I do not get a match. Now let's have a look at another example. So let's say I want to return the order number, and I know it's 11 numbers, so we want to be precise. So we can do either \w or \d. \w is for any characters, or \d is for numeric values, and then let's use the curly brackets to pull out exactly 11 digits. So \w means any characters, and we want to be precise, so we are specifying that it's 11 digits. Let's run the file, and we can see we get a match, and we can see we get the order number back, because that's the only thing that equals 11 characters. Or we could put a range in here. Let's go with 8, 11, and run the file again. So this time we get the order number back again, but there are more items between 8 and 11. So actually, if we change this to the find all method and run the file, we see we get back the order number as well as purchase and accepted. Now I have put a couple of dates in my string. Let's now say we have some dates we want to search for. So we have a regular expression to match on the date, month, date and year. So \d to match on any character, but the day and month can only be of 2 occurrences, so we put them in the curly brackets with the value of 2, whereas the year can be a value of 4. So this is very specific, and we will hopefully only pull out the dates when you run it over a large set of data. And if we run the file, we receive back the dates. The next example, let's match any uppercase character at the beginning of the string. So we use the caret symbol and our set here, and let's run the file. And of course, using search, it only finds the first occurrence, which is Y. So let's change that to find all. and run the file again. And we still get Y because the caret sign means only at the beginning of the string. So I guess if we remove that, we'll get a lot more of a response. So this time we get Y, P and R, which are our uppercase characters. Y over here, P over here and R over here. And for the last example, let's look at a URL. I'm going to paste in a list of URLs. So the first URL is example.com, and then there's example.co.uk, example.us, example.gov, and example.whatever. And the first three are HTTPS and the last two are HTTP. So let's create a search pattern called R1. R1 equals re.findAll. And let's search for HTTPS :://. And let's ensure there's 3 occurrences of the W. And I think let's just run that for now. my_list prints R1. Let's run the file. And it's complaining over here, type error, expected a string. So let's convert this into a string. Hopefully that should do the trick. And if we run the file again, we can see we get back all of the HTTPS : / and we get back www. Now let's say we wanted to match on only the com and the gov domain. So if we build on this pattern over here, because we want to literally match on the dot, we need to specify a / before it. And then let's do a /w for any character, and plus to make sure it repeats as many times as possible. Dot, and then in brackets we can create a capture group of com or gov. And let's run the file. And we can see it returns back the domains for com and gov. I'll add some dots before them. So now we can see it comes back with all the domains ending in .com and .gov. And that's it for this video. That's a high-level overview of regex expressions. Thank you for watching. This is a video on how to debug your Python code. I'm using PyCharm, however we will be using the Python PDB Debugger that comes pre-installed with Python. So this is relevant to Python regardless of the IDE. Python PDB, by the way, stands for Python Debugger. It is used to debug Python code, and it's an interactive debugger module that comes built in with Python. It enables you to navigate through your code step by step, examining variables and troubleshooting problems in your Python program. And it's important to understand how to use PDB, because although you may have the luxury of using an IDE and its built-in features for debugging like PyCharm, there will be times when you are debugging Python code on other systems like servers and you are not able to use an IDE. So this is where it's important to understand how to use the Python debugger from the command line. Now in this slide we can see many of the commands we can use with the Python debugger. I'm not going to spend too much time on this. We are going to have a look at this in PyCharm, but we can see on the top left how to start the Python debugger. So it's python-m pdb, and then it's the file name. So I've called it myfile.py, which will start the debugger. And by the way, over here at the bottom right is the help command. And this is a key command you can use frequently because it will show you the commands available. And if you needed to know what a specific command was, you can do help and then type the command. For example, I can do help and then type break. And then it will give me some information about the command break. So we can see all of these commands, and we can see you can type C for short or the full word, continue, down, next, return, step, up, but there is the shortcut to these commands as well. So you just have to type C or D, N, R, S or U. So all of these have shortcuts. And the slide before, although it was not the full exhaustive list of commands, it was many of the commands, but this is more of the frequently used debugger commands, and these include the following. And the first one is break, and the break command is used to set up breakpoints in your code. And the breakpoint is used where you need a debugger to pause execution, allowing you to inspect the program state variables and control flows at that particular point. So that way your full program does not execute using the debugger. It lets you inspect chunks of code at a time using these breakpoints. So you run the code, and whatever you need to stop the code from running, you specify a breakpoint there. And then you can analyze your code and what the debugger has seen before continuing with the rest of your code. And you can set up multiple breakpoints. There's also continue, and this will continue execution until the next breakpoint or until the program ends.
So this executes the code until the end of the code unless it hits a breakpoint. Help, which displays help information for the debugger commands. And list, which lists the source code, and so it prints 11 lines of code around the current line, and if you type it again it will print the next set of code after that, so you can see what's next in your code. It's a good reminder to show you where you are and what's coming next. By the way, you can also do a double L for long list, which will give you a bigger chunk of lines. Then there's step and next. The step command executes the current line of code and enters into any function called on that line. So it allows you to dive into the function and debug it line by line. So you will actually be debugging the function line by line. Whereas next, the next command also executes the current line of code, but it does not dive into any function calls encountered on that line. So the difference between step and next is step, you step into a function, and with next, you step over a function. We will have a look at step and next and the key difference in PyCharm. Then there's return or R, which continues execution until the current function returns. Print evaluates and prints the value of an expression or a variable. Quit will exit the debugger. Where will print the current position and stack trace. You can use the where to find where you are in execution. And the last one is what is. And the what is command is used to display the type of specified expression or variable used. It allows you to quickly check the data type of a particular object during debugging, like a float, string, integer, etc. Next, we can go into PyCharm and have a look at the Python PDB Debugger. And we are in PyCharm, and I have some basic code here. So we are printing hello1, hello2 and hello3 to the screen. Then I have created a function called my_profit, and we are adding profit_1 and profit_2 together. And then we are calling the function here, my_profit. And then we've got some input variables asking the user how much money did you make today. And then we add profit_1 and profit_2 over here as well. And we store this in total_profit and we add them together. And then we print total_profit to the screen. So if I run this file, we can see it prints hello1, hello2 and hello3. It also adds the two numbers together, which is the one from my function over here, 5 plus 1 equals 6. And then for how much money did you make today, I can specify some values. Let's go with 8 and 10. And we can see from the result it's 810. So it concatenates them together, it does not add them together. Now to start Python PDB in PyCharm, we'll right click my file, first py file.py, and we will open in terminal. And you have to ensure you are working from the correct path where your files reside. So you can do that again by right clicking your file, and then you can go to copy path reference and copy absolute path. But we can see I'm already in the correct path. But the way we do that, we type cd for change directory and then right click paste, and then it will paste in my path. We don't want my file, of course, so we remove that. And then we press enter and we will be in the correct directory. For me it's the same directory. And we can also run the file from here. We just specify Python and then the file name .py. But we are not going to do that. We have already ran the file. Using the play icon in PyCharm instead, we are going to start the debugger. And the way we do that is Python -m pdb and then the file name. Don't forget the .py extension at the end and press enter. Now if we have a look, we can see our actual source code on the left, and we can see it's print hello1, which is the very first line of our source code, and we can see the debugger starts at the very first line of the source code, so we can see that over here. And now this is where we can type help to see the debugger commands. So if we type help, we can see many of them here. A lot of them are short abbreviations. For example, N for next, double L is for long list if you want to see the next chunk of lines, H for help, or you can type help. So if we type H here, we'd get help again. Clear will clear the console, and you can see all the short abbreviations again. Q for quit, R for restart, and then we can find out what a specific command means. So we can do H for help, and then let's say we want to find out what break means. So break is for breakpoints. It also tells you how to configure break. Let's do another one. Let's do N for next. So it gives you information about what next is. Now let's have a look at some of the commands.
So we know we are at the top line of code, but if we type in list, it will tell us where we are. So the arrow icon here, we are at the top, print hello 1 over here, and then it shows us the next 11 lines of code. If we do list again, it shows us the next chunk of lines as well. But because our source code is so short, it shows us everything. Now you can imagine if you are in middle of debugging your code and you have hundreds of lines of code and you just want to see what your next 11 lines of code is, you can use a list command. Also, there's the double L for long list. So the list is a bit longer. We can also specify the command where. So it will tell us where we are in our code. So of course we haven't done anything yet, so we are still on hello 1. But we can do N for next to execute the current line of code. So if we do N here, we can see it's executed that. So we've got hello 1 as the output here. And now we can see with the arrow, we are on the second line of code. So using N, we can execute the code line by line. So I've pressed it again, pressed it again. Now I've pressed it the third time. We can see this time, we can see now it's printed out hello 3, which is here on the third line. And we can see the arrow points to my function. Now this is the difference between next and step. So next is referred to as step over, where step is referred to as step into. If you recall, I said earlier, step is used to enter into a function, while next is used to execute the current line without diving into the function. So at the minute we can see we specified N when we was on my function, my underscore profit. So it's jumped from line 4, it's jumped to line number 9. So we are on my function, calling my function, my underscore profit. And it's not really given us any output here with 5.1, print profit 1 plus profit 2. None of that has happened. It's jumped to line number 9. So let's see what it does this time. And we can see it's given us the output of 6. So 5 plus 1 equals 6. So it's called the function and it's jumped to line number 11. So if we quit the program, by the way Q is for quit, and run the file again, let's do next a few times. So now we are on line number 4, define my underscore profit, which was here when we did N for define my underscore profit. It jumped to line number 9. So let's type in the S to see what happens here, which it does the exact same thing. It's jumped to line number 9. Now this is where the key difference is where there is a function call. So again, if we go to where we specified N, when it jumped to line number 9, it was over here. So we see the arrow, my underscore profit. This is the function call. We specified N, it gave us the output of 6 over here, line number 9, and then it jumped to line number 11. Profit underscore 1 equals input, how much money did you make today? So it's jumped to that line, and then we quit. But it did give us the output of 6, but it stepped over the function. So let's see how S behaves, because S steps into the function. So if we do an S, and we can see the difference. So it says call for function call. And we can see here, define my underscore profit. So it's gone back to the function. So it's jumped from line number 9 back to line number 4. It's going into the function now. Let's do an S again. And now we can see it's going line by line inside the function. I guess we can do an N from here as well. Let's try an N. And we can see it's giving us the second line, profit underscore 2 equals 1. Now at this point we can do a what is as well, because we've defined, or should I say we have executed profit underscore 1 and profit underscore 2. If we wanted to know what these variables are, or the type of variables they are, we do a what is, and then we can do profit underscore 2, for example. Okay, so that's my mistake, because actually we have not executed profit underscore 2. We are actually on the line, so we can execute that now by doing N for next. Now let's run the command again, since we have now executed that line, and now we get the result. So it says it's an integer. So that's what the what is command does, by the way. Again, I mean, we can do an S instead here, and it gives us an output of 6. So that's the difference between N and S. N steps over the function call when we were on line number 9. It still gives us the output of 6, but it didn't go through the function. So this, using the S, went through the function. it went through line by line on the function. So it stepped into the function, it did not step over the function. There's also C for continue, but we can do help instead, just to have a look at the commands again. So with C, we can execute the rest of the Python script right to the end. So if we do C, and it's got to the input function where the user has to specify something. So I can do 5 here and 20, and we can see the result is 520. I guess if we do a what is this time, what is on profit underscore 1, put a Z on the end of that, so remove the Z. Okay, so it cannot run because the program finished and will be restarted. So instead, if we do a quit here again and run the program, we can do a C for continue. I guess C will be more effective from this point because we are starting from the beginning of the program. So at print hello 1, and it will run right through the program until our input value is required. So let's do C. And again, it's got to, how much money did you make today? Let's go with 5 and 2. So of course this is not going to work because the program finished and will be restarted. It says it there. So now what we can see is restarted the program again. So it's restarted at hello 1 again. So that's the thing with continue. It goes right through the program without stopping. It executes the full script. So what we can do instead is use breakpoints. We can either add a breakpoint here. So we can do breakpoint. Now there's a breakpoint on line number 12. So if we do continue this time, it gets to line number 11. How much money did you make today? Let's do 12. And it's not taken that breakpoint into effect. And this is because the program needs restarting. Let's quit this and restart again. Let's hit continue. And let's go with 12 again. Now we can see it's paused. So it's hit the breakpoint here. And it's telling us with the arrow, it's on profit underscore 2. So line number 13. And breakpoints are there for this reason. They allow us to stop execution of the program running at that point we specify. So at a certain point in your code block, we would set a breakpoint. So instead of using next line by line or nest to jump into a function call, for example, you may use continue, but you may specify lots of breakpoints in your code. And that way you can evaluate chunks of code before moving on to the next chunks of code. So I guess because it's already executed, line number 11, profit underscore 1, we can do a what is profit underscore 1. And we can see it's a string, and that's why it's concatenating them together like it was here earlier on, 810. So let's do another C to continue with the rest of the code and do 13. So we get the string concatenated 1213. And the way we would fix this is because it's specifying this as a string, the output value, we would use the function integer and not to forget our brackets. So now we can quit this. And actually, before we start again, let's do another breakpoint over here. So now we can see we've got 2 breakpoints. And then if we run the file again, we start at line number 1, hello 1. Let's do C for continue. So C for continue will execute the whole script or until it hits a breakpoint. So it should hit the first breakpoint, and we can see it's executed line number 3, hello 3 here. And we are on my function now, my underscore profit, because it hit the breakpoint on line number 4. And now it should hit the next breakpoint. So it should do line number 12 and then stop at line number 14. So do C for continue. How much money did he make today? Let's do 5. And now we can see it stopped again because of the breakpoint. And do a C for continue again. And let's go with 5. And now we can see it's adding the values together. So that's why we've got 10. So we have used breakpoints inside our actual source code. Let's remove these, because actually if we quit the debugger and restart it, if we specify H for help here, we can see we can specify a breakpoint within the terminal instead, rather than using the source code. So break over here. So let's do a help break, and we can see how we use this. We can also list all breaks, but for us we want to specify a breakpoint on line number 4. So we do break 4. Now if we do C for continue, we see it's stopped at line number 4. Let's specify break, and we can see there's one breakpoint, and it tells us the breakpoint has already been hit one time. But this is how we specify breakpoints within the debugger rather than using them within the source code itself.
And that's it for this video. So in our example, the source code was very simple, but you can imagine hundreds of lines of code and you have issues, bugs, actual bugs, where you want to debug them. So the Python debugger is very useful, it's interactive. You can debug code line by line, you can set breakpoints to debug chunks of code. You can use commands like where you are or what type of variables have been used, amongst other very useful commands as well. So it's worthwhile making sure you understand the basics of Python debugger. Welcome back to another video. In this video we are going to have a look at how we would integrate version control and collaboration tools for our projects. And this could be for our Python code, or it could be for Java, C, Swift, TypeScript, or any other programming language, any other code, HTML, websites. So we can implement version control for pretty much anything, and we can use collaboration tools. So a team of developers can access the same code from anywhere in the world. For version control, we will have a look at Git, and for collaboration, we will have a look at GitHub. At a high level, Git is a version control system. Git tracks changes to files over time. So Git tracks the changes you make to the files. So you have a record of what has been done and you can revert back to specific versions should you ever have to. Git allows developers to revert to previous versions of the codebase when required. And Git has other features as well. For example, branching and merging. We will have a look at this shortly. Collaboration. Now, although GitHub is a collaboration service as well, by nature, Git does collaboration. So we will have a look at the differences with collaboration between Git and GitHub. Git also has history tracking amongst other features. So in a nutshell, Git is a version control system. It will take multiple snapshots of your project, and then you have multiple snapshots you can revert back to if you ever have to. And looking at GitHub at a high level, GitHub is a hosting service. It's a very popular programming resource used for code sharing. You can see GitHub as a social networking site for programmers that many companies and organizations use to facilitate project management and collaboration. So GitHub provides a platform for developers to host, manage and collaborate on code repositories. It stores and manages Git repositories in the cloud with support for both public and private repositories. And GitHub can do other things as well, such as continuous integration and deployment, CI/CD and collaboration tools amongst other features. And GitHub has become an essential tool for many developers and technology professionals because it provides a platform to showcase their skills, experience and portfolio of work. And due to this, recruiters often turn to GitHub profiles when evaluating candidates. Also with GitHub, you can often reuse other people's work. Rather than creating your own work from scratch and vice versa, you can also share your own code with other developers. So as long as you adhere to the licensing terms that it is published under, you can copy the code from GitHub for your own use. However, just to bear in mind, not all code on GitHub comes with an open source license, but if it does, that license allows you to copy the code, modify it if you wanted to, and use it for whatever purpose you want. So in summary, you would need Git, which is a free and open source version control system, to manage your source code and make copies of it. And of course, it does other things as well. And when you want to collaborate with a team of developers, then that's when you would use GitHub to store all your code in the cloud, which is also a free open source cloud-based service for storing your code. And this makes it accessible from anywhere in the world. The second bullet point on this gives it away: store and manage Git repositories in the cloud. Let's have a look at what a version control system is. With Python, like any other programming language, version control is crucial to managing changes to your source code over time. Version control is needed for when things go wrong with your code. So typically, a version control system like Git provides the following capabilities. A version control system tracks and manages all of your changes to your code. A version control system gives you the ability to store copies of the code as you progress through building your code. A version control system could be for your Python code or any other code, or it can be for your web design layouts or images or anything else for that matter. And a version control system promotes team collaboration, where multiple developers can work on the same source code simultaneously without ever overwriting each other's changes. So it manages conflicts with changes for you as well.
A version control system enables tracking of all changes, what changes were made, who made the changes, when the changes were made. This helps with debugging and reverting to previous changes seamlessly or easily. A version control system provides branching and merging capabilities. Separate branches can be created to work on bugs and features without impacting the main branch, and these can then be merged back into the main branch. I am going to be expanding on branching and merging in this video shortly. Another use case for version control system, backup and recovery. In the event of a failure, a VCS or version control system provides a backup of your code. It's not supposed to be there for a long-term backup solution, retention backup solution. It's a version control system. But in the event of a failure, a version control system, regardless, it does provide a backup of your code. Again, it shouldn't be used as a long-term backup solution, as it's not being built for that purpose. And there are other benefits to version control systems, such as they can be used for auditing and compliance, code quality, of course, version management, and other built-in features and tools. Now, there are three main types of version control systems. The first one is local, so storing different versions of a file into the local system. The downside to a local version control system are that a team of developers could not collaborate with locally stored files, and it's a single point of failure. Then there's centralized. With centralized systems, they were created to facilitate collaboration amongst developers. All files were stored on a central server and accessed from a single location, but this also introduced a single point of failure. If the server or group of servers became unavailable, whether due to server downtime, maintenance, or connection issue, access to files would be interrupted. So to address the issues with local and centralized version control systems, distributed version control systems were developed. In these systems, each user has their own complete repository. Client machines create a full mirror image of the repository, including its entire history. This ensures that all clients have a complete copy of the repository. And with a distributed version control system, if the server goes down or fails completely, a client can upload its complete copy back to the server. There is no real server as such in a distributed version control system. Well, there is and there isn't. There is a master repository which everyone uploads and downloads their files from. We will have a look at this because this is very much how Git works. So moving on to Git. Git is a distributed version control system. In Git, each user has a complete copy of the entire repository, including its full history. However, rather than teams pulling and pushing changes to each other, there is a master repository. So Git kind of works in a centralized fashion as well, and the master repository is usually uploaded to GitHub so everyone can get access to it, as GitHub is a cloud-based service available at all times. Now, all developers pull and push from the master repository hosted on GitHub. However, it doesn't have to be on GitHub, by the way. It could be on a server in your network as long as you have Git installed on it and have a copy of the repository. But GitHub is kind of best practice with it being available from anywhere in the world, amongst other benefits. And since it's free and open source as well, then why not use it? You do not need GitHub, by the way, to use Git, but you do need Git to use GitHub. Now, another reason why GitHub comes into play is there are downfalls with Git. For example, developers have found the distributed nature of Git difficult to configure, whereas a single central repository shared by developers seems to be the preferred choice. And now with everything in the cloud, this is where GitHub addresses some of those limitations with Git. So you can collaborate with just Git. You just need to install Git anywhere on your network and all developers can collaborate with it. But when developers need to access files from anywhere in the world, then it makes sense to host it on a cloud-based platform where all developers have access to it at all times from anywhere in the world. And this is where GitHub comes into play. Looking at alternative version control systems, if we type Git Alternatives in Google, it provides a mixture of Git Alternatives and GitHub Alternatives as well. So as we have already gathered, GitHub is a cloud-based hosting service and it hosts Git repositories. So it serves a different purpose to Git, which is a version control system. Now Git is the most popular version control system and it's a distributed version control system, but there are also some of these as well. For example, Subversion, SVN. This is another version control system which is commonly used in enterprise environments for projects that require strict version control and access management. Then there is Mercurial. I hope I've pronounced that right. But it's similar to Git. It is a distributed version control system. It's designed more towards larger projects and built for scalability. Although similar to Git, it has a different set of design philosophies than Git. Mercurial users typically use another service which is called Bitbucket or other platforms that support Mercurial. So Bitbucket is a GitHub alternative. Now looking at GitHub alternatives, we can see GitLab and Bitbucket. So GitLab is a GitHub competitor that also offers an open source on-premise version of their software. It's suitable for teams and enterprises looking for an integrated DevOps solution. It offers tools for the entire software development lifecycle, from planning to monitoring with strong CI/CD capabilities. And then Bitbucket, like GitHub, Bitbucket is also another web-based hosting service for version control repositories. Bitbucket is a platform that facilitates collaboration, hosting, and management of Git repositories. And Bitbucket provides great collaboration tools for granular access control and integration with something called Atlassian ecosystem for software development, project management, and team collaboration. Now this is a bit of a duplicate slide comparing GitHub, GitLab, and Bitbucket, but the key note to take away is that all three are popular web-based platforms for hosting Git repositories and supporting version control collaboration. So this slide is an overview of Git. It's a bit of a duplicate, but after this we will have a look at the Git architecture. Let's take a look at the Git architecture, as it's essential you understand the key areas and some of the associated commands before diving into Git. So you can call them key areas or workspaces. We can see in the boxes are the workspaces, and we can see in red are the commands. So these are some of the common commands. Of course, this is not an exhaustive list. I have one coming shortly. So starting at the top left, we install Git on our local computer. Then one of the first things we do is use the git init command. This does two things. It initializes a project to work with Git, as we can see in the green box on the right hand side, which is the working directory. Git init, by the way, stands for git initialize. So all the commands are in red, by the way, and the boxes are our workspaces. Now this has initialized and created a working directory. And the second thing git init does, over here in the middle, it creates a new repository as shown in the brown box. So let me rephrase this. When we use the git init command after installing Git, Git creates the working directory, and it also creates a subdirectory called .git that contains all of the local snapshots. These are all of the commits we do and other metadata about the project, which is the local repository. So git init creates the working directory and the local repository. A repository is just a directory that is initialized with Git, and it can contain anything such as code, images, web content, or any other type of files. Now going back to the green box, this is the directory where we make our changes, and then when we are happy with the changes, we add these into something known as the staging area, and this is done with the git add command, we can see in red. Or we can use the git rm command, by the way, which is git remove if we was not happy with the changes and wanted to remove the changes. By the way, you may recognize rm as one of the Linux commands, as Git was created by the same person who created Linux. Now the staging area, this is a temporary holding place where you choose the changes to include in the next commit. It gives you a chance to review the changes before you actually finally commit them to the local repository. By the way, it's best practice to make little and regular changes. So then we can review and then commit the staged changes to the local repository using the git commit command, which in effect takes a snapshot and produces a hash for the commit, which is a unique identifier of the commit, and you can add a comment as well so you know what the commit is. And the git commit command is essentially creating a point in time local snapshot of the project, which you can revert back to in the event of any issues. So we created the local repository using the git init command, and we can see this in the middle, the brown box, and this created a brand new repository. But in a real world scenario, we may already have an existing repository, for example a remote repository hosted on GitHub, when a new developer wants to work on an existing project, and this is where they would clone the existing remote repository. So we could see the git clone command,
going from the remote repository, which could be hosted on GitHub or GitLab or Bitbucket or any of the other hosting sites, and it's cloning the entire project to the local repository. So rather than using the git init command, this is the alternative method using the git clone, cloning an existing repository, which in effect creates your local repository and your working directory on your local machine. And then on a daily basis or a weekly basis, when you make your regular changes, then we can use the git push and git pull commands. The git push command to push changes to the remote repository, or vice versa, we can use the git pull command to pull changes from the remote repository. So these are the basic building blocks of Git, and as a typical workflow, it will look something like this. You initialize a directory for Git, or you clone an existing one. You then add or change a file and add it to the staging area. You then commit the change to local repository, and then you push a file or change to a remote repository. And then on a regular basis, you are updating a local repository by pushing or pulling changes to the remote repository. So that's the typical workflow. Another part of Git which is important to understand is Git branches. So you can create different instances of your repository called branches. And a branch allows you to work on features and bugs without impacting your main branch. By default, there's only one instance of your repository called the main branch. I think it's also called the master branch. So master branch or main branch, and your main branch should be your main production branch, which is your stable code, and then you use other branches for new features and bug fixes. So you would typically use other branches for new features and bug fixes, which will provide an isolated environment for every change in your code base. So you can see a branch as a timeline of all your commits, and you can work on separate branches in parallel. So you can have a main branch, which is your main production code. I've got the diagram in front, so you can see the main branch is in green, and then you create another branch off it. You could create another branch off your main branch, and this will be a separate branch. So one for fixed bug, and another one for new major feature, and another one for new minor feature, or bug 1, bug 2, etc. And you could have feature 1, feature 2, feature 3. So you could have all these different separate branches. And then when the feature or bug fix is ready, you would merge these back into the main branch. Now on the bottom right, I have created the diagram again. So in green, these are all of our commits. So in effect, it's a timeline of the main branch. Now a separate branch has been created for the bug fixes, which has its own timeline, and another 2 branches in yellow and blue for features, which have their own timelines. And they all have something which is called its head, which is where the branch points to for its next commit. So the head is the reference to where the most recent commit in the current branch is going to be. And this is an important concept, in particular when working with Git Checkout, when you detach the head and when you are reverting the code. So the master or the main branch has its own head, but when you create a new branch, it will have its own head. So all of these are isolated from each other, and the next commit for each of these will point to their own heads or their own commits. This means all branches end up with their own timelines of commits. Eventually, we merge all of these together, and of course, it's simple to merge them on your local repository, but when merging them to the remote repository, where let's say a team of developers are working on, then you may need to resolve conflicts, which is, for example, when 2 developers have changed the same line of code and both are trying to merge back into the main branch. So most of the times, these kind of conflicts are resolved manually. You, as a developer, can resolve which change you want to keep. Now here are a few of the common branch commands. So using the command git branch without any additional argument will list all of the branches in your local repository. And to create a branch, you would use git branch followed by the name of the branch, and the star sign will represent the current branch, the branch you are currently on. We'll have a look at this shortly anyway. Once you have created a second branch, for example, then you can use the git checkout command, which allows you to navigate through branches. So now to switch between branches or to move heads, we use the git checkout command. Just for completeness, let's have a look at types of branches. So the main or master branch, which is the default branch, contains the stable version of your code. Then there's the feature branch, which is used to develop specific features, and once ready and tested, it's merged back into the main branch. And then there's the hotfix branch, used to fix any urgent issues with the main branch. So the hotfix branch will allow you to fix any issues without impacting or disturbing your ongoing development with your feature or release branch. And then there's the release branch, which is used to create a new production release. And once that's ready and tested, it's also merged back into the main branch. Now this slide is more of an exhaustive list of the Git commands. It's not all of the commands, but it's many of the commands, and I have broken them down into sections. So we've got the initialize and setup, and then commands for branching and merging, and then the staging area, remote repositories, view analysis, undo changes, and then tagging and stashing. So you can use these as a reference, and I will be using these as a reference as well when working in the live environment.
Welcome back to another video. In this video, I'm going to install and initialize Git on the Windows 11 operating system. Now, if you are installing Git on a Linux or a Mac operating system, you can install it using these commands here.
If you are installing it on a Mac, it's installed via Homebrew, and the command is brew install git. Otherwise, if it's Linux, it's installed via your package manager, and you can use the command sudo apt-get install git. But we are going to be doing it using Windows. And with Windows, we can use Google search. So let's search for Git. And the website we want is git-sem.com. And we've got download for Windows over here. And the one I want is the standalone installer. And I'm going to be using 64-Git for Windows setup. So that's going to download now on the right hand side. And now that it's downloaded, we can click it to install Git. And we can click on yes. Do you want to allow this app to make changes to your device? Now, the one thing we can do is if we open up the command prompt, we can check if Git's installed. So all we do is type Git, and if we press enter and it's not recognized, Git's not installed. Now, going back to the setup, we can press next for the licensing information. And next, it's where should Git be installed. Let's stick to the default, which is C program files Git. And this page shows us what components to install. So we can see there's a few components here, but we are going to stick to the defaults on here and click next. This time it's asking us where should setup place the program shortcuts, and we will stick to the default. So we'll create a folder called Git, and let's click on next. Now on this setup page, which editor would you like Git to use? And it always gives us some information here. So it's saying the Vim editor, while powerful, can be hard to use. But Vim is the default editor of Git for Windows, only for historical reasons, and it is highly recommended to switch to a modern GUI editor instead. Now, if we drop this down, we can choose the editor of our choice. And in here, we can see lots of popular editors. We can see Notepad++, Visual Studio, Sublime, Atom, and at the bottom, we also see Notepad and WordPad. And I'm going to choose Notepad for this. So let's click on Notepad and click Next. Now, what would you like Git to name the initial branch after git init? Git init is the git initialize command, which initializes a repository. And if we let Git decide, Git uses its default branch name, currently master, for the initial branch in newly created repositories. But we can override it, and I like to override this. So I like to refer this to main as the main branch rather than the master branch. And by the way, a branch allows you to work on features and bugs without impacting your main branch. So you create your main branch. This is our default branch. The main branch is where our main production code is. But then, for example, when we are working on specific features and bug fixes, we create different branches. So we are not impacting our main branch. So that's what this is for. And in this case, it's just asking us what we want to name our main branch. It can be called the master branch, but I prefer the name main. So let's leave it as main and let's click next. Now, adjusting your path environment. How would you like to use Git from the command line? So we can use Git from Git Bash only, which is good for Linux and Unix users. And then the next option is Git from the command line and also from third-party software. And this is the recommended option. So this option adds only some minimal Git wrappers to your path to avoid cluttering your environment with optional Unix tools. And then it says you will be able to use Git from Git Bash, the command prompt, and Windows PowerShell, as well as third-party software. And then the last option is use Git and optional Unix tools from the command prompt. So here it says both Git and optional Unix tools will be added to your path. So unless you need these two for specific reasons, stick to the recommended option here and click next. Now, which secure shell client program would you like Git to use? So you can use the default, which is use bundle open SSH. This uses ssh.exe that comes with Git. And then there's a new option, use external open SSH, and this uses an external sh.exe. And with this, Git will not install its open SSH binaries, but use them as found on the path. And you can read what it says here, but let's stick to the default, use bundled open SSH, and let's click next. Now, which SLTLS library would you like Git to use for HTTPS connections? So the default is use the OpenSL library. Server certificates will be validated using the ca-bundle.crt file. And then we also have the option use the native Windows secure channel library. So in here, server certificates will be validated using the Windows certificate store for when you have a company's internal root certificate that you want to use. And this option is good because it allows you to use your company's internal root certificates. For example, using Active Directory domain services. But we are going to use the top option, use the OpenSH library. Let's click next. Now for sure, this is the option to use for Windows. This is the recommended setting on Windows, but this is the recommended setting on Unix. And then there's the as is. So Git will not perform any conversion when checking out or committing text files. So by the way, it does say how should Git treat line endings in text files. And we will stick to the recommended one for Windows here. Let's click next. Terminal emulator do you want to use with your Git bash? And then again, we will stick to the default. Use min-tty, the default terminal for MSWise2. And as usual, it tells you more about it over here. Or we can use the Windows default console window. But just to bear in mind, it says it has very limited default scrollbacks. Needs to be configured to use a Unicode font in order to display non-ASCII characters correctly. So it's got some limitations. So let's stick to the top one and click next. Now this is about the default behavior of git pull. What should git pull do by default? We will stick to the default, which is fast forward or merge. So fast forward the current branch to the fetched branch when possible. Otherwise, create a merge commit. You can also choose rebase and rebase the current branch onto the fetched branch if there are no local commits to rebase. And rebase is the equivalent to a fast forward. So the first option. And then the last option is only ever fast forward. So this will fail if fast forward is not possible. Again, let's stick to the default, fast forward or merge. And now this setup page is about which credential helper should be configured. And this stores all of the credentials, including the credentials to connect to GitHub and other websites and other applications as well. So this uses Git Credential Manager and this does not. So let's stick to the default again. I'll click next. So here are some features we can use. Enable file system caching, and this is a good thing because it provides a significant performance boost. And then this is to do with symbolic links, enabling symbolic links. So you can do this if you wanted to, but we will leave it as disabled. Let's click next. Now it says here, these features are developed actively. Would you like to try them? So the first one is enable experimental support for pseudo consoles. And it tells you here this allows running native consoles, programs like Node or Python in a Git bash window without using Wimpy, but it's unfortunately not quite stable yet. And then this is enable experimental built-in file system monitor. So it can speed up common operations such as git status, git add and git commit that are inside work trees that contain many files. So this is a feature to speed things up. So that was quite a few options, but we have got there and we can click on install to install Git. So now Git has now installed, we can click on finish. Actually, we can click on launch Git bash as well and view the release notes. And let's click on finish. So it will open up Git bash. Let's open up the release notes. And in the release notes, we can see, we can have a look at the known issues. We can have a look at new features, including bug fixes. So that's in the release notes if you wanted to have a look at those. We are going to skip this and jump on to Git bash. Actually, before we use Git bash, let's go back to the command prompt and type git. Right, it's still not recognized it because we need to start the command prompt again and click on git. And now it's recognized git, and over here it says these are the common git commands used in various situations. So we can see some of the commands we can use. Start a working area, work on the current change or examine the history and state. Now actually, before we jump onto Git bash, if we have a look at the start menu, we see three options. So Git bash emulates a bash environment on Windows. It lets you use all of the Git features in the command line and also many of the standard Unix commands. So if you are a Unix user, you would use Git bash. Otherwise, for Windows, it's Git command line, which is the Git CMD. And this is basically using the Windows command prompt with the Git commands. So you can use all of the Git features through the command line. And again, it's useful if you work on Windows commands and you work on Windows. Now, finally, there's a Git GUI, and this has minimal features, but let's have a look at it. It's got create new repository, it's got clone existing repository, it's got open existing repository. If we have a look in here, it's got the same thing, new, clone and open. So the Git GUI is there to create, clone or open repositories without having to do anything with commands. So it's got minimal features, and that's why we are going to use Git Bash. Now, when you install Git, the first thing you need to do is set up a username and email address. And these are needed, both of these are associated with each commit. So every time we commit Git, these two pieces of information are associated with each commit. So the way we do that is git config -- global user.name, and then we specify our name inside speech marks and press enter. Now for user.email we could do the same thing, but it's user.email instead of user.name. And I'm going to use a fake email here, so this is not real, and let's press enter. Now if we use git config -- list, we can see all of the current configuration settings. So if you want to see what your current settings are, you run the git config -- list. So in here we can see things like user information, repository settings, color preferences, and right at the bottom here we can see my username and my email address we have just set up. The next thing we want to do is initialize a repository. So we can either clone an existing repository if we are working on an existing project, or we can create a brand new one, and we are going to create a brand new one. But the first thing I will do is create a directory. So if I do a pwd, just to understand where I am in terms of my working directory. Now let's use the mkdir command to create a new directory, and let's call it my git. So let's change directory to my git, and we could specify the full path and then my git, enter. And finally let's do a pwd to make sure we are in my git, which we are. So it shows my git over here. Now we can initialize Git inside the new folder, my Git, and we do this using the git init command, which initializes a new Git repository in the current directory. So it's done that instantly, and it's telling us initialized empty Git repository, and it tells us where it's initialized the empty Git repository. And if we see here, it's created a hidden directory called .git, named .git inside the current directory, and this Git directory contains all of the necessary files and subdirectories that Git needs to store repository, metadata and object databases. Maybe if we do a pwd here, sorry, not a pwd, a dir, and we see nothing actually because it's a hidden file. What we can do is open up the folder. Now if I go to this PC, C drive, users, jaff, and then my git, it should be in here, but it's a hidden file. So if we go to view, options, and then view, show hidden files and folders, apply, OK. There we are, so we do see it now. And here's all the hidden information in here. Now the next thing we can do, if we go back to Git Bash and we do a git status, this is a command we will use often. It's a very common command used with Git because you need to know the status of Git, the status of your repository. And what we can see here is on branch main. So we did call the default branch main, and we can see it says no commits yet. There's nothing to commit. Create copy files and use git add to track. So it's basically saying add some files in here first. So this provides a summary of the current state of the working directory and the staging area. It displays which changes have been staged, which haven't, and which files are not being tracked by Git. So using the git status helps developers understand what changes have been made to the working directory and what steps are needed to prepare these changes for a commit. And that brings us to the end of this video. So that's how we install Git on Windows 11 and how we initialize a new repository, and just have a look at the current state of the repository using the git status command. From the first part, we have now created a new repository called mygit, and now we are ready to add some files. But before we start tracking the files with Git, I want to go over the two-step process with Git and Git files. So when we commit Git changes, there is a two-step process in doing so. We first stage the files so that they are added to the staging area. And then second, we commit them to the repository, which in effect is a point-in-time snapshot. And staging enables us to stage changes we want to actually commit. Staging is especially important when you're working on multiple things on your code at the same time.
So for example, whilst you're working on the main code, you need to update a bug fix. So you stage the changes for the bug fix only, and then you commit the change for the bug fix with its own commit message, such as bug fix to resolve, let's say it's an authentication issue, so bug fix to resolve authentication. And then continue working on the rest of your project. So it gives you that flexibility to frequently update your changes in small increments and provide each of them with their own commit message. So this way you have an audit trail of what commits are for what changes, which is actually best practice. Staging the files so you can see it as getting the files ready for a commit also allows you to review the changes you're about to commit, and then you can choose which files are going to be committed and which files are not going to be committed. So for example, you might have a file of your notes, so you make notes of your different codes and your different files. Maybe that file you don't want to commit, so you don't go ahead with committing that particular file. Before we get into the command line, it's also useful at this point to know about the different states of a Git file. The first one is the modified state. So in this state, changes have been made to the file, but they have not been committed to the database yet. Then the next state is staged. We've just spoken about stage. In stage, you have marked a modified file in its current version to go into your next commit. So you have got the file ready to be committed, and this is the staged state. And then you have the committed state. So in this state, you can see it as the data is safely stored in your local database. So it's been committed. Or in other words, a snapshot has been taken of the Git repository. So in this state, you have a committed snapshot of your repository, which you can revert back to if you have any problems in the future. Now I wanted to share the different areas of Git. So in these states, what is occurring? So you have the working directory. So you make your changes to your files here, and these files are not yet tracked by Git. And then there's the staging area. So here you can add changes from the working directory to the staging area. And this process occurs when you use the command git add. We'll be doing this very shortly. The git add command also enables tracking of the files. And then there's the repository. So using the command git commit, all of the changes in the staging area are committed to the repository. This process is also flexible, so you can add changes from all files or selected files or changes from a specific file. Now the committed state you can also see as an unmodified state because everything has been updated. Git knows about the latest changes, and to think about it, when it's committed, it's kind of like an unmodified file or unmodified repository. So you can see it as unmodified as well, as Git has all of the changes. It knows about all of the latest changes. So I almost feel like adding the term unmodified in there after we do a commit as well. As Git is up to date with everything, it knows about everything. So you can see it as the unmodified state as well. We'll now add files, and theoretically we can add any file at all in here. So from Python files to HTML files to images or whatever you want. But I will add two simple text files. So you can do that from the command line. We can type touchmyfile.txt. We can also add another file in here as well, or if we press enter, I can add a file manually in here, but you can see myfile.txt has been added as we have just typed it into the git bash command line. But I can also do this manually as well from here as well, from Windows Explorer. So I can do another text file, and let's call this one myfile2. Now if we go back to git bash, a common command we will always use is git status to verify the status of the Git repository. And this is the status, so it's showing us we're on the branch main because I changed it to main when we first installed it. By default it's called master. There are no commits yet, but there is two untracked files. One we added from git bash and the other one we added from Windows Explorer. And it's saying nothing added to commit, but untracked files present. So it's telling us there are untracked files. We can also, by the way, do a dir from here as well. We can see them inside here because we are already in the mygit repository. So the dir and git status command will confirm the status of files. So the dir command will show us that the files are present if you're not using Windows Explorer. So it tells us the files are not yet being tracked. They need to be tracked so Git knows about these files and can monitor them. So let's go back to tracking these new files. And when we use git add, we can do git add followed by a space and a period to track all of the changes we have made. Or we can do git add followed by the file name to track individual files. But we are going to track all of the files. So git add space period and then press enter. And then we will do git status again to verify the status of the Git repository. And we can see it's changed from red to green, which means it has been staged and it's now tracking the files. Whereas previously it was red because it was modified, but it was not staged. Now we've got the files ready for a commit. They are staged in the staging area. And git commit is a git commit. It creates a point in time local snapshot of the project, which you can revert back to at any time. And to commit the change, it's git commit followed by an M for message. And the message is really important because you describe what exactly you are committing. So for me, it's adding my file and my file2 to my Git. So make sure you describe your commit message as clearly as possible so you recognize it in the future. Just in case you need to revert back to it, you know exactly what that commit was for, that point in time snapshot, the commit. So now if I press enter, and the one thing I missed there is the hyphen. So it's git commit hyphen M. So it's got to be a hyphen before the M. If I add that in there, press enter again, and we can see the status there. It says 2 files changed. So to confirm things as usual, we use the git status command. And now we can see we're at the committed state. So everything is up to date. Nothing to commit, working tree clean. So Git is telling us it knows about everything. Everything is clean, it's up to date. So next, if I remove and add some files in here, let's say we remove myfile.txt, and let's add index.xml and mypyfile.py and do a git add. Period. Maybe we should have done a git status before git add period just to have a look at the status, but we will do one now anyway. And they have gone green again because we just did a git add period and they're now tracked and staged. Now let's do a git commit -m, added and remove some files in here. Obviously you want to be more specific than that, and this will commit the new changes. And let's do a git status again just to confirm everything is up to date again, which it is. Nothing to commit, working tree clean. So that's how you make changes and use git add and git commit. Of course you can make changes within the file as well, and Git will track those. Let's do that now, but I'll also show you how to combine git add and git commit as one command. So now let's suppose I'm making a simple change to a file, my file2 in this case. So let me open that up and add the line new changes. Save it and close the file. And if I do a git status, we can see the file has been modified and it's showing in red. Now from here we would usually do a git add and then we can specify the file name, or a git add and period to add all the changes. And then as the second part we will do a git commit. But let's say we want to just make this simple change as we have done now and combine these two processes. So git add and git commit. And we can do that using an O flag followed by the file name like this. So we do git -m. Let's say we specify the message, made some changes to my file2, and then it's -o, and then it's the file name myfile2.txt. It's opened up the file for us too, but it has committed the file for us, and we can see it says made some changes to myfile2. One file changed, one file insertion. So let's do a git status to confirm everything is up to date, and we can see everything is up to date, nothing to commit, working tree clean. And that's it for this video. That's how you add changes to the staging area, and that's how you commit them. Now that we have done some git adds and git commits, and we have taken some snapshots of our projects. So that's the git commits. The git commits are the point in time snapshots. It would be useful to be able to see what we have done in case we do have to revert back to these commits, as after all, that is what Git is there for. And each snapshot or commit has an identifier, also known as a hash. We will have a look at this, and we will be able to see all our commits for a particular branch. Our default branch is called the main branch, as I changed it to the main branch, but by default when you first install it, it's called the master branch. I'm going to add some more changes to my file 2. Let's call it more changes. Save and close the file. Now let's do a git status, and it shows us my file 2 has been modified. So let's do a git add period, and git status again. This time it should convert into green, and we can see every time we do a git status, we can see we are on branch main, the main branch. And the next thing we want to do is a git commit. So we'll do a git commit -m and call the message some more changes. And let's press enter. And we see one file changed and 2 insertions, but the main bit I wanted to show is the identifier. So we've got the commit identifier here. It's got 7 characters, AEF3798. We need to know this because this identifies the commit, and also when we are reverting changes, we may want to revert to this commit. So we need the identifier. It's longer than this, so this is the 7 characters we can use, but the full identifier is much longer, which we will see next. So the main command we need to see all of our commits is git log. So this is the log of our commits. When we run git log, it will show us all of the commits, or in other words, point in time snapshots from the most recent at the top to the oldest at the bottom. So what we see here is our most recent change. So we can see the message, some more messages, some more changes, should I say. And then we have the date this commit was committed. And then when we first set up Git, I had to specify a name and an email address. So we can see that over here, the author, my name and email address. And I used a fake email address. That's not a real one. And then we have our identifier, the commit identifier. We can see it's much longer than the 7 characters, but we just need the 7 characters when we are reverting changes or we are checking out to that change. We can also see where the head is as well. So the head is in the main branch and it will be following the timeline of commits on this branch. So when we do our next commit, it will follow this timeline. So oldest to newest commit from bottom to top, and the next commit will be, of course, it will be over here and these will shift down, because that's where the next commit will be going. It will be following this timeline within the main branch. So I have about 4 commits, but let's say you had lots more commits. Let's say we had 100 commits. We can use another command, git log -- online, to streamline each commit so that we see more of them. We see more commits and each of them on a single line. It helps us see more of our commits if that's what we wanted to do. So we can see which one we wanted to revert back to. Spelling error, I missed the E. And let's press enter again. So here we are, we can see all of our commits. We can see them on a single line. So we can see the identifier followed by the message. This is why you need to ensure the message is very clear so you know what that commit was there for. Also, if you have too many commits and only wanted to see, let's say, the last 20, we can do that as well using the -n option. So that would be git log --one line -n, and let's do 2 to see our last 2 commits. And there we go, it shows us our last 2 commits. Of course, in a real world example, there may be hundreds of commits and you want to streamline these to the last 20 commits. Now, having a look at the documentation, so if we go to Git and have a look at git log, in here there are a lot more options to do the filtering. For example, if we hover down and we have a look at the options, we can see things like the log size, or something even more relevant, maybe the commit limiting features. For example, since date or after date. So show commits more recent than a specific date. Or you may want to do show commits older than a specific date. Or what would be really good is the author information. So you may want to see all the commits done by a particular developer. And you've got more advanced things as well, like the committer pattern. Limit the committer output to the ones with author. Committer headlines that match the specified pattern. So you've got lots of granular options in here for really narrowing down how to find the specific commit you are looking for. So I mean, the commits are endless, so you can look for commit formatting. So using pretty print the content of the commit logs in a given format. So there's so many options in here. So that's how you use a git log command to view your commits and to search for commits as well, using very specific filter options like the date and the author, etc. And in the next video, we'll have a look at how to go back to a specific commit using commands such as revert and reset and git checkout, etc. and the differences between each of them. Welcome back to another video. In the previous video, we had a look at the git log command to view the history of our commits. So all the point in time snapshots we've taken, which are the commits, we had a look at them through the git log command. Next, I want to talk about the git checkout command, because that's what we are going to use to revert back to these previous commits. So we can revert back to them to view our changes in those older commits. We use git checkout for a couple of things actually, and I'm going to go into more detail about this later on in the video, but we use it to switch branches, and the second thing is, as it says over here, to restore working tree file. So restoring the working tree file is going back in time to the previous commits, so reverting the state of the working directory to the previous commits. So in this video we're going to focus on the latter one, restore working tree file. So git checkout will revert your working directory to specific commits. Now if we have a look in the middle of the screen, there's a main branch timeline. So this is my branch, it's called the main branch, and this is my timeline of commits. And we have 4 commits here. In the middle of each box we can see the identifier of each commit using the first 7 digits, and the head is at the end, which is pointing to where the next commit will be. And as we can see, these commits are my actual commits, by the way, and I've taken a screenshot of the previous video of the command line console. We can see in black. And this is the Git log, and this shows us all of our commits. So I have 4 commits, and this is a timeline of our commits. And we can see the identifier of each commit as well, using the 7 digits. And the head is at the end, which is pointed to where the next commit will be. Now, when we do a git checkout, followed by the identifier, this will revert to that commit, but also detach the head. The head is detached. It's now in a detached head state. This means the head pointer is not pointing to a branch. So it's no longer pointing to our main branch. Instead, it's just pointing to a specific commit. Usually the head points to the latest commit on the branch we are working on. And when you make new commits, they are added to that branch. In our case, it's the main branch. So what we can see is if I do a git checkout and we use the 43D0070, the second commit in our timeline, which is on the left, is added and remove some files. This in effect takes you out of the main branch timeline. So in effect, it's being thrown off the main branch and it's not associated to any branch. And if we do a new commit, it will point to the end of this commit. So it's not associated to any branch. So why would we use git checkout and the implications of a detached head state? So git checkout is good for temporary experimental work. So you can experiment on previous commits. So you can make changes here and nothing will take effect, but bear in mind any commits you make whilst you're in a detached head state will not be associated to any branch, which in other words, they are known as orphaned commits. The commits can also be lost if you check out to another branch or you commit changes whilst in this detached head state. However, if you do like the changes you have made, there is a method to get this into a branch, which we'll have a look at. So we are now on git bash, and the first thing I'll do is check out my logs. So git log --, one line. And I'd like to go back to the very first commit I did. So this one here. Let's copy that one. The reason being is I added my file and my file 2 to my git. But if we recall, we did not have the index.xml file, or we did not have my pyfile.py. We just had my file 2 and my file. So if we go back to git bash and we do git checkout, and now if I paste in my identifier and press enter, note on the right hand side, and we can see that the files have disappeared and we only have my file and my file 2. So everything has gone back to the state of this commit. So whatever state the commit was in, we're in that state now. So my file 2, and if you have many other files in here, for example, all of the changes within the files will be at that particular state. We can also do a dir from here as well. It will show us my file and my file 2. And we can see it says git checkout and it gives us the identifier, and then it says no switching to, and then the identifier. But then it says you're in a detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch, retaining commits you create, so if we create commits here and we want to keep them, you may do so now or later by using the -c with the switch command, and then it gives us an example, git switch -c new branch name. Or you can undo this operation with git switch hyphen, and it shows us that the head is now at this identifier, added my file and my file 2 to my git. So this is almost the start of a new timeline. However, this is not attached to any branch. By the way, the git switch -c new branch name is a new way of doing it. We can also do it with a git checkout -b new branch name as well. And I'll describe the differences between the two at the end of the video. But we can still do a git status from here. And again, it says nothing to commit, working tree clean, and it tells us the head is detached. So instead, let's make a change to a file. Let's open up my file 2, test my changes in a detached head state. Let's save and close the file. And now we will do git status. So we have a modified file. We can do a git add myfile2.txt, enter. Now this will add it to the staging area. Finally, let's do a git commit -m, give it a message. Test some commits in a detached head state and press enter. So it's always reminding us we're in a detached head state, so it says it over here as well. And if we run a git log from here, and we can see we have 2 commits in here now. The first commit is the one that we reverted back to, and this is the new commit we've just done now. Again, this is a detached head state and it's not associated to a branch. This is not the way we do version control. Version control is associated to a branch of commits. This is for experimental use only. Actually, if we do a git log, let's do a git log without the ---- online. And usually in here we see the branch it's associated to, but we don't see anything. We just see the head. So now that we have played around with this commit in a detached head state, the way we revert back to a branch is with the command git checkout followed by the branch name, which is main in our case. And Git is quite good with information because it tells us, warning, you're leaving one commit behind, because we made a commit and it says not connected to any of your branches, and it gives us the commit identifier. This is the identifier up here, which my message was test some commits in a detached head state. And then it says if you want to keep it by creating a new branch, this may be a good time to do so. And then it gives us the command how to do that. So git branch and then new branch name followed by the identifier. Finally, it says switched to branch main. And we know we have switched to branch main because we can see on the right hand side, my index.xml file is back. And my file 2 should not have that comment I left inside it. So it's gone back to new changes and more changes. And it's removed the comment about the detached head state because I left a comment in there earlier. And of course, you can do a git log -- one line to verify I've got all my commits back, my 4 commits, which I have, and I can see we are in the main branch again as well. So this is one way of saving the changes to a new branch, but I've got another way as well. If we do a copy of that again, so if we copy it, let's go back into this detached head state. So git checkout, and then let's paste it in. Made a mistake, I used F instead of a G. So git checkout, and then let's paste in that identifier. I don't think I copied it the first time around. Let me do another one. Hopefully, third time lucky. Let me type it in instead. So we are checking out back to this commit in a detached head state. Now we can see on the right hand side we're back to my file and my file 2. Let me double click my file 2. So I have opened up my file 2 again. Test changes in a detached head state. Let's do a file and save here. So let's save the changes and let's do a git add myfile2.txt and let's do a git commit -m and leave a message testing changes in another detached head state. We can do a git log as well from here, git log -one line. So you can see the 2 commits, and the new commit is this identifier here with my message. So traditionally the way we used to do this is using git checkout -b and then the branch name, my_branch_2. But there was a lot of confusion with the git checkout command. So there is a new command as well, which is called the git switch -c command. So let's use the git switch -c command. And what this does is the git checkout -b command is effectively a shortcut for 2 separate commands. So it's a shortcut for git branch, which creates a new branch, and for git checkout followed by the branch name, which switches to the new branch. And the word checking out, by the way, means the head now points to this new branch. Or we can do this with a git switch -c command and a branch name. So git switch -c my_branch_2. And this will do the same thing. And I'm going to talk about the differences between git checkout and git switch next. So let's press enter here. Now it's telling us it's switched to a new branch my_branch_2 using the git switch -c command. And if we do a git log from here, we can see our 2 commits. So I added my file and my file 2 to my git. This was my very first commit. And then my second commit, which we did in a detached head state, is testing changes in another detached head state. And now it shows us the head is pointing here within my_branch_2. So that's how you retain changes in a detached head state and move them into a new branch. Next, I want to talk about the 2 commands, git switch versus git checkout. So the git switch -c followed by a new branch name for a new branch. That command combines the creation of a new branch and then switching to that branch in a single command, which is very similar to the git checkout -b new branch name command. And the reason for this is git switch is a newer command than git checkout. And due to git checkout being used for multiple things, it was a little bit confusing. For example, it's used for checking out to a specific commit, it's used to switch branches, and for file level operations, where git switch is used for one sole purpose, which is to switch branches. So that's its sole job, and because git switch has only one job, it's less error prone, as you don't accidentally check out commits or modify files. And that's it for this video. That's how you use the git checkout command to revert to previous commits. And that's how we exit the detached head state back into a branch, or we exit a detached head state and retain the changes, saving them to a new branch. Next, we will have a look at the git amend command. When we do a git -amend command, it will let you replace the previous commit. It combines the staged changes with the previous commit to a new commit, and you can only use it against the previous commit only, in other words, the last commit. So it is a nice, convenient way to modify the most recent commit. The key thing to take away here is that it replaces the previous commit, so the commit will no longer be part of the timeline, and this new commit will take its place. And here I have got some commits, so we've got commit 1, 2, 3 and 4, and let's say the last commit number 4, we made some mistakes, or we need to add some changes, or we need to update it with some changes. So we make some changes to it, and then we do a git add and git commit -amend. So we amend it, and the new commit is a brand new commit, so we can see it's 1, 2, 3 and 5. So 4 no longer exists. Commit 5 has replaced commit 4. Let's have a look in PyCharm how this works. So I'm back in PyCharm on my main branch. I've got my file open, my file 2, and I've got some changes in here. If we do a git log -one line from here, we can see our commits. And my most recent commit is this one here, AEF 3798, and it's called some more changes. So that's the message. Now let's say, for example, I missed something and it was in my file 2. So go to my file 2 and I add further changes, and we do file and save. And maybe we add my file 1 back in as well. So I missed adding another file as well, my file. So I made changes to my file 2 and I've added my file as well. So if we do a git status from here, we'll see there's a modified file and a new file that's untracked. So from here we can do a git add period to get these changes staged. Now that we have made these changes, let's say for example this last commit here, AEF 3798, some more changes. We want to replace this change rather than committing it to a new change. So the way we do that is git commit -amend and -m for message, and then I can specify the usual message in here, amended further changes and added my file. And maybe I can put in brackets amendment commit or something like that. And let's press enter. So we have made the change, and if I go back to git log -one line, what we can now see is the most recent commit has now been replaced. So this AEF 3798, it's been replaced by this commit here, A02C9E0. So this commit no longer exists, it's been replaced by this commit here. We can see the previous commits, they're all exactly the same, it's just the last commit has been replaced. So this is a good way of replacing the previous commit because you forgot something, for example, and you wanted to make some more changes, and replacing that commit with a new commit, rather than creating new commits. It may be a more streamlined way of managing your commits. And I guess this keeps your commits to a minimal. So rather than creating additional commits, you can just replace your last commit instead. I want to talk about another undo command, so to undo changes, and that's the git reset command. So the git reset command resets the head. It's used to move the current head and potentially branch pointer to a previous commit, which means it undoes changes made after that commit. And because you are modifying the commit history, it's safe to use with local changes, if you're sure you want to do this of course, but it can cause conflicts if shared with others. To be honest, all these undo commands, you have to use them with caution, because you are undoing something and you could potentially lose the work. So using the reset command, it's good for undoing recent commits that you don't want to keep or need anymore. So it may be good to use to clean up your history. So for example, you have too many commits and you are cleaning up your history. So if we have a look at an example, I've got 4 commits, 1, 2, 3 and 4. 4 is the head and the next head will be following on from 4. So let's put H in here for the time being. But let's say we wanted to repoint the head to a previous commit over here to commit number 2. And this means these two commits, number 3 and 4, are moved off the branch timeline, and any new commits will be created following this commit. And that's simply it. That's a git reset. So now we have moved the head over here to commit number 2. And this means the new timeline starts from commit number 2. And any new commits will follow this timeline. So the new one will be over here, and it will be 3. Well, maybe not 3 because 3 is the old commit. Maybe 3B for example. So they all have a commit identifier which is completely unique. So be cautious using it as you are moving the history And the tricky bit with git reset is, even though you're moving ahead to a previous commit, your working directory stays the same. So it will reflect the last commit. So when we reset to a previous commit and do a git status, we would see all of the changes that we need to add and commit that were part of the commit we have reset from. So for example, if we reverted from commit number 4 to commit number 2, then in the working directory, we would see all of the changes that need to be committed that were part of commit number 2 and commit number 3. So if you add and commit from commit number 2 without doing anything else, you would add a new commit which would have the same changes as commit number 4 again. By the way, there is 3 types of git resets as well. There's a soft reset, there's a mixed reset, and there's a hard reset. With the soft reset, it moves ahead to the specified commit but leaves the changes in the working directory and staging area. It's as if you had not committed those changes yet. And then the mixed reset, which is the default by the way, it moves ahead to the specified commit and unstages the changes but leaves the changes in the working directory. So the changes appear as uncommitted modification. And then there's the hard reset, which is the most sensitive one and you have to be cautious with it. So the hard reset moves ahead to the specified commit and all changes in the working directory and staging area are discarded. Obviously this is deleting files, so you have to use it with caution. So with the mixed one, because this is default, which moves the specified head to the commit and unstages the changes, but it leaves the changes in the working directory. So the changes appear untracked and uncommitted. And with that said, even though you move the header to a previous commit, your working directory stays the same. So if from that point we did a git add and a git commit, it will reflect the last commit again. Git reset is a nice method to clean up your commits when you have too many commits. We combined commit 3 and 4 into a single commit, but imagine you had 20 commits and the last 9 were all minor updates. So commit number 11 to commit 20 were all very small updates. So it would make sense to combine them all into a single commit before you share your work with other developers. That's one use case of using git reset. Now we are back on git bash. I want to have a look at the git log --1 line command. And this is where I can see all of my commits. So my latest commit is this one here, A02C9E0. Amended further changes and added my file. And I made a note to say this is an amendment commit. Now let's say for example these 2 commits here, I do not want them anymore. And I want to go back to 43D0070. So this one here. So if I copy the identifier and then we do a git reset and paste that in, I can press enter now. And again, the type of reset this is mixed reset. So this is the default where it moves ahead to the specified commit and unstages the changes. So that's why this change is unstaged. But it leaves the changes in the working directory. The changes appear as uncommitted modifications. So I can make some further changes in here. So if we recall as our last change previous to this change, the amendment change, we created this line here, further changes. So with git reset, it's repointed the head, but we still have all of the changes in the working directory. So we still have further changes. And I can make other changes as well in here and file and save. We can do a git status on here now. And now we can see my file 2 has been modified and it's untracked. So we can do a git add period. Now we can do a git commit -m and the new message will be new changes following a git reset. Let's press enter. Now if we do a git log --1 line, and we can see these 2 commits are exactly the same as these 2 over here, but these have gone. These 2 commits here, they have now gone. So my new timeline started with this commit here. This is the head. This was the head until we made our last change. So this is the latest commit we just did now. These commits have gone. Now with Git, it doesn't remove things permanently unless we forced it. There is a way to get these back, but they are off the branch timeline. There is a way to recover them from Git. Next, we will have a look at another undo command, git revert. Now we just had a look at git reset, which is a bit drastic of a thing to do because it removes history, especially the hard reset. So instead, if you use git revert, when you revert a commit, Git creates a new commit, and this new commit is the reverse of the reverted commit. In other words, imagine your last commit, you create some files with some code inside them, and let's say you wanted to remove these files, but not permanently in case you need them in the future again. So instead, if you use the git revert command, it will undo these changes and create a new commit, but the original commit will still be preserved. and in your timeline, so that you can go back to that commit just in case you needed those files with the content inside them again. And let's say we wanted to undo all of the changes that were made to commit number 4. So all of the changes to commit number 4, we wanted to undo them. So what we do is git revert on commit number 4, or you can also do git revert head, which is the same thing. It will revert commit number 4, and what will happen, it will create a new commit number 5, which is effectively a reverse of commit number 4. It's commit number 4 before all of the changes were committed to it. So it's undone all of the changes and it's created commit number 5 from it. But this does not remove any of the history, so we still have commit number 4. And by the way, with all of the changes we are undoing for commit number 4, it can be a copy of commit number 3. But we don't want to go back and reset to commit number 3 and lose the stuff we have of commit number 4. We rather preserve commit number 4 and create a new commit instead. So as we can see, git revert is a lot more safer than git reset because it preserves the history. It's a perfect method to use when reverting changes that have already been pushed to a remote repository. So when you are collaborating with other users, you don't want to reset back. That could cause conflicts, which could be very difficult to resolve. It's safer to revert the change instead when you're working in collaboration with other developers. So git revert is the safest method to use when you are comparing git reset to git revert. Now the last one we wanted to have a look at is the git revert. So again, if I make some changes here, save changes and have a look at our git status, I can see my file 2 has been modified. So let's do a git add and a git commit changes to my file 2. Now if we have a look at the logs, we see changes to my file 2 here. So that was this change over here. A new change. So we added this as the new change and we committed the change, which is this one over here. Let's say we wanted to revert that change, so we can do a git revert. I think the command is head, like this, if we press enter. And I have a message over here, hint, waiting for your editor to close the file. And it's opened up a file saying revert changes to my file 2, this revert commit, and it's given us the commit identifier. Please enter commit message of your changes. Lines starting with hash will be ignored and an empty message aborts the commit. So I'm going to type my reverted commit, Ctrl S to save this. Let's close the editor and let's see what that has done. If we do a git log again and have a look at the git log, and we can see our new committed identifier, and this is the head now, revert changes to my file 2, and we can see all of the older commits are still preserved, so we can see all of them over here and they're all over here as well. One last thing I forgot to do is have a look at my file 2 to confirm the change has been reverted, and in the previous commit we added a line called new changes which has vanished, so we can see it's undone the changes and created a new commit, so the git revert has worked perfectly fine. And that's it for this video. So we've had a look at a git reset and a git revert. Git revert is a lot more safer, so always try and use the git revert unless you wanted to remove some history, in which case you can use a git reset. In this video we will have a look at how to unstage a file in Git and ignore a file as well. So what if you did not want to include a certain file in your repository? For example, if we had notes that had been created to let the team know about weekly project updates or something similar, and then we accidentally staged these files. So how would we unstage a file and we keep files in our directory without them being tracked? So let's take a look at this. So the first step, I'll create a new file called my_notes, and in here I'll put some notes in my notes for my project. Let's save the file. Now a git status will show there's an untracked file. So if we do git status, so we can see my notes.txt is untracked. And now if we do a git add my notes.txt to add the file to our staging area, and let's say we accidentally added this file and did not want to really add it to our staging area, and now this file has become a staged file, which we can confirm with the git status command. And doing a git status, we can see the file is now in green, which means it's staged. And what we can see over here is it says use git restore to get the file unstaged. So git restore -- staged and then the file name to unstage the file. So we can do this, git restore -- staged, and then it's my_notes.txt. And now if we do a git status, we can see the file has been unstaged again.
However, we can easily accidentally re-add the above file again to the staging area. So how do we ask Git to ignore the file altogether? To ignore the files completely in the working directory. For example, it's a file for your notes, just like the file we have here, that you don't need to create commits for. For this, we can create a .ignore file in our repository and list our files we want to ignore in there, so these files will never be staged or committed. So let's create this .ignore file, and the way we will do that is do it through git bash touch.gitignore. Enter, and that's created the file on the right hand side. So if we go into the file, actually before we do anything, let's do a git status. So I can see both files. I can see my_notes.txt, but we can also see .ignore file in there as well now. And this is fine, as we want to track the .ignore file and let the team update and commit it when files need to be ignored. But the my_notes.txt is still showing. So let's update the .ignore file. And let's specify in here my_notes.txt, and let's save the file with a Control S, and I'll cross this off. And now let's do a git status again. And we can see the my_notes.txt has now disappeared. It's not being tracked anymore because now we are ignoring the file, and this is what you want Git to do, to ignore files. So we can do a git add from here and a git status, and we can commit this one, and running a git status again will show us now there's nothing to commit, working tree clean. And of course, if we remove the file from .gitignore, save the file, now we do a git status again, we can see the file is back. So we can see one file has been modified. We modified the .ignore file, and there's a new file which is untracked, my_notes.txt. And that's it for this video. That's how you unstage a file if you accidentally stage a file, and that's how you ignore files if you want Git to ignore files permanently. Git is a powerful tool, especially when you are collaborating with others. So this is when you are all working on the same project and need to keep it up to date when you are all updating the same content. With Git, with collaboration, each user has a copy of their own repository and they all have their own timeline of snapshots. Then with Git, we usually have a master repository that everyone pushes and pulls changes to and from, and so you want this master repository to be available from anywhere in the world, and this is why it's hosted on a cloud-based platform like GitHub, GitLab or Bitbucket. We will be using GitHub. We will be having a look at GitHub, and GitHub is a free and open source cloud-based service which is used for this very purpose. The first thing we will do is have a look at GitHub. What is GitHub? GitHub provides a platform for developers to host, manage and collaborate on code repositories. Git is a free and open source version control software that tracks changes to your source code. GitHub allows for real-time collaboration and is accessible from anywhere in the world, which enables teams to work together effectively. Using GitHub is optional if you only need to track your code locally, such as hosting repositories within your company's network over a VPN connection. Then it's not needed. You do not need anything in the cloud. Then it's not required. So GitHub is not mandatory for Git, but Git is mandatory for GitHub. You need Git to use GitHub. You do not need GitHub to use Git. And GitHub offers both free and paid plans, including free, pro and enterprise options. The free plan includes the basics such as unlimited public and private repositories with 500 megabytes package storage and 2000 automation minutes. The team plan offers advanced collaboration features with 2 gigabytes of storage, where enterprise plan includes all features of the free and team plans, along with enhanced security, compliance, flexibility deployment, and its 50 gig of storage. The platform supports both public and private repositories and was acquired by Microsoft in 2018, which increased Microsoft's focus and commitment to open source development. And additionally, GitHub includes features like continuous integration and deployment, as well as various collaboration tools. So that's a high-level overview of what GitHub is. Let's go ahead and create a GitHub account, and once we create a GitHub account, let's go ahead with creating a new repository and connecting this new repository in the cloud back to my local Git environment on my local machine. The very first step is to create an account on GitHub. For this, we'll go to github.com, and before I sign up, if I hover down, GitHub shows some of the latest and greatest features that comes with the service, so you can read more about those.
Now I will click on the sign up button on the top right of the screen. Next, we specify our email address and create a password, and enter a username for your GitHub account and click continue. After this, we verify the account and confirm the code they sent to your email address. And now you are done with this part and you can sign in. Now, upon signing in, you will get asked some questions. You can skip it. This part is to set up your environment with the correct level of services that you want to use. I think it's basically to upsell their other services or their other pricing models. They offer the three models: free, team and enterprise. Anyway, regardless, we are going to stick with the free one, but I'll go through this anyway. So it asks, how would you describe yourself? So I'm going to select student here just to see what options we get with student. It does, by the way, ask you to apply for the student services. To get the student services, we will see this in the next couple of screens. So let's go with student for now, but ultimately I'm going to go with the free option. How many team members will be working with you? Let's go with 2 to 5. And we can see here what specific features are you interested in using. I assume if you select any of these, it will try and upgrade you. It will try and ask you to upgrade to another pricing model. We will have a look at the pricing models as well. And here's an image of the pricing model. So you get these three pricing models: free, team and enterprise. Now if we click continue, next it shows us our free options, and because we did not select any of the other features in the previous window, it shows us only the free options and the get additional student benefits options. But we would have to apply for this. I guess we would have to show that we are a student. But I'm going to select the continue for free option. And that's it as far as initially setting up the account. And now it's landed us on the GitHub dashboard. So I'm logged into my GitHub environment and we are on the dashboard. So this is the GitHub dashboard. We can see it gives us some suggestions like explore other people's repositories or start a new repository. And we can specify the repository name and whether we want this repository to be public or private, and create a new repository right from here. And introduce yourself with a profile readme so everyone knows what my page is about. And then we've got some useful tools. By the way, that's start writing your code. Then we've got some useful tools of the trade. And we'll be having a look at this actually. Install GitHub Desktop, maybe in the next video. Then there's some AI-based code suggestions. Try GitHub Copilot for 30 days and so on. So this is the dashboard. Of course, at the bottom it's showing trending repositories as well. But on the left hand side, we've also got create your first project. So we can do this, or we can import a repository as well, but we will create a repository. So here is where we create our new repository. The first thing I'll do is give it a repository name. It could be a name of your project. I'm going to be very generic and call it my first project, but of course you can be very specific. So if it's a particular game you're building, a particular website, etc., you want to label it correctly, and then you want to give it a nice, precise and memorable description. And then you can choose whether you want this to be public or private. Again, public is anyone on the internet can see the repository, but you can choose who can commit to your repository. So although they can view it and pull from it, they cannot commit to it. But then you've got private as well, and private you can choose who can see and commit to this repository, but we will stick with public. So by creating a public repository, anyone on the internet can see that repository. However, you can control who can commit and make changes to that repository. But by creating a private repository, you have complete control over who can see and make changes to that repository. Then we have three more things. We've got the README file. With the README file, you can write down what your project is about and provide any instructions. So let's tick it anyway. Then with the .gitignore file, this will contain the names of the files you do not want to push to GitHub. So with Git, we track changes to files. And by using the .gitignore file, we can specify files. In here, we ask Git to ignore. And Git will no longer track changes to those files. These could be operating system dependent files, or just notes you don't want Git to track. Or they can be settings specific to your IDE, or files specific to a version. They can even be system generated log files that just take up too much space and you do not want to track them. Things like that. So I'm going to use Terraform soon, so I can ask Git to ignore all my Terraform related files. Of course, we can click on these to learn more about each of these as well. Next, we need to specify a license. A license tells others what they can and cannot do with your code. But there is quite a few options with licenses. If we have a look in here, So this is for the GitHub repository we're creating. It can be licensed under a variety of open source licenses, and a license tells others what they can and cannot do with your code. But we have quite a few choices, so we can go through them. And the top one is the Apache License 2.0. With this license, users must maintain original copyright notice and include any changes in the software, and it's suitable for projects that might involve patents or where you want to prevent patent trolls. It's common in enterprise environments, software frameworks, and large projects like Apache projects. Then the General Public License, GPL, is best for projects where you want to ensure that all derivative works remain open source. It's widely used in the GNU or Linux ecosystem and other projects where open source principles are paramount. Then we have the MIT license, which is a very common license. A lot of people use this, and this is because it's a very permissive license that allows for almost complete unrestricted access of use. So users can pretty much do anything with it, including selling copies of the software, as long as the original copyright and license notice are included in all copies of substantial portions of the software. So the license is ideal for projects where you want to maximize freedom for users, including commercial use, and often used in web development, libraries, and open source projects where the creator wants widespread adoption. Then there's the BSD2 and BSD3 licenses. These are similar to the MIT license. The BSD licenses are permissive and allow for almost unrestricted freedom. The 2 includes basic permissions, while the 3 clause adds a no endorsement clause. These are good for projects where you want a permissive license with a bit more control over endorsements. They are often used in academic and government projects. A lot of these licenses are very niche and specific to things. The Creative Commons licenses, and these are a range of licenses mainly used for creative work rather than software. And they are best for documentation, images, media, or other creative content within a project. So it's not recommended for software code. The Eclipse Public License, this is a copyleft license similar to the LGPL, but with different patent and compatibility provisions. And this license is suited for enterprise-grade projects, especially in the context of software that could potentially be integrated with other proprietary software. The AGPL Affero General Public License, this is a version of the GPL designed for software that is used over a network, and it's best used for web-based applications where you want to ensure that the code remains open even if it's used on a server-side context. The Mozilla Public License, this is ideal for projects where you want to enforce open source on a file-by-file basis, but allows for integration with proprietary systems, and it's commonly used in projects like Mozilla Firefox. Now at the very bottom we've got the unlicensed, and this places the work in the public domain, allowing anyone to do anything with the project without any restrictions or conditions. So it's useful when you want to completely relinquish all rights and allow other users to use your work without any conditions at all. It's not very common you would use this, but it is sometimes used for small scripts or snippets where the authors want to avoid any restrictions. So to choose the right license for maximum freedom of permissive use, you could use the MIT license, Apache 2.0, or the BSD license. These are ideal licenses for maximum freedom of use. For ensuring open source continuity, we would use GPL, LGPL, or AGPL. For a balanced approach, you could use MPL or EPL. For documentation or creative content, you should use the Creative Commons licenses. And for total public domain dedication, so it's completely unrestricted, you would use the unlicensed license. So for most people, they use the maximum freedom, which is MIT or the BSD license, I suppose. So if we hover to the top, so I'm going to go with MIT license here. And then at the bottom it says this will set main as the default branch. Change the default name in your settings. So we could do this, but I like to use the default branch name as main, as I have done in my Git environment as well. It's called main. My default branch is called main. And finally, we can create the repository. So this is it. This is my first repository, my first project. It's called my first project, and I have my 3 files in here, my .ignore file, my license, and my readme file. And so this is information about my license. It tells me the permissions, the limitations, and the conditions for the MIT license. Got my .ignore file here, and we can see it says local.terraform directory. So it's got all Terraform related things in here. TF state files, crash log files. exclude all TFVAR files, which are likely to contain sensitive data. So these are templates. You can use templates, but you don't have to use these. I chose the Terraform template, but we could start from scratch with nothing in here, and you just specify your files in here. And on the right hand side, you can download your files from here, or copy the raw file, or edit this file as well. If I click on edit, I can remove all this information if I like, start from scratch, and specify a file in here like myfile4.txt, and we can commit changes on the right hand side over here, commit directly to the main branch, add a description, ignore myfile4.txt, commit change. Let's hover over to the readme file, and I can edit this as well, put some description in here. This is my first project. I'll leave this as it is and cancel changes from here. So this is all done. And on the left here, we can see our files, but we can also see the branch we are in. So I'm in the main branch. I do not have any other branches created just yet. And we can click on the plus sign as well here, and name our file and put some content within our file, and then we can commit changes. Commit directly to main branch, commit changes. So now we can see myfile5.txt in there. If we click on the GitHub icon, we can go back to the dashboard, and at the bottom here I can see my first project. If I go back in here, that's how we open up the project again from the dashboard. But on the right hand side here, I've got code, and in here I can copy my URL. So I can copy it from here. But we've also got other methods as well. I can copy this, but we can do it via SSH or GitHub CLI as well. We can also download it as a zip file as well. And downloading it as a zip file is exactly the same as a git clone. So you can do that with no issues. So you don't have to use git clone command. This is a perfectly alternative way of doing it. Now to copy all my content, to clone all my content into my local repository on my local machine. So this is GitHub, my remote repository, and we are going to clone the content to my local repository on my local machine. So I have already copied the URL. I'll copy it again just to make sure. It's now copied to my clipboard. Again, I can do a download zip from here. I can also use other alternative protocols to do this with, maybe for security or compliance purposes. You can also open with GitHub Desktop. If you do this, it would open up the URL and everything for you on your GitHub Desktop on your local machine, and then you can just clone it with a click of a button. But we do not have GitHub Desktop installed yet. I will cover this off in another video, but for now we have cloned it, and now I can go to my local machine on my Git bash over here, and we can use the git clone command from here. Let's begin with doing a pwd to work out which directory we're in, and then do a dir. I've got a directory called my git project. So if we go into my git projects, we're in the directory I want to be in, and this is where we are going to create our new repository. So again, if I go to code and I copy the URL, we can see it's github.com, followed by my name, followed by my project name, my first project. Now we can do a git clone from here and press enter, and that's done. So if I do a dir now, sorry, I have to go into my first project, but I'll just open up my folder instead. I've got my git projects in here. If I go into here, I've got my first project in here. Now if I double click my first project, we can see the files in here. So you can see the .ignore file, the license file. We can see the new file we created, my file 5, and the readme file as well. If I open up my file 5, I can see the same content in here as we had in the cloud. So that's how you clone a remote repository rather than starting from scratch. This is the alternative to using git init. So rather than using git init, starting a new project, you can clone an existing project for developers who want to work on existing projects. So that's how you use the git clone command to clone an existing repository in GitHub. Welcome back to another video. In this video, we're going to have a look at virtual environment for Python. Virtual env, virtual environment, will allow you to create virtualized and isolated environments for Python. And a virtual env in Python is a self-contained directory that includes a Python interpreter and isolated libraries and dependencies. Essentially, it's a sandboxed environment that allows developers to run projects independently from the system-wide Python installation or other projects. And one of the main reasons you need a virtual environment is when you have two projects that rely on different versions of the same library. So projects often have different and potentially conflicting dependencies. For example, one project might need Django 3.3 while another project needs a different version of Django, let's say 3.0. And virtual environments allow developers to replicate an exact setup. So developers can work on multiple projects simultaneously, each with unique requirements. Virtual environments make it simple to switch between the different projects without worrying about conflicting packages or configurations. So when you're starting a new project, you may as well create a dedicated virtual environment for it as well. This way you're not going to run into dependency errors and conflicts of writing to the same directories and things like that. So virtual environments let you have a stable, reproducible and portable environment. So basically you are in control of which packages, versions are installed and when they are upgraded. And by the way, Python version 3.3 and above comes with virtual env by default. However, if you do need to install it, you can run the pip install virtual env command from the terminal and it will install it for you. Let's have a look at virtual environment. Now we will have a look at these virtual environments. I have 3 different versions of Python installed and I also have PyCharm installed. And within PyCharm we can go ahead and click on new project. So I can name my project and give it a location. I can even create a Git repository and create a welcome script. It's just a basic script you get familiar with Python. And then here is my interpreter type. So these are my environments. We can use the default project virtual environment. And there's also others as well. We've got base, conda, and then there's custom environment. Actually, I've got select existing here. If I click on generate new, which is the default, we can specify the type of environment here. So there's virtual environment, which we will be having a look at. But there is conda as well, which is another popular one. And there's pip environment and poetry. So we will stick with virtual environment. And then we've got Python here. We can specify our Python version. I'm going to go with, let's say, version 3.12, but you can also install them directly from here if there was a particular Python version you needed for this virtual environment. So let's go with 3.12. The inherit packages from base interpreter. This gives your virtual environment access to the global site packages. So it's for packages you have already installed on your physical host. So this way we are using the packages installed on our physical host. So let's click create to create this virtual environment. So it has now done that. We can see the virtual environment here and the associated folders and libraries. But what we can do is go to file, settings, and then project. And the project name for us was Python project. I could have changed this to another name, of course, but we left it at the default. And then there's the Python interpreter here. So this is where you can confirm the Python interpreter. So we can choose or add interpreters from here, add a local interpreter, and we can see our location and the base interpreter. So this is the base interpreter. So we can change things around if required. But I'm going to cancel out of here. I'm happy with the changes. I'm happy with the settings. And if we go to the terminal, here are some commands with virtual environment. So this is not specific to PyCharm. These are commands you can use in any environment associated with the virtual environment application. So the first command is pip list. Now to list the packages installed in the virtual environment, we use the pip list command. And by default, this will only have pip installed. We can see pip is installed, 23.2.1. But if we install a particular version of NumPy, 1.26.3, let's say, for example, we needed this particular version for this environment. So we go ahead and install it. And we can install anything else as well. Let's go ahead and install another popular library called pandas. So that's done. We can do a pip list again. And now we can see a lot more packages have been installed. We can see NumPy, pandas, etc. down here. And we can see it's telling us a new release of pip is available. So we could go ahead and run this command to install that as well. But going back to PyCharm specific, we can also go to file, settings again, project Python interpreter, and we can install the libraries and packages from here as well, simply by clicking the plus package here. And because I'm doing this on a virtual machine, it's quite slow, so it's not populating, but usually it would populate with packages. Actually, the packages have appeared. So, I mean, there's so many packages, that's why it gives you the ability to search as well. You can click on any of these. It usually shows a description, a lot more information. It looks like it's struggling to pull that down. And you can specify a specific version as well. So there's many packages to choose from. And we install the package by just clicking the install package icon over here. Let's click close and cancel. And by the way, to verify you're in the virtual environment, we can see the virtual environment label on the left hand side here. And there's two of the common commands. One is to come out of the virtual environment and the other one is to go into the virtual environment. So to come out of it, it's deactivate. And this is what happens when you spell the command incorrectly. So I've deactivated now, and we can see it's deactivated because we was in the virtual environment, but now we are out of it. Actually, we can do a pip list here to see what's installed on the physical host. We're not in the virtual environment, we're on the physical host now, so we can see only pip and setup tools is installed. Where in the virtual environment there was only pip installed, and then we installed some more libraries. And to go back into the virtual environment, we specify activate. Actually, I've missed a few bits, not activate on its own, but we need the name to the virtual environment, followed by scripts, and then followed by activate. So we are back in the virtual environment again, we can see on the left hand side. And we would follow this process if we had more virtual environments. We would specify the virtual environment name, followed by scripts, followed by activate to go into another virtual environment. Or to create a new virtual environment, we can go to the bottom right hand side as well, add new interpreter. Add local interpreter. Now this is where we was near the beginning as well. Now let's create a new virtual environment. New. Let's give it another location. Let's call it VN2. So this is virtual environment 2. Maybe for this one we are dependent on the Python interpreter 3.13. So let's click on OK and we will create this new virtual environment. So now that we've added a second environment, let's jump out of the first environment by using the deactivate command. And then let's copy this, paste it in, location, and we called it VN2 for virtual environment 2. Let's click OK on that. And now we can see on the left hand side, we're in virtual environment 2. So what we can do here is a pip list. And we can see it's only got pip installed again because it's a new virtual environment. And by the way, we can see it over here as well. So we've got our first virtual environment here, and then VNV2 for our second virtual environment. But let's say, for example, for this particular environment, we wanted the latest version, the latest and stable version of NumPy. So we went ahead and installed NumPy, and it's installing its collected packages. And while it's downloading, this is the whole point of NumPy. So we've got 2.1.3 downloading, which means this specific environment has its own version, has its own dependent version of NumPy. So this environment may be dependent on this particular version of NumPy. And if we do a pip list again, it will confirm the libraries installed for this particular environment, which is NumPy version 2.1.3. And by the way, you can pick your specific interpreter from the bottom right. It looks like I picked the same Python version for both of these projects, version 3.13. Let me choose a new one with version 3.12. I'm going to create a new one. I'm going to choose a new one for version 3.12. So I will choose Python 3.12 as the base interpreter, and I will create a virtual environment 3, venv3. Now I can click on OK to create it. And of course I can create many other environments as well. So the environments are unlimited actually, but you can create as many environments as you need. Notice it has populated the packages with the one package. I'll click OK and let it finish things off in the background. Now I have it as an option on the right hand side. We can change our interpreter by choosing it from the bottom right. So now that we have these two virtual environments with the different versions of NumPy installed, we can take a look at the versions of NumPy just to see the differences. So this one in Venv2 is using 2.1.3. And if we deactivate from virtual environment 2, actually we don't need to go into the other environments. We have the history here. I can scroll up and check the history because I just want to see the version of NumPy installed. So you can see in virtual environment 1 we have NumPy 1.26.3 installed because it may be dependent on that particular version. And for virtual environment 2, we have numpy.2.1.3 installed because this one is dependent on this particular version of NumPy. And one more thing I forgot to show, if you wanted to delete the virtual environment, you can just right click the virtual environment folder, the root folder, and click on delete. Or you could even copy the path, the absolute path, and down here if we specify rm for remove and then paste in the path, the items has children and recursive parameters was not specified. Alright, so it wants you to delete them recursively and we did not specify that in the command. So if you continue, all children will be removed with the items. Are you sure you want to continue? And you can use Y for yes or an A for yes to all. So I guess that's removed the virtual environment. Now that I have given it a refresh, virtual environment 1 has been removed. And that's it. That's a high level overview of virtual environments. It's absolutely essential. We use them at every opportunity to make sure we isolate and contain our environments. In this video, we're going to have a look at Python for AI. So how is Python used to build AI applications? To begin with, why is Python the main programming language for AI? And the first one is for simplicity and readability. So Python's syntax is beginner friendly. It's easy to understand, making it ideal for prototyping AI models. Then it's the vast ecosystem, so a huge array of libraries and frameworks tailored for AI and machine learning. And the third one is the community support Python has. So it has a massive active community that provides tutorials, resources, and solutions to almost any problem. And last but not least, it's cross-platform compatibility. So Python works across different platforms, Windows, macOS, and Linux operating systems. Now let's have a look at what is AI. The term AI can mean different things to different people, but the best way to look at it, at least in my view, first, it's a larger umbrella-like term which has different capabilities that make up the term AI. And second, the purpose of AI is to artificially match the task of a human being, or even exceed it in some ways, as it's much faster than a human will ever be at making decisions. That has been trained on a huge amount of data. So whatever capabilities a human being has, let's get AI to do the same thing. So one of the main things AI does is information discovery and processing, so searching, reading and analyzing data, understanding and recognizing patterns, identifying faces, objects or speech, predictive analytics and decision making, so making informed decisions based on data. Next is visual and audio processing, so face recognition, speech recognition and natural language understanding. And automation and robotics, enabling machines to perform physical tasks such as warehouse picking and autonomous movement. Now this is the bulk of the rest of the video, how Python enables AI tools. And first, there are three high-level areas of how AI is used or developed. And the first area is standalone AI applications. These are AI power tools designed to function independently, such as ChatGPT or Runway ML, that provides conversational AI capabilities. And Runway ML is an example of a standalone AI tool which offers video editing, text to image generation, etc. And there are other Runway ML alternatives like Midjourney and Kling. And second are tools with integrated AI features, which means built-in AI enhancements within a software solution. So these are broader platforms or products that incorporate AI capabilities to enhance user experience. For example, Microsoft Word Editor, which has an AI-powered grammar, style and clarity suggestion tool. And then there's Adobe Photoshop as well, which has an AI tool for editing and creating images, like features such as background removal or content-aware fill. And the third area is a custom AI solution. So this is an application that has been specifically made to solve a problem. For example, in healthcare diagnosis systems, AI tools built for hospitals to predict diseases or recommend treatments based on patient data. Or fraud detection systems, so custom AI models designed for banks to detect fraudulent transactions in real time. And a third example is predictive maintenance for manufacturing, where AI analyzes equipment data to predict and prevent machine failures. Next, we'll have a look at how Python builds AI tools. So I've got some examples here. So they provide pre-built functions, libraries like TensorFlow and PyTorch to simplify mathematical operations required for AI. The next example is Python integration with other tools. So Python can integrate with C++ or CUDA for performance optimization. And next, API and deployment. So Python frameworks like Flask and Fast API allow deployment of AI models as web services. And finally, cloud platforms. So Python libraries support integration with Google Cloud AI, AWS SageMaker and Azure ML for large-scale training. Next, let's have a look at the many AI terms and examples of how Python and Python libraries are used to help in these many different AI areas. The first terminology is machine learning. And with machine learning, it enables systems to learn and improve from experience without being explicitly programmed. For example, credit card fraud detection, where machine learning models analyze transactions patterns to flag suspicious activities in real time. And here are some Python core machine learning libraries. The first one is scikit-learn, which is an open source machine learning library for Python for beginners, and it's focused on traditional machine learning algorithms, for example, regression, classification, and clustering. And it's really good for beginners because of its simplicity and extensive documentation. The next example is TensorFlow, which is a software library for machine learning and artificial intelligence. Its main use case is training and interference of neural networks. We will have a look at what neural networks is shortly as well. TensorFlow has been developed by Google and is highly scalable for deep learning. It supports GPU acceleration and production level deployment. And the next example with machine learning is PyTorch. And PyTorch is a machine learning library used for applications such as computer vision and natural language processing. It's been developed by Facebook and excels in dynamic computational graphs. And it's preferred for research due to its flexibility. And PyTorch is a machine learning library used for applications such as computer vision and natural language processing. The next term we will have a look at is deep learning. So deep learning is a type of machine learning involving neural networks with multiple layers, deep neural networks, designed to mimic the human brain's function. For example, autonomous vehicles like Tesla use deep learning for visual object recognition to detect traffic lights, pedestrians, and other vehicles. And some examples of the Python deep learning libraries. Again, TensorFlow. So TensorFlow is a versatile library for building and deploying neural networks, which has been developed by Google. And PyTorch again, which we had a look at in the last slide for machine learning. But PyTorch is used in deep learning as well, and it's preferred for research and experimentation, known for its dynamic computation graphs. And there are always more examples of how Python helps in these different areas of AI. For example, there are other libraries such as Keras, MXNet, Theano, CNTK and JAX. But we are looking at the most common examples. Then there's natural language processing, NLP. And NLP is a branch of AI focused on the interactions between computers and human language, enabling machines to understand, interpret, and respond to human language. For example, language translations like Google Translate convert text or speech into different languages with high accuracy. So this is one area where NLP is used in, Google Translate. And the natural language processing tools are NLTK, Natural Language Toolkit, and Transformers by Hugging Face. So looking at NLTK, so this is for NLP tasks like tokenization, stemming, and sentiment analysis. And there's also SparSci Industrial, which is an NLP library optimized for performance and scalability. And the last one, Transformers by Hugging Face, which is pre-trained models for state-of-the-art NLP, for example, BERT and GPT. The next terminology in AI is computer vision. Computer vision is a field of AI enabling machines to interpret and process visual data from the world around them. For example, face recognition technologies we get with smartphones for unlocking our phones. And here are some of the Python computer vision tools. The first example is OpenCV. OpenCV, which also stands for Open Source Computer Vision Library, is a library of programming functions and it's widely used for image and video processing and computer vision tasks. Again, PyTorch Vision or TensorFlow's Keras application. PyTorch again is a machine learning library used for applications such as computer vision and natural language processing, and is again popular for research and development in computer vision tasks. But then there's TensorFlow Keras application, which is a high-level API for building deep learning models. It can be used with TensorFlow or computer vision tasks, and it has pre-trained models for image classification and object detection. Now let's have a look at some other AI terms. Reinforcement learning. So this is training agents to make sequences of decisions by interacting with an environment to maximize cumulative rewards. The agent learns optimal behaviors by trial and error, improving through feedback from actions. And the use cases include autonomous vehicle navigation roads, robotic for control and manipulation tasks, game AI, for example, AlphaGo learning strategies to win board games. Now looking at the Python tools, Stable Baseline 3 is an example, which is a high-level library for developing reinforcement learning algorithms. Then there's OpenAI Gym, which is a toolkit for creating and testing reinforcement learning environments. And then there's RLlib, a scalable reinforcement learning library in Ray. Next is PyBullet, which is simulations for reinforcement learning in robotics. And moving on to the next term, which is neural networks. Neural networks are computational systems inspired by the human brain, capable of learning patterns and relationships in data. They excel in tasks that involve large data sets, like images, text, or audio, to identify patterns and make predictions. And use cases include image and speech recognition, medical diagnosis, for example, identifying diseases from scans, or language translation and NLP tasks. And the Python tools used for neural networks is as follows. TensorFlow, which is an example we've used a few times, which is a comprehensive machine learning framework. Another common one, which is PyTorch, which is a flexible framework for building deep learning models. Keras, high-level API for TensorFlow. ONNX for exporting and importing neural network models across frameworks. The next AI term is generative AI. And generative AI creates new content, for example, text, images, audio, or video, based on the learned patterns in existing data. And it uses certain models or transformers to synthesize realistic outputs. Use cases include text generation, the famous GPT models for essays, stories, etc. Image creation, so generating photorealistic images or art. And music generation or voice synthesis. And some of the Python tools used in generative AI include Hugging Face transformers, pre-trained models for text, images, and audio, GANs in PyTorch or TensorFlow. It uses models like GANs or VAEs or transformers to synthesize realistic outputs. DALL-E and Stable Diffusion for generating images from text prompts. And the last example on Python tools is Deep Speech, which is open source speech to text engines. The next term is ethical AI, and this is the development and deployment of AI in a way that is fair, transparent, and free from biases. For example, AI-based recruitment platforms ensuring diverse hiring practices by eliminating biases in candidates for shortlisting. And use cases include fair hiring systems, so unbiased screening of resumes, transparent decision-making in finance or healthcare, and preventing algorithmic discrimination. And Python tool examples used in ethical AI applications is Fairlearn, which is a tool for assessing and mitigating fairness issues. AIF 360 or AI Fairness 360, which is a toolkit for bias detection and mitigation. Explainable AI, XAI, which are libraries like SHAP and Lime for model interpretability. Privacy Preserving AI, which is federated learning tools like PySci-FT. The next term is predictive analytics. Predictive analytics uses historical data, statistics, and machine learning to predict future outcomes. It is data-driven and focused on forecasting trends and behaviors. So use cases include sales and demand forecasting, customer churn prediction in businesses, risk assessment in finance, and predicting equipment failures in manufacturing.
And the Python tools used with predictive analytics include scikit-learn for classic machine learning algorithms for predictions, Profit, which is time series forecasting by Facebook or Meta, stats models for statistical modeling and forecasting, XGBoot or Light GBM, and this is for boosting libraries for prediction tasks. And the next one is robotics. Robotics integrates AI to develop machines capable of performing tasks that typically require human intelligence. AI in robotics enhances perception, decision making, and control. And use cases in robotics include autonomous drones and self-driving cars, industrial robots for assembly lines, and service robots, for example in healthcare or retail. And Python tools used for building robotic services include Robot Operating System. This is a framework for developing robotic systems, often interfaced with Python. PyBullet, which is a robotics simulation tool. Gym Robotics, a part of OpenAI Gym, focused on robotic reinforcement learning tasks. And the next one is chatbots. With chatbots, these are conversational AI systems that simulate human-like interaction via text or speech. They aim to assist, inform, or automate repetitive communication tasks. Use cases include customer service automation, virtual assistants, or education, such as tutoring bots. And the Python tools used to enable chatbots are Rasa, which is a framework for building conversational AI, Dialogflow, Google's natural language understanding platform, Chatterbox, which is a library for creating simple rule-based chatbots, and Transformers, which are pre-trained NLP models for conversational agents. And the last term we will have a look at is sound, audio, noise. So AI for detecting and analyzing audio signals involves using machine learning and signal processing techniques to extract meaningful information from sound. While there is no single universally accepted term, the domain is often referred to as audio signal processing, acoustic analysis, or audio AI. And this field addresses tasks like speech recognition, environmental sound classification, and anomaly detection. The technology relies on both classical signal processing methods and modern deep learning techniques. And these are some AI use cases for audio detection. So we've got speech recognition by converting spoken languages into text. For example, ASR systems like Deep Speech or Caldi. Then there's audio classification, identifying specific sounds, environmental noise like alarms or bird songs. Acoustic anomaly detection, identifying unusual patterns in audio, such as machinery noise deviations indicating failure. And voice authentication, verifying a speaker's identity. Now these are some Python tools and libraries used with AI audio. Librosa, audio analysis and feature extraction. PyDub, audio manipulation. PyAudio, this is for real-time audio stream processing. And WaveNet, which is high quality speech synthesis and audio generation. And finally, pre-trained models offered by libraries like Hugging Face or OpenAI. And that's it for this video. That was a high-level overview of artificial intelligence and the common terms used in AI, so the different areas in AI, and examples of Python tools to enable AI applications.
Welcome back to another video. In this video we are going to have a look at Python coding best practices. So although Python is a favorite amongst developers for its simplicity and readability, writing Python code effectively goes beyond syntax. It's about maintaining clarity, efficiency and scalability. So here are 10 essential Python coding best practices. The first one is about writing readable and Pythonic code. Pythonic code is code that follows Python's conventions and leverages its strengths. So here are some ways how we would achieve this. With variables, functions and classes should have clear descriptive names. For example, instead of x and y, we should opt for user_age or calculate_total. So this way names are descriptive and other developers know the purpose of these variables, functions and classes just by having a look at the name. Next we have follow PEP 8 guidelines. So this is Python Enhancement Proposal 8 and it's a styling guide for Python code. Some key rules include indentation with 4 spaces. Do not use a tab, use 4 spaces. Line length should be limited to 79 characters and use blank lines to separate logical sections of code, so you can easily identify the different sections of the code. So these are the three basic ones, but PEP8 has other ones as well, like imports. Place imports at the top of the file. Use separate lines for each module. So when you do an import OS or an import sys, you place these at the top of the file. And you should group imports as well, like the standard library, third-party libraries, and local modules. Group them together. Then there's naming conventions as well. So variables, functions, and methods use snake case, which is using each word separated by an underscore. However, with classes, we use Pascal case, so we capitalize the first letter of each word. So my list with a capital M and a capital L for list, where a variable, function, or a method would be my underscore list. And for constants, use all caps with underscores. And for private members, use a prefix with a single underscore. You should also avoid extra spaces inside parentheses or brackets. So we can see in red, using the correct way, we have no spaces before 1 and after 3, whereas if I did it incorrectly, we do have spaces before 1 and after 3. And in the next example on the right, we should be adding spaces around the operators and after commas. Moving on to comments. So you should use comments to explain why a decision was made, not what the code does. And for block comments, use hash with a space at the start of each line. And use docstrings for modules, functions, and classes. And a few other guidelines are use is for comparison with none if variable is none. And avoid writing overly complex one-liners. You should always prioritize readability and use consistent error handling, so you're able to handle errors accordingly. Having a further look at what is PEP8. PEP8 is a style guide that provides specific rules and standards for formatting Python code. Its goal is to make code consistent, readable, and maintainable, especially in collaborative environments. It's about how your code looks and is structured, rather than how it functions. And here is an example. We can see the same code written twice. The one that is not PEP8 compliant, to start with, it's not using snake case for function names, because there should be an underscore between calc and area. So this should be calc underscore area. Then if we have a look at the white space around parameters, PEP8 advises placing a single space after commas in parameter lists. And base height should be written as base, comma, and then a space and then height. Because currently there is no space between the comma and height. So we can see the code at the bottom. First it's using snake case, calculate underscore area, and then there's a space between the comma and height. Next, placement of the return statement. So PEP8 recommends placing the return statement on a new line for clarity, especially in functions of reasonable complexity. So if the function is quite complex, it's recommended to place the return statement on a new line, while a one-liner might be acceptable for a basic, simple function. But always clarity is preferred. So where it's more clear, it's more preferred. And the last one is spacing around operators. PEP8 specifies including spaces around operators like star. So you can see base star height with no spaces in the non-compliant version. But the correct way is base space multiply space height. So there is a space either side of the multiply. Number 2, keep functions and classes focused. So here we adopt the single responsibility principle, SRP. And here we are saying a function or class should do one thing and do it well. So they should not be doing multiple different things. So the single responsibility principle is a software design principle stating that a function, class, or module should have only one responsibility or reason to change. So the code is more clear, it's more maintainable, and it's easier to test. And on the left we have an example of an SRP violation, and on the right we have a better approach to the same code. The function on the left, process and display data, combines two distinct responsibilities. The first piece is processing of the data, that's transforming the data by stripping white spaces and converting it to an uppercase. And the second is displaying the data, so printing each process item to the console. These are two separate tasks that could have different reasons to change, and this breaks the SRP violation. By combining these responsibilities, the function becomes harder to maintain and test. For example, testing the processing logic separately from the display logic is impossible without executing both parts. Now, refactoring code using SRP, which is the better approach on the right. So here's how you can refactor this code to adhere to the single responsibility principle. The code on the right, the process_data function, is solely responsible for transforming the data, and then the display_ function is solely responsible for presenting the data. So two distinct functions here. Each function now has a single responsibility, making code easier to maintain and test. Number 3 Python coding best practice is to use list comprehensions and generators. List comprehensions and generators are two powerful tools in Python for creating sequences. We can see some differences in the table between the two. So there's memory usage, execution, use case, reusability, and performance. And list comprehension stores entire list in memory, where generators generate values one at a time. So in terms of memory, list comprehension is efficient for small to moderate datasets, where generators are ideal for large datasets or infinite sequences. Execution list comprehension is immediate execution and creates a list, where a generator is lazy evaluation and computes values on demand. By the way, lazy evaluation refers to the technique of delaying the computation of a value until it is actually needed. So in Python, generators implement lazy evaluation by producing items one at a time, rather than computing and storing all items in memory up front. That's why they are referred to as low memory. So for typical use case, list comprehension is used for smaller datasets and reusable results, for example like numbers or strings, where generators are used for larger datasets like streaming of data, processing logs, or infinite sequences. For reusability, the created list can be used multiple times, but generators can only be iterated once, so you would create a new generator if needed. And the last one is performance. So list comprehension is faster for smaller datasets as all data is in memory, and generators are more efficient for larger datasets because they are more scalable. And list comprehensions and generators are considered best practice in Python because they embody Python's design principles of readability, simplicity, and efficiency. This slide lists some advantages of using list comprehension, but I'm not going to bother reading through this, but you can see in red the list comprehension code. So this code transforms a sequence of numbers into their squares in a single readable line. It generates squares from numbers 0 to 9. Since the range is small of 10 elements, using a list is efficient and allows for immediate access to all of these results. So a single line does it all. And I have a separate video on list comprehension. And then these are the advantages of using generators. So at the bottom in red we can see some code. This generator handles an infinite sequence without running out of memory because it yields one number at a time rather than attempting to store an infinite list. And the values are produced only when needed, making it highly efficient for scenarios where only a portion of the data will be consumed. And unlike lists, which are bounded by memory, this generator can scale indefinitely, making it suitable for tasks like streaming data or processing live events. Number 4 is to handle exceptions gracefully. And with this one, error handling ensures your program does not crash unexpectedly when something goes wrong. For example, without any error handling, if your code encounters an error, like dividing by 0, the entire program stops abruptly. However, with error handling, you can gracefully handle such issues and even recover from them. This will improve user experience and make debugging easier. Also, we should use the try except blocks thoughtfully. Using the try except blocks allows you to catch specific errors and respond accordingly, rather than leaving the program to crash. The example code in red shows a try block. So code inside the try block is executed. In this case, result is 10 divided by 0 causes a 0 division error because division by 0 is undefined. It shows the 0 division error exception is caught here. The program executes the code in this block. Print cannot divide by 0. And at the bottom is the finally block. Code in the finally block runs regardless of whether an exception occurred or not, and it prints execution complete. So why this is good practice is it prevents crashes, the exception is handled gracefully and the program continues to execute. it provides clarity by specifying the error type, the specific error type, zero division error. You're explicitly documenting what errors you're handling. And then the cleanup actions. The finally block is perfect for resource cleanup. For example, closing files or releasing database connections. And last but not least, avoid bare exceptions as they make debugging harder. If you're not familiar with bare exception, it is when you use except without specifying an error type. For example, bare exceptions catch all types of errors, even the ones you might not expect. And this makes debugging harder because you lose information about the actual problem. So use specific exceptions rather than the bare ones, and use finally blocks for cleanup tasks that you must always execute, and always aim for clear and maintainable code, documenting which errors you're handling and why. Here's an example of a bare exception. So you can see there's no specific error. So if there is an error, it just has the except clause. It will print an error occurred. But the preferred approach is to handle specific exceptions. So we can see we're using the zero division error and also the value error. And if we come across the zero division error, it will print cannot divide by zero. Or if we come across the value error, it will print invalid input. Number 5, leverage built-in libraries. So Python comes with a rich standard built-in library, so we should avoid reinventing the wheel if libraries already exist. And here are some examples of Python's built-in libraries. Use the OS for file and directory operations to interact with the operating system. Use collections for specialized data structures like dec or counter. Use iterative tools for efficient looping. So these are tools for creating efficient iterators, for example, combinations or permutations. Random, generate random numbers. And there's more as well. For example, math library to perform mathematical calculations. RE to work with regular expressions for pattern matching. Datetime handling dates and times. JSON working with JSON data, and so on. Now here is an example of importing the counter class. From collections, import counter. This imports the counter class from Python's collection module, which is used to count hashable objects like strings or numbers in an iterable. So step 1, we've got the input string, which is the text hello world. So we define a string containing letters and spaces. Step 2, apply counter. So we use counter to count occurrences of each character, and the character is text. So whatever we store inside the variable text, which is the first variable, and it's holding the string hello world in this case. And bear in mind the space is also treated as a character. So letter underscore count equals counter parenthesis text close parenthesis. This counts how many times each character appears in the string, and the output is print letter underscore count. And then we can see the counter. So it counts how many times each character appears in the string. So for example, the character L is 3 times. We've got it twice in hello, and then we've got it once in world. The next one is O, and we can see that 2 times. It's at the end of hello and the second character in world. Number 6, test and debug your code. So for this, we should write tests to catch errors early and ensure your code works as intended. And use Python's built-in unitest module. Unitest module is Python's built-in testing framework used to write and run test cases for code. So we import the unitest module. Then we have a class, test math operations, which is a subclass of unitest.testCase. This is necessary for defining test cases. Then we define the test method. So the method test underscore addition is named with the prefix test underscore, which is required for unitest to recognize it is a test. And then inside the parenthesis, we've got self. Then the third line, we have self.assert equal. In parenthesis, we have 2 plus 2, 4, which checks if 2 plus 2 equals 4. If the assertion is true, the test passes. Otherwise, it fails and raises an error. And also, we want to debug efficiently using the PDB module. The PDB module is Python's built-in debugger. It allows developers to set breakpoints, step through code, inspect variables, and identify runtime issues interactively. So I've got a dedicated video on the PDB module and how we would use this. It's useful for troubleshooting issues in Python scripts interactively. So the command python-m pdb and then your script, your file.py. This will launch the script with the PDB Debugger. So this is how you launch the PDB Debugger. Number 7 is document your code. Well-documented code is easier to understand and maintain. First, we should use docstrings for functions, classes, and modules. Docstrings, or documentation strings in Python, are special strings used to describe what a function, class, module, or method does. They are enclosed in triple quotes, double quotes, or single quote, and are typically the first statement in these structures. We use them because they provide a clear explanation of the purpose and usage of the code, making it easier for others to understand. We also use them because tools like Sphinx are able to extract docstrings to generate documentation automatically, and it's for standardized structure. So following conventions like Google style or NumPy, docstrings make it easier to maintain and scale your code base. In the code example, the triple quoted string in purple explains the function's purpose and structure. So with the code, this function calculates the area of a rectangle, giving it its length and width. It then multiplies length by width and returns the result. Then the actual docstring, so I've changed the colour into purple so you can see the difference. This describes what the function does. It calculates the area of a rectangle, and the argument section specifies what the function takes. Two float arguments, length and width. And the inline comments should only be used when absolutely necessary to make the code easier to understand. And then what it returns a float, the calculated area of the rectangle. So the command return length multiplied by width. And then there is provide inline comments sparingly to clarify complex objects. So with inline comments should only be used when absolutely necessary to make code easier to understand. For example, if your code is self-explanatory, additional comments are unnecessary. So you should use comments to explain parts of the code that might be hard to understand at first glance, and keep the comments brief and relevant. So you should always prioritize clean code over comments. Number 8, version control your code. So for this, we can use Git and GitHub to track your changes and collaborate. But it does not have to be Git and GitHub. It could be other version control software and collaboration tools, but Git and GitHub are the most popular ones out there today. Git is a free open source version control system that tracks changes in your source code. Git tracks changes to files over time. Git allows developers to revert to previous versions of the code base if required. Where GitHub is a free open source cloud-based platform that hosts Git repositories. GitHub enables real-time collaboration and can be accessed from anywhere globally, facilitating effective teamwork. So you should regularly commit small and logical changes. You should also write meaningful commit messages, fix bug in data processing instead of update file, so you understand what each commit was taken for. The commits are the snapshots. And I have a dedicated course on Git and GitHub. So it will take you right through how to use Git and every step of the way, how to commit changes, how to revert changes, etc. But here's a basic workflow of Git. So Git has 3 different areas: the working directory, the staging area, and the local repository. And when we make changes in the working directory, we use git add to add it to the staging area. So it's a 2-step process. Once it's added to the staging area, it's ready to be reviewed. And if you are happy with the changes, you can commit them using the git commit command, which will commit the change into the local repository. It will take a snapshot of the change, and then you can push and pull the commits to the central remote repository, GitHub, so that your team can access those changes as well. So GitHub is a cloud-based service that hosts these Git repositories, so all your team can get access to all your projects and files. Number 9 is to optimize for performance. So for this, be mindful of performance bottlenecks, meaning identify parts of your code that are inefficient or consume a significant portion of the program's execution time, because these inefficiencies can slow down your application, especially in areas that are executed repeatedly or operate in large datasets. And here are some examples. Nested loops, so these scale poorly with the input size, and these can lead to something called quadratic time complexity. Unnecessary recomputations, where, for example, if a function does not depend on I, you can instead move the computation outside of the loop. Slow algorithms, sorting a list repeatedly instead of maintaining a sorted list, and input-output operations in loops. So opening and closing a file repeatedly in a loop is costly. Instead, you should open the file once outside of the loop. Next, you should use timeit to measure execution time. The timeit module is a Python utility used to measure the execution time of small blocks of code with precision. It helps determine which part of your code is slower or more efficient when compared to alternatives. So we import timeit. This imports the timeit module, which is used to measure the execution time of small code snippets. Then we have timeit.timeit. Sum range 1000. This is the code snippet you want to measure. It calculates the sum of the numbers from 0 to 999 using range 1000. Number equals 1000. This specifies how many times the code snippet should be executed, 1000 times in this case. Timeit will run the snippet 1000 times and return the total time taken in seconds. And then we print the output, which displays the result, which is the total time in seconds for executing sum range 1000 times. And at the bottom we have prefer efficient data structures. So set over list for membership checks is an example. Because different data structures in Python have different levels of efficiency for certain operations. So the example set over list for membership checks, this is because a set is highly optimized for checking whether an element exists, membership test, whereas a list is slower for the same task. So use the right data structure for the right task you are performing. So this is why you would use set when you are frequently checking for elements' existence, as it's much faster than a list. And finally, for number 10, keep learning and refactoring. The first part, learning continuously. The Python ecosystem evolves with new libraries, frameworks, and best practices. So staying updated ensures your code benefits from performance enhancement in libraries, new features such as syntax improvements or built-in functionalities, and community recommendations which evolve over time. The next one is refactoring. Refactoring is the process of improving code without changing its functionality. The goal here is to make code easier to read and maintain, eliminate repetitive patterns or unnecessary complexity, and incorporate new learnings such as better algorithms or cleaner syntax. So in summary, final words for coding best practices. To excel in Python development, follow these key principles. Write readable code using meaningful variable names, comments, and adhere to PEP 8 for consistency. Focus on simplicity. Solve problems with the least complexity, leveraging Python's built-in functions and libraries. There's also one that I missed. Stay dry, don't repeat yourself. Reuse code through functions and modules. Test your code, write unit testing and leverage testing frameworks like PyTest and ensure reliability. Keep learning and keep adapting. Refactor your code regularly, stay updated with the latest developments and learn from the community. That's the end of Python coding best practices. Thank you for watching.
Welcome back to the last video on the course, and in this video we will have a look at working on small Python projects and exercises. So now that you have learnt the basics of Python and have an understanding of the core concepts, the next steps will be to work on small projects and exercises, so to get some hands-on experience. And for this there are plenty of resources out there, so let's go over some of them now. So the following lists are some of the best platforms for projects and exercises, and this section covers interactive coding platforms. So these are online platforms where you can write, test and run Python code directly in the browser without needing to install anything. They provide immediate feedback on whether your solution is correct, making them great for learning and practicing coding problems. And the first one is LeetCode. So this focuses on coding challenges, especially for job interviews. And for some of them I've got the link to the website as well. Then we've got HackerRank, which offers structured Python exercises on different topics. Next is Code Wars, which uses a gamified approach where you solve problems to level up. So again, for these, if you want to practice Python challenges interactively without setting up anything on your computer, these platforms are perfect. And the last one is Project Euler, which focuses on math-based coding problems. The next set of resources are for Python project ideas and practice sites. So these are a collection of beginner-friendly Python exercises. And the first one is actually called Python Exercises. So this is beginner to advanced Python exercises. Then there's Practice Python, which is a collection of simple practice problems. Next is Real Python Projects, which is free Python projects with explanations. And the last one is Awesome Python Projects on GitHub. So you can download this from GitHub, which is a collection of open source Python projects. And the last section is for full projects for hands-on learning. And this includes Kaggle, which provides datasets and coding competitions for data science and machine learning projects. And then the last one is Free Code Camp, which offers full Python-based projects, often for web development or automation. Now, speaking of web development and automation, if you wanted to get hands-on on a specific path, I've got some resources for that as well. So we've got web development with Python using Flask or Django, and we can see the skills to learn here. And then there's some exercises, so to-do list app, simple blog, and a weather app. And you can see the resources on the right hand side. The to-do list app uses Flask or Django with a database to store tasks. The simple blog, you can create a basic CRUD, create, read, update, delete web app, or you can fetch real-time weather data using an API and display in a web app. For Python automation and scripting, again, you can see the skills to learn and the resources on the right hand side. So for this, we've got File Organizer, which is to write a script to organize files by type, or you can automate Excel reports with OpenPyExcel. And the third one down is Data Science and Machine Learning. So again, you've got the skills to learn, and for this we can work with a data visualization dashboard. So we would use Matplotlib and Seaborn to analyze data sets, or the CSV data analyzer. For this, read CSV files and generate reports. And the last one, Basic Sentiment Analysis. So use TextBlob to analyze Twitter or product reviews. Now moving on to the last two paths. The first one is cybersecurity and ethical hacking. And the first one is create a secure password generator, or we can scan open ports on a target machine using Socket, which is the port scanner. And then there's simple key logger, which captures keyboard inputs. And a small disclaimer for that, for ethical use only. And the last one is the game development with Python. So we've got tic-tac-toe, basic 2D game logic. Then there's snake game, which is a classic snake game with Pygame. And the last one is Flappy Bird clone, which you can recreate Flappy Bird using simple physics. And that brings us on to the end of the Python fundamental course. And with that being said, congratulations on completing this Python course. Hopefully you've built a strong foundation in Python programming, covering everything from variables, data structures to functions, object-oriented programming, file handling, and even Git for version control. Not to mention as well regular expressions and debugging with Python PDB, as well as Python coding best practices. So hopefully you've taken a few things away from the course. And most importantly for myself, I'd like to thank you very much for following my course. All the best in your Python journey. Thank you.